Hello, and have we hit start broadcast?
Yes.
We are now live. Now I see the little live yellow button in the upper right-hand corner. Welcome back. Thank you for following us from one link to another. For those of you just joining us, this is the CosmoQuest 36-hour Hangout-a-thon. We are spending 36 hours with three simple goals: to talk to some really awesome guests, to work on marking 36,000 science images of the Moon, Mercury, Mars, and the asteroid Vesta, and to raise $36,000 to support science to help us get through the rest of this year. We need your help to be successful. We need your help to help us map other worlds, because we have more images than we can handle on our own. And we need your help finding the dollars to, well, keep our servers turned on. To give you some comparisons, we were talking with some folks earlier about space tourism, and it made me think there are people out there who've spent $200,000 to reserve themselves seats on Virgin Galactic, which is awesome. But that ticket that they reserved, that would pay all of our salaries this year here at CosmoQuest. And can you help? There's a thing of potato salad. It got $55,000 on Kickstarter. Aren't we more awesome than potato salad? I'm not sure, because, well, so far the potato salad is earning more money than I am. Help us out. Share our links. Do some science. Donate what you can. All of it works together. No effort is too small. And to help incentivize the process, some awesome people have donated some awesome things. We're going to be giving away some Surly Amy pendants. We're going to be giving away 5 children's books. Your Place in Space by Sarah Wills. We're going to be giving away 2 $200 gift certificates to iTelescope. We're going to give away 2 chances to get indigo night prints like this one that allow you to get a visualization of what the sky looked like over a city that mattered to you on a date that was important. We have 3 meteors. And to the person who donates the most this hour, we're going to give, well, dragon eggs. This is part of a new tradition that was started last year that, like in the book Aragorn, the eggs travel from person to person. And if they hatch, you have dragons. Most likely they won't. But you are part of the tradition. Your name will be engraved on a plaque. The person who gives the second largest amount gets this awesome lightsaber that was created by Tim Legauer, a props maker and costumer that we adore. And no matter what you give, no matter how small, no matter how much science you do, and again, science and dollars are being treated the same when it comes to our prizes. No matter what you give, no matter what you do, it all matters. Now, joining me this hour are 2 of my favorite humans. We have Mike Simons, who is the director, the president supreme, I think is more of your title, of Astronomers Without Borders, an organization that is helping us celebrate the fact that we are one planet, one people sharing one sky. He is going to take over hosting duties for the next 2 hours, letting us get breakfast and not eat on camera, which is always the joy. Joining him is Laura Beecher from the International Observe the Moon Night program. She is someone from the lunar and planetary community who's done awesome work. And thank you both. And Mike, I'm going to start sharing the new link while you start getting this new hangout going. Oh, Mike can't hear, so apparently I'm still talking for a few minutes, and that is good. So let's see we have a back channel that we're working on. Okay, they're going to go out and they're going to come back in, and hopefully this will work.
I can hear you, Mike. Can you hear me?
I hear you, Laura. Oh, technology problems sometimes happen.
Can you hear me, Mike?
Can you hear me, Laura? This is the strangest problem I've ever seen before, because I can hear both of them. I don't know if either of them can hear me or if either of them can hear each other.
Can you hear me, Mike?
Open the producer box, up one. Adjust the volume for both of them all the way up. Can you hear me, guys?
Mike, can you hear me?
This is highly confusing. I think this is the point where, can you type a message in a text box and show it on screen telling them that we can hear them, and telling the audience we can hear them, I guess. Okay, that works too. I'm sorry, folks. These sorts of things sometimes happen. We were in a situation a couple of years ago where we had on an Apollo astronaut who shall remain nameless, and we were talking about the overview effect, the way they've been up on orbit, and this very lovely gentleman could not get Google Hangouts to quite work, and it was one of these moments that made us realize that maybe it's easier to fly an Apollo spacecraft than it is to well, use Google Hangouts. So let's see it looks like we're sending them the links one more time, and hopefully we'll be able to get them in and get everything working. Yeah. So while we're waiting for them to come back, just to review where we're at, we've had $18,175 in donations. We're trying to hit $36,000 by the end of today. We're now going into hour 24. We started this thing yesterday, 24 hours and 17 minutes ago. So we're a little bit behind where we'd like to be. In fact, but you can help us catch up. You can help make the difference. You can help us get the word out and maybe find that one person who can just say, oh, I can fix this. Astronomer Katie Mack, Astro Katie, where she talked about how she got interviewed for an article in The Economist, and it was all about how we put neutrino detectors, dark matter detectors, underground in mines. And she got a letter from a gold mine owner saying, hey, do you want to do science in my gold mine? And a partnership was formed. You never know what your science is going to make a difference. I see all of you out there, they're tweeting. I see Guido is the one that came out most recently. Below that is Noel Rupenthal. Below that is Todd Dietrich. And now we are going to just keep asking, can you support us? Can you help? And two people who are going to help me hopefully go get a warm breakfast are Mike Simons and Laura Bleacher, and we're going to check, can you hear me?
Yes, I can, and I could even hear you mispronounce my name again, Pamela. How long have we known each other? Mike Simmons, thank you.
I can only hang my head in shame and at least say I'm consistent.
Mike, can you hear me this time?
I hear you fine, Laura. It's good to be able to talk to you. Here we are.
All right, wonderful.
So I'm handing things over to Mike. I'm going to finish pursuing my attempt to post the link for this as many places as I can, and then I'm getting breakfast. And these two awesome people who I adore and didn't hear me say earlier the awesome things that they do for Astronomers Without Borders and for International Observe the Moon Night, I'm going to leave them to science you. Now, Mike, you have one goal. Your goal is to do better than Fraser did while he was on as host, because when Fraser was on, that's how we got these $5,000 behind where we need to be. But when Nicole and Georgia were on yesterday, they got us $2,000 ahead. So are you Nicole, or are you Fraser? I know you're Mike, and you'll be your own version of awesome, but let's see which side of that line you're going to be on.
Well, I will do the best I can to get all the people watching from the middle of the Pacific Ocean right now, and maybe waking up on Sunday morning. We'll see what we can do. But yesterday when I tuned in, Pamela, the first thing I saw was that you had a goal you had to reach right away, and I got so upset about you not getting there. I jumped on and donated somewhere between $100 and $1 million. I won't tell you which one.
Thank you. It's things like that that matter so much. We can do this together. So let's raise money for science, and let's do science education. It's all part of a whole. And part of my whole right now is just sharing links. So
very good. And
have at it. The hangout's yours.
I still have to understand how you can stand for hours and hours drinking coffee the whole time. Are you hooked up to a kidney dialysis machine or something?
No, we periodically go to video and take a 10-minute break.
Okay, good. I'm glad to know that. I hope there's a video standing by sometime. But I only have 2 hours, not 36, so very good. Take a break, Pamela. It's very well deserved. I hope you can get a nap, too.
Thank you so much, Mike.
Okay. So, Laura, welcome.
Yeah.
And this is a little bit last minute, and 36-hour things like this. This is not normal. Normal people don't. So I have not had a great chance to catch up on everything that you do. International Observe the Moon Night I know very well, and so on. So that's what we're going to be talking here. But also Dream 2. So tell me, where do you stand with now? Dream 2 is. And this is clearly was named entirely for the acronym because it's too good to be a Dynamic Response of the Environments at Asteroids, the Moon, and Moons of Mars. You know what? So let me ask you about this first because I want to know what that means. And what is that about? This is on a NASA page, Goddard Space Flight Center. Who's doing what here?
So the Dream 2 team is part of one of NASA's virtual institutes. NASA has 2 virtual institutes. One is the NASA Astrobiology Institute, and one is the Solar System Exploration Research Virtual Institute, or SERVI for that acronym. And so the Dream 2 team is one of the teams of this virtual SERVI institute for NASA that is looking at the moon and asteroids and the moons of Mars. It's a follow-on to a team that was funded as part of the previous NASA Lunar Science Institute. So this is kind of the second group of, or second round of funding for this particular group of researchers for DREAM. So what the Dream 2 team is trying to do is they're looking at the environment around the moon, and how the sun affects the environment around the moon, and also asteroids and the moons of Mars, which we think are captured asteroids. So what they're doing is they're doing a lot of modeling. They're a modeling center. They're a data validation center. They use some of the LRO data, especially the LAMP instrument data, the recent Lunar Atmosphere and Dust Environment Explorer spacecraft data, and then also the Artemis data. Artemis is a series of spacecraft that are currently in orbit about the moon right now. So looking at how the solar wind affects the surface of the moon and the exosphere of the moon, looking at how the surface of the moon and the dust on the surface of the moon gets charged, thinking about how that might affect future astronauts. Should we go back to the moon, or also with some of our robotic explorers as well, looking at the, especially the unique charge environment that you get near the poles of the moon, where you can have permanently shadowed regions within craters at the poles, and you get a really unique charge environment there. So that's what they're doing. It's
Okay.
it's pretty interesting.
It
Yeah,
is.
it's a huge team spread out across the country.
Well, that's something I can see. It's a virtual center, which means basically you can't get people together in a meeting in one room. So let's translate a few of these things into English too, for some people that don't know.
Okay.
A lot of people think that the moon is someplace where we sent people in the 1960s and 70s, and we haven't done anything since then. But there's a lot going on at the moon. One of the things you mentioned is LRO, which is a Lunar Reconnaissance Orbiter in orbit around the moon. How many spacecraft are there at or on the moon right now doing actual science?
Well, currently we do have the Lunar Reconnaissance Orbiter, which has been in orbit since 2009. We also have the twin Artemis spacecraft right now. And those are our main two American assets around the moon. There are plans by other countries to have future missions to the moon. There are groups within NASA that are proposing some landers specifically to look at a large impact basin at the south pole of the moon called the South Pole Aitken Basin. There's also a group that's working on a mission called, I want to say Flashlight, if I can remember correctly. I apologize. It's actually a CubeSat that would be going to the moon and looking in some of these permanently shadowed regions again, which we have been studying the last few years with missions, but still trying to get a better grip on what water ice might be there in these permanently shadowed regions or other regions near the poles as a resource.
And
Um,
CubeSats, for those who don't know about those, are usually associated not with NASA, but with universities, other small endeavors. These are tiny little satellites. They're, what is the size? They're something like 10 inches on a side or something like
yeah, basically, yeah, they're literally about that big, very
that. So
tiny.
NASA is getting into the CubeSat business as well. So there's a whole variety. Tell us, there are two Artemis telescopes. I'm sorry, astronomy focused. There are two Artemis spacecraft there. Tell us why are there two of them? What is that mission doing?
That's a good question. So Artemis is NASA occasionally likes to kind of repurpose spacecraft for new science once they've kind of gone through their main life cycle and accomplished what they were going to accomplish. And Artemis is one of those. I believe the mission when it was kind of overseen by our heliophysics division within NASA was called Themis, if I'm not mistaken, and now it's transitioned over to Artemis. And so the two spacecraft, they're not in a very close orbit around the moon like the LRO spacecraft. They're actually much farther out in space because they're kind of swinging through the solar wind and then back around through, I believe, what we call the wake, which is the area. So if you've got the moon here, you've got the solar wind kind of coming in this way, then you end up with this really interesting area behind the moon where the solar wind's kind of going up and around the moon and then eventually kind of coming back into it. So the Artemis spacecraft are way out here kind of looking at this region of heliospheric space around the moon.
So this and the solar wind, for those who don't know, is material, charged particles, gas, and with magnetic field bubbles and so on, a very complex outflux from the sun itself. Essentially, we and the moon are inside of the sun's most outer atmosphere, and we see that through aurora and through interruptions in communications and things like this. So when it goes past Earth and when it goes past the moon, there's actually a wake on the other side where things are happening, and that's being studied by Artemis as well.
Yes. Mm-hmm. Yep.
Okay. And now is that in some way analogous to the stereo spacecraft studying the sun? They're looking at the sun from two different places and able to see different things. So they work together as this data combined, sort of.
Yes, exactly. Yep. They work together. Yep.
So we've got two eyes on that as well.
Yep.
Now, I can't believe. Hold on just a moment here. I'm sorry, my time program when I had to reboot automatically defaults to Big Ben telling me what time it
That's
is.
okay. And I saw that my colleague Andrea had popped on for a second, but I don't see her now.
Yeah,
Andrea, are you there by
sort of come
chance?
and gone. Let's see if there's anything here. Maybe somebody in the back room will let us know through
Okay.
the chat box what's going on. Oh, Andrea had a well, I guess she got the answer. Andrea asked if we could
Mhm.
hear her, and since we didn't reply, I guess she figured out that was a no.
Okay. Hopefully she'll
So
hop back on.
probably doing the same thing I had to do and rebooting it again. So this is all great stuff. There have been other countries that have gone to the moon as well. India, with their
Mhm.
first lunar mission, and China famously actually landed on the moon for the first time in a very long time. Are those missions contributing to our overall understanding? And I don't know if there's a lot of cooperation between NASA and China because there are some restrictions on that placed by Congress. Unfortunately, most of us would like to see science be politics and boundary free, but it doesn't always happen. So where do those fit in with what NASA is doing as well?
Yeah, so there's actually been quite a bit of collaboration between the Indian Space Organization and NASA. You mentioned the Chandrayaan-1 mission that was in orbit around the moon for a while. And there was actually an instrument that was contributed to that mission called M-Cubed, the Moon Mineralogy Mapper. And that was a NASA-contributed instrument. And that data is still actively being studied by scientists. It's given us a really wonderful wealth of information about just this whole water story on the moon, and how for a long time we thought the moon was bone dry, and it is in a lot of respects. There aren't lakes and oceans on the surface of the moon like we have here in our beautiful Earth, but we're starting to get a better understanding of the possible presence of water ice in different places on the moon, and not just maybe in permanently shadowed craters, but we're also seeing indications of it elsewhere near the poles. And so that's really causing scientists to kind of go back and rethink some of their ideas about how the moon formed, how any water ice that's present on the moon, was it actually, most of it delivered to the moon through impacts throughout the moon's history, comet impacts, for example, or could some of the water that we're now seeing indications of mixed into the lunar soil, could that actually have been water that was, there in situ when the moon originally formed? So that's really, and then that kind of gets at the larger question of the process of how we think the moon actually formed. So there's a lot of really interesting science that that is coming out of the Chandrayaan-1 Indian mission and that Moon Mineralogy Mapper instrument, and then that being combined with again the amazing data that we're getting from LRO and still the research that's going on the lunar samples that were returned by the Apollo astronauts. So one thing that I definitely like to stress to folks is that just because we visit a place one time doesn't mean that that's the the end all be all now of visiting there and what we have to learn. There's still so much left to learn, and as new instrumentation is developed, as we have new technologies, as we have these data sets that are we're able to combine both samples that have been collected as well as this contextual information that's provided by spacecraft such as LRO, combine that with high resolution images. We're really just continuously learning and refining our ideas, and coming up with new questions and new things that we want to learn about and test. So science is a continual evolutionary process.
It is.
And I see my colleague
Well said.
Andrea now,
Yes,
so I want
Andrea is
to
here.
wave to her. Yay!
So we'll introduce Andrea, and then I'm going to ask you the big question because we're still learning about Earth, and we will continue to through all of our time. So there's plenty to learn about the moon. So I'm going to ask you the big question: why do we do it? But let's introduce Andrea here first, and you'll get a chance to weigh in on that as well, Andrea. And Tell us who you are and where you're coming from. I'm sorry I don't have everything in front of me. This was last minute.
No problem. So my name is Andrea Jones, and I am an education specialist with the Planetary Science Institute based out of NASA's Goddard Space Flight Center, and I work in the Solar System Exploration Division with Laura, and I am Director of International Observe the Moon Night. And right now I am learning all about how it is very difficult to connect with places with poor internet service, as you know, other places around the world have. So, you know, this is helping me to understand how to better serve those who don't live in high internet areas.
Well, yeah, and as president of Astronomers Without Borders, I've been doing this for many years, so I know very, very well what it is you're going through, and we can talk about that later sometime. Maybe I can help a little bit. So, and Laura, you are the education. Well, you know, I'm looking at Dream 2, and you are the well, give us your title here.
Okay, I'm the Education and Outreach Lead for the Solar System Exploration Division at NASA's Goddard Space Flight Center in Greenbelt. So in that role, I work closely with Andrea on the education teams for several of the different planetary science missions that Goddard is involved in or leads, such as the Lunar Reconnaissance Orbiter, and then also Dream 2, again, this virtual institute, which happens to have a team at Goddard. I help lead the education efforts for that.
Okay, and so here comes the big question then. Why do we want to keep studying the moon? I mean, we know why we want to study the Earth, although some people could even question, well, why study at the bottom of the ocean? We're not going to go there. But we know with everything that we're doing, we're learning more about our home. And we learn things that we don't expect to learn. There are things to know that are helpful that we don't know ahead of time unless we explore. So we have all this going on at the moon. Why do we do that?
Do you want me to go first, Laura, or do you want to go?
You can hop in. I'll give you a chance to talk while your internet connection seems to be working.
That's probably a good idea. So I feel like there are a lot of different reasons for this. One is definitely to better understand the Earth, which is a great question in general. We always want to know, you know, who are we? How did we get here? Where do we come from? Where are we going? And Laura's heard me give this analogy so many times, but I feel like it's trying to understand a tree in the forest. And if you really want to understand a tree, you can't just study the tree. You have to look at, you know, the rainfall and the other animals around and the other trees around and the sunlight that comes in and the nutrients in the soil and everything that affects the tree helps you better understand the tree. And I feel it's that way with planetary science. If you want to understand the Earth, you have to look in our neighborhood. You have to look at what's around us, what's similar, what's different. What is the family, and you know, where did the Earth come from, and what are its siblings like, in order to better understand our planet. And you know, the Earth is very special. It's very unique in the solar system, in the universe. We have no idea exactly how it came to be this perfect for us and for all other life on Earth. And you know, if we are going to keep expanding as a species and as a race, we really may want to expand beyond our Earth someday. And so the better we can understand other planets and understand how our Earth got to be this way, the more insight that gives us into potentially going past our Earth. But I think the sense of exploration that is inherent in us as, you know, humans, we've always wanted to cross oceans and climb mountains and pursue mysteries, and I feel like planetary science is a way to do that. And I also, as one other thing, you know, the more that we study the planets, the more we have to develop technologies to do that. And if you like things like internet, which are difficult to access, you know, here, but if you like things like that and iPhones and Velcro and all of those things, space exploration really drives technology development on an amazing level that is beneficial both to spacecrafts that explore the solar system and beyond, but also to people here on Earth who can take advantage of those technologies. So it really drives a lot of that as well. And I think those are just a few of the reasons I feel like we could have a whole conversation about this.
We could.
But Laura,
yeah.
I'll let you weigh in as well.
Yeah, I've been answering questions like that for 40 years, and I know there are a lot of arguments for it. The one that seems most compelling to me, and especially in studying the moon, is that we are finding out more and more all the time how unusual the Earth is. We know that Venus and Mars had the potential maybe to form uh, environments that are not as hostile to life as they are, at least to our life. And we don't know what happened to them. We're finding out Mars has gone through some major changes, and we don't know why. And in fact, the moon's existence has something to do with the conditions on Earth being what they are. If it had not formed, maybe we wouldn't have been here in the first place. And as we look out to other solar systems and other stars, finding planets our size is really difficult. But we've found enough and learned enough to know that finding a place like ours is not that easy. So.
Yeah, and I also, just as one other thing, I really like how scientific exploration brings people together in, ways that are, congenial and friendly and just purely driven by curiosity and wanting to find out more. And I like how that unites people together in a great way, I think. So I think it crosses borders and boundaries and all kinds of things in a way that is really wonderful.
Absolutely. Well, that you just stated the reason for the existence of my organization, Astronomers Without Borders. So, thank you for that plug there.
Sure,
And
sure, absolutely.
it really does work, but I can't get started on that. I'll spend the rest of the hour talking about that. So, Laura, do you want to weigh in on why we do this? What are we learning from these science missions? You've thrown out a lot of science there. How is that helping us to understand our own planet and our environment?
Well, those are big questions, and I don't know if I have too much more to add to what Andrea said and how she eloquently put it all, in terms of just so many ways that exploration, continual exploration, is helping us better understand our planet, better understand our solar system. Again, the technologies that are created, the jobs that are created, the way it brings us together, the excitement that, I think one thing that I really enjoy in this job is that, talking about space just excites people. As Andrea said, it ignites their natural curiosity. It's so fun to help educate students and help educate teachers who are then going to educate students about science through the lens of NASA and through the lens of space exploration. So I think that's also something that's, a really nice thing that our space program really brings to the public is this excitement that can be used to fuel investigation and understanding into basic science. In terms of what we're learning about the Earth by studying the Moon and by studying Mars and Venus, it's so much. It's hard to even put it all into just a few statements. One mission that's not moon focused, but that I did want to bring up because it really does kind of relate to this overall topic we're talking about, is the MAVEN mission, which is currently in orbit around Mars, and that's the Mars Atmosphere and Volatile Evolution mission, which went into orbit around Mars this past fall, and it's basically looking at climate change on Mars. And thinking about, how did Mars go from this potentially warmer place where we know that there were at different periods of time standing water and flowing water on the surface, how did it become this dry, barren place that it is today? What were the steps that happened for it to get from a place that maybe was more Earth-like in the past to what it is now? How long did that take? What similar steps might the Earth take in the future? So it's, your question is really big, and it's kind of individual, I think, based on which mission or which planet, that we're talking about at any one time in terms of the individual lessons that we're bringing back to Earth to help us better understand our own planet.
Absolutely. Well, we get this, and I've heard this, like I said, for 40 years, 45 years. I shouldn't reveal that on air like this because it'll belie my youthful appearance. But people say, well, we have people starving on Earth. Why should we be spending money on space? And the fact of the matter is, we have a lot fewer people starving on Earth because of what we are doing in space. Not necessarily always looking outward, though that will always benefit us, but NASA has a tremendous number of spacecraft in orbit around the Earth. Looking back, it's helping in many, many ways as well. So there is an awful lot that would happen if we didn't have our space program. Now, I want to move on to what people can do to get involved in this as well, because you have a big event that's held every year that people can take part in. But before I do that, because this is a fundraiser for CosmoQuest, this 36-hour hangout-a-thon that so many of us are taking part in, I want to mention that CosmoQuest is the place for citizen science. You can go to the CosmoQuest site, cosmoquest.org, and you can take part in mapping the moon and other planets. This is actual data collected by the spacecraft that needs the help of a lot of people to take a look at what the data is there to make sense of it. We now have the ability to collect enormous amounts of data, but not the ability for the scientists and for NASA and so on to make sense of it all. So citizen science is not just something for you to do in your spare time. It is very important research, and the people we're talking to on this hangout-a-thon are doing their best to learn what we can from this data. So you can go there and take part, and there's a race going on right now, as I understand, to see which planet is going to get the most mapping done during this hangout-a-thon.
Mm-hmm.
But the other thing that you can do, should do, for whatever amount you can, is to go to the cosmoquest.org site and click the donate button. And just like citizen science, this takes a lot of people. If one person can come along and pay for CosmoQuest budget for the year, that's great. It's not something you can count on. And as our guests here know very well, the outreach budget for from NASA and NSF for outreach for organizations like cosmoquest.org has gotten a lot tighter. So your help really is needed. Now, I mentioned that I run an organization called Astronomers Without Borders, and we need to do the same thing. So why am I on here asking people to donate to a different organization? Well, Laura mentioned it as well. We work together. We are always all in this together. Maybe it was Pamela that mentioned earlier, actually, before we started, but it doesn't matter because we all feel the same thing. We work together. CosmoQuest supports our organization. We support CosmoQuest. And I've known Pamela a long time, and we've done a lot of work together. None of us can do it alone. Just like having multiple space missions in many different countries doing the work, we are all in this together, and we need each other's help. So this is the time to support CosmoQuest. And if you have anything you can donate, I won't say how much. It may be a very small amount for you. You may have the ability to do more. Whatever it is that makes you feel good that you donated to support this kind of organization. Because without you, and you hear this all the time, without you it isn't possible. Well, that is literally true. I'll tell you, I'm in the position of knowing that. We can't do it alone. So please donate and support science. Especially for citizen science, for people like you. And so, Andrea, I wanted to talk to you again, and now I don't know if Andrea is there. Andrea, do you hear me? I think Andrea just dropped off again.
Oh, uh-oh.
I'm seeing a little circle that doesn't look like Andrea at all. Oh, there she is. Andrea, do you... Well, it's not quite working. Andrea, do you hear?
Yeah, she's still showing up on my end, but she's frozen. So
frozen, yeah. So I think she's temporarily out of service.
Yeah.
Laura, it's going to fall to you.
Okay.
And that is International Observe the Moon Night.
Mm-hmm.
This is not just about collecting more data. This is about engaging people.
Right.
Which is what I do, so I want to hear more about this. So tell us the origin and the what happens there and how people can get involved.
Yeah, so we've already mentioned the Lunar Reconnaissance Orbiter, LRO mission, which launched in 2009 and is still in orbit around the moon. And at the time when LRO launched, there was actually another mission that launched on the same rocket called the LCROSS mission, or Lunar Crater Observation and Sensing Satellite. And so there was a lot of excitement about these two missions across the country. LRO was built at NASA's Goddard Space Flight Center in Greenbelt, Maryland, and LCROSS was built at NASA Ames Research Center in California. And then, of course, the two missions had a lot of partners from across the country that were involved with the development of the instruments and the spacecraft. So there was a lot of public excitement. So we did a big event around the time of the fall. So LRO launched in June. It only takes 3.5 days or so to get to the moon and get in orbit around the moon. But later in the fall, it took LCROSS a little bit longer, just based on the orbit that it had to get into, the special orbit that it was aiming for to allow it to eventually impact the south pole of the moon. So around the fall of 2009, we did just a big event called, we're at the moon, back at the moon, back to the moon. And it was a lot of fun. There was a lot of public interest. And so it got some of us thinking, well, this was amazing. Like, there's all this public interest. How can we kind of keep this going, and get people to keep looking at our beautiful neighbor that's up there all the time, thank goodness, but that we're so busy going about our daily lives, we just don't maybe pay it as much attention as we could or we should, and especially because we knew that with these two missions, with LRO and LCROSS, that we were going to have all this wonderful data, these amazing images coming back. So how could we keep the public engaged throughout the lifespan of these missions to, let them know the great things that we're learning, to get them to just learn more about the moon and be able to appreciate it in general, understand what they're seeing when they go outside day or night and see it up in the sky. So we came up with Observe the Moon Night, or it was going to be National Observe the Moon Night, actually. And then, we started kind of moving forward, making plans on that. And then, we had all of this international interest, hence the name International Observe the Moon Night. So we did the first International Observe the Moon Night in the fall of 2010. And we've done one each fall since then. And the next one, which will actually be our 6th annual International Observe the Moon Night, is taking place on September 19th this year. So the date changes a little bit each year based on several different factors. We try to do it in the fall so that it's not too hot, not too cold for most people. We also try to do it after the school year has started, at least here in the United States, so that we can get teachers involved in doing some observations of the moon leading up to International Observe the Moon Night, to give students a better understanding for lunar phases, trying to address the misconception that the moon is not just up at night, that you can also at times see it during the day. So we try to keep it on a Saturday just to make it easier for families to participate in. So that's kind of why the date changes, and of course the phase too. Doing it the night of a full moon or a new moon is not exactly best for observing.
Sure. So outreach events, public star parties are usually done not at new moon, like us astronomers mostly like, because it's nice and dark, but when the moon is near first quarter, so that you have a great object that you can see from any place, including the city lights, in places in the city with light pollution. September is also a good time because you're close to the equinox, and some people forget that if it's going to be international, you don't want to hold it during the summer in the northern hemisphere. It's winter in the southern hemisphere, so that doesn't work. So all the things that I've done internationally since 2009 have been near the equinox, one way or the other, for the most part. So that's also good. And these are ways in which, people love to get out and share the sky with other people, amateur astronomers around the world. I ran the 100 Hours of Astronomy Cornerstone Project in the International Year of Astronomy in 2009, when you had your first National Observe the Moon Night, and we had probably 1 million people look through telescopes in one night. And so we built on that in other ways since then. Amateur astronomers love any excuse to get out and point their telescopes at the sky and call people over and have them take a look. And the moon is always a winner. It gets a bad rap from people trying to do deep space imaging, but you know, when you want to share something, I mean, the moon is absolutely an amazing object, and it changes every night. No matter when you look at it, you're going to have different shadows. You're going to see different detail.
Uh-huh.
Definitely the place to go. So, what is the focus then? So I was just talking here about ranting on about my love of sharing the sky just through telescopes, but International Observe the Moon Night is about awareness as well, awareness of the science and so on. What do you have for that? Do you have materials for the amateur astronomers to share information with the public, or what sort of things do you have for that?
We do. Yeah, each year we put together what we call a moon map to highlight, it shows the phase of the moon on the night of International Observe the Moon Night, and it highlights a few of the specific features that will be easily observable that night, especially as you had mentioned along the terminator. We also try to pull in images from the LRO spacecraft, high-resolution images of those features, to not just kind of point out, oh, that dark blob is such and such on the moon, but what does that actually look like? What does it mean? What does it tell us about the moon, about the moon's history and how the moon formed and has changed over time? So we make the moon map available on our website, observethemoonnight.org. We also, we're actually in the process of updating our website right now. So if you go online right now, hopefully you'll start to see some changes over the next couple of months as we approach International Observe the Moon Night, to make it easier to find links to some of the information that you were just asking about, information from some of our recent and current science missions, again, such as LRO. We're going to be updating those, having some presentations on recent new lunar science results that people can download and use in their events. We currently have, and we'll be updating it as well, suggestions for hands-on activities that you can do at your event, whether you're doing something small that's within your neighborhood, or doing something at a local that's a little larger at a local school or library or museum or a community center. Some instructions for activities that you can easily do with the families or with the members of the public who might stop by, to start to get them thinking about planetary science and lunar science in a little more detail, and some of those fundamental processes that have helped shape the planets, the moons, and our own planet, such as impacts, for example. So all of those resources, some of them you can currently find on the International Observe the Moon Night website, and some of them, again, will be coming. So definitely stay tuned. And again, we do encourage events small to large. This is not a one-size-fits-all type thing. We know that people have different constraints that they're dealing with in their own areas, and you don't have to have a telescope to look up at the moon either. So that's the other thing that I really like to stress with people is, you can do this without a telescope, without anything fancy. Use a pair of binoculars, for example, if that's what you have. It's just really just to get people out, looking up, get them excited, get them thinking about it and learning a little more.
Well, this is also an issue in many countries, developing countries. I've been to quite a few, and there are some countries where there just aren't any telescopes, and we do what we can to try and help them. But some countries I've been to, there is outreach going on, even though they don't have a telescope. They're sharing information and the things that are of interest, and they use pictures. But with the moon, it's actually a bit easier. If you go out at night and say, here's the moon, here's a close-up picture of it, this is what you're seeing, people can see it. It's not quite the same as seeing it directly, but you can share what is going on there. Why are there dark areas? Why are there light areas? What is that thing that I can see right in the middle there? It might be an impact crater, Copernicus, or something that got rays, or Tycho, of course. And these things you can see with your eyes, certainly easily with binoculars, which is the way I started more years ago now than I'll even say. But so these are things that anybody can do with resources like what you're talking about there. So that's something that everyone should do, and I think should be encouraged to do. I'll mention also we have a resource that you guys could use. This year, during Global Astronomy Month, which is now, we have had some observing challenges for people just to give them something particular to do. in some countries especially, they really like to have sort of a program where they say, do this, do this, do this, and it's a challenge, and people like it here as well. The Astronomical League, for example, which is an organization of organizations, so clubs belong to it, has many awards or certificates for completing certain observing programs.
Mm-hmm.
And for our Global Astronomy Month this time, they created some moon observing challenges. And these are unusual things, some I didn't even realize, which are of historical importance, places where people thought that they had seen something happen, like meteor impacts or flashes of some sort, and in some cases volcanic activity and things like this that turned out not to be the case. But that's interesting too, so you could grab that stuff as well.
Yeah,
The
I'll
amateur
definitely check that out.
astronomers, yeah, it's the regular lunar observers like this have got a lot of great ideas, and they
Mm-hmm.
what interests people. So, but I know you are already doing that kind of a thing as well. So let's see, we haven't got Andrea back yet. So tell us about International Observe the Moon Night. You mentioned the website. Is there an easy to cite URL for that?
It's observethemoonnight.org.
Okay, that's easy enough.
Yep.
For all of
So
us to
it's basically our name, but without international in front. So it's just observethemoonnight.org.
Right, right. And sorry, I've just muted the person who joined us now because we're going to have a lot of noise there. And
Mhm. Yeah, one thing I want to mention is that we do have a map on the front page of the Observe the Moon Night site. So you can go ahead and start registering your events, again, big or small, and have your map or have your event show up on the map. We tend to have typically about 500 events, give or take, in about 50 countries each year. That's typically our average. We would love to increase that. So, this is a real opportunity for you guys to help us do that. And actually, we tend to only have about 45 or so states participate. I really, really want this year to have all 50 states participate. So definitely, please do that. And as you mentioned earlier, Mike, one of the benefits of the CosmoQuest program is an opportunity to participate in citizen science. And one of those is focused on the Moon Mappers program, and that is using LRO data. So, this is an opportunity. Hop on CosmoQuest, hop on Moon Mappers, help scientists investigate the Moon. Then on September 19th, go out and observe those places that you have just mapped in detail in high-resolution images. So help it come full circle for us.
Yeah, that's a great way to get involved, because those people who are mapping things on the Moon should participate in this, and those people who are participating in most U.S. states and in many countries around the world should get involved in CosmoQuest and help do the science there. And I will add as well, help support CosmoQuest. Laura is with NASA, which has its own funding difficulties, but it's better than those of us who run nonprofit organizations, some of whom are supported by NASA, but in increasingly smaller amounts these days as the budget gets tightened up. So the help of those citizen scientists, or just plain citizens who have an interest that want to see science happen, real science involving ordinary people, please do go to the cosmoquest.org page and click the donate button and give whatever it is you're comfortable with, whatever amount that is. It doesn't matter if it's big or small. Big is always better, but if it's going to be small, that's fine, because if everybody who is involved in International Observe the Moon Night, or Astronomers Without Borders, or CosmoQuest gave $1, there wouldn't be any need for a fundraiser like this, and everybody could just get on doing great things for people around the world. So, and let me have to check here on, okay. And I keep hearing a ping someplace. Sounds like from the guys in the back room, but I haven't seen anything appear in the chat I'm looking at. So in case you're trying to reach me, I'm not seeing it. But so Laura, I want to thank you for joining us, and I hope everybody will go to observethemoonnight.org
Yep.
and at least take a look and see what's going on. Chances are, if you go there, you're going to be hooked and you're going to take part. And a big part of all the programs that we do, Astronomers Without Borders, is the sense of community in the society. You're doing this with other people. This isn't just you out in the streets looking at the moon and sharing it with others.
Mhm.
You are doing this with people in 50 countries around the world. It's exactly, of course, the type of thing that we do, so we support it very, very strongly because we're all on this one little planet together, and we share that moon. And when you have a chance to see it and share it with others, that's really a good thing. So Laura, thanks for joining us, and I'm sorry we couldn't get Andrea on here more. I know she had a lot more to say about this, but internet problems, which is not restricted to developing worlds only. So thank you very much.
Well, thank you. I really appreciate it. I enjoyed it, and I look forward to looking up at the moon with everyone on International Observe the Moon Night on September 19th. Thanks.
Great.
Bye.
Okay. Bye-bye. Good luck there. And next up, we are going to have Brian Coverline. Now, Brian, you may not know it, but I muted you, so you will have to unmute yourself if you are not already.
I think I'm unmuted now.
There you, I can hear you, Brian. So
Okay.
welcome to the Hangout-a-thon.
Thank you very much.
I was sort of a last minute, well, not last minute, came up last night. We finalized that I would be hosting here. You may not even have known that you weren't going to be talking to Pamela or maybe Fraser. And I didn't know I was going to be talking to you. That's the way 36-hour live programs go. Longest thing I've done live was 5 hours with the Venus Transit in 2012. But
Right.
this is another step beyond that. So I guess there was a little miscommunication as far as schedule, and you jumped online earlier than you had expected, so we could continue.
Yeah, yeah. So
I hope you're prepared. I can tell you I'm not a whole lot sure about my preparation for this, but you know, this is what happens with live events, especially when they're 1.5 days long. So
right, right.
So to introduce myself, I'm Mike Simmons. So we haven't met before, and president of Astronomers Without Borders. We work with Pamela Gay and CosmiQuest quite a bit, and despite the fact that we need to raise funds just as much as CosmiQuest does, we all need it, and we all support each other, and we all work together, just like you and the previous guests at NASA with International Observe the Moon Night. And so we're all in this together and have to support each other, and I very strongly support CosmiQuest. And with your organization and ours, and with CosmiQuest, you know, if one folds, it's cutting the chair, the leg out from underneath the chair. You know, we all need to support each other. So we are all in this together. So you have something very interesting. Now you have one universe at a time in your tagline on your lower third, and you have an organization called Prove Your World. It is a nonprofit organization based here in the U.S. And this has to do with an area that I don't get into very much, which is teaching the younger children. So tell us, give us a quick summary of what it is that you do.
Prove Your World is actually an organization that's trying to enhance scientific habits of mind within kids ages 8 to 13. So if you look at the interest in science as it goes by age, little kids are really interested in science. Older kids that are interested in science are interested in science. But in this 8 to 13 range is when the transition happens. 8 to 13 seems to be a point where kids will decide whether they're going to be interested in science and maintain that into adulthood, or whether they decide science is not for them. So we decided to target specifically that age range, not just training scientists, but just to get kids interested in science and understanding what science actually is.
And to maintain that interest that they have. You know, one thing that we all know, those of us who've been doing outreach for a long time, kids almost seem to be born with an interest in this stuff.
Right.
I have a 2-year-old great-granddaughter who we show the stars, and now when we go outside, she looks up and says, "Moon." You know, it's one of the few words she can say. there's always an interest in astronomy. And we know also that things change when the kids get older, but that interest really never goes away. It may be latent, but when we get parents with young kids coming up to a telescope at a public star party, they'll come up and they'll encourage, they're kind of sheepish about it. They'll encourage their kids to go take a look through the eyepiece. But they don't know what's going on. They don't know any astronomy. They feel kind of funny about it. And eventually we coax them to the eyepiece. And they quite literally turn into kids again. It's like, oh, wow, that's amazing. So what happens in the meantime? I mean, I've talked to so many people who said, oh, when I was younger, I always wanted to be an astronomer. But I went into this, I went into that. Sometimes people stay in science because of that interest. And I know people get PhDs in astronomy and then they go into something else with that background. But most people say, oh, yeah, I really loved it. And then they get away from it. And you're saying this is a critical period in that time to actually. So why 8 to 13? What's happening then that makes that the case?
Well, there's several things that are happening. One is cognitively. Little kids before 8, you can focus on basic ideas, but critical thinking is still developing. And between ages 8 and 13, the ability to actually think critical about data, to analyze and solve problems, reaches a new level. And so the level of scientific sophistication that they can do shifts during that period.
Interesting.
And so that's one of the things that happens, is that science goes from being somewhat just entertainment. There's some basic cognitive training there, but a lot of it is let's do a demonstration and let's talk about it, as opposed to let's actually analyze a problem. So the perception can be that it becomes harder. I don't know that it becomes harder, but it becomes different. The other thing that comes in is between 8 and 13, there's a lot of social pressure. The social dynamics really ramp up as they start moving into becoming teenagers. And so the ideas of how your peers view you and how you think you should behave or what you should be interested in versus what you are interested in pushes a lot of pressure in kids to either decide to move away from science or to stay with science. The other thing is that within that age range in schools, there's a lot of different pressure. It's not just in science, but it's in mathematics and history and writing, and the testing start coming in, and you've got a lot of pressures from all sides. And so the encouragement of science can diminish during that period. So there's just a whole bunch of factors that are driving this. And you can see this in the level of interest. In that 8 to 13 range, it's kind of the hardest range to tackle, but at the same time, it's the most critical range.
Absolutely. So, and I don't know who's deciding what goes up on the screen live. That's one of the quirks of Google Hangout, is that we can't be sure, but I'm showing your website now because I thought this is just a great site, and here we see you with some of your colleagues. Did you work there? And I hope the guys in the back room are making this, if this is voice activated as to what goes up there, then I'll just keep talking just in case. And here are a number of things that we can see as to who you are and what it is you do. So yeah, this website is, as you can see at the top, proveyourworld.org. And I will come back here to me. So now you mentioned a couple things that I think are really very interesting. Of course, there's the peer pressure. One of the unfortunate things is that science isn't always cool. You know, and why is that? There are countries I know of where science is really kind of a cool thing. It's not the main thing in adolescence, young adolescents like this, of course, but it's not discouraged like that. And what are we fighting against there?
Well, I think part of it is that in the United States, at least, there's an idea that you don't want to be seen as being too smart. You don't want to be seen as being too intelligent, because then that seems snobbish or elitist or something like that. And this is particularly true with girls, for example, where girls aren't supposed to be smart. And so you get very intelligent young women who start posing as not being interested in science because it's frowned upon by their peers. And so, that's one of the points where you'll see that shift of girls away from science. There's kind of several critical points, but that's one of them. Boys will do the same thing. Boys will go more into sports, for example, and they'll think that if they're going into sports, they can't really be interested in science. And so there's a small group that will maintain that interest in science, but a lot of this pressure is pushed away from science just because we don't want kids to be too smart, apparently.
Yeah, well, so this is almost like group therapy for those who fit into another category, which is interest in science. And I have to say, I wouldn't know as well as you, but I think that everybody's interested in science in one way or another. Science is simply, it sort of gets labeled as some sort of separate thing from what we do. But every time you figure out something in your daily life, that's
right.
Science. There's physics involved, chemistry involved. If you cook, there are so many things. Anytime you learn something, that's science. Science is just the process of learning. And
right.
That's why there is political science and social science. It means learning about these things. And learning should be a lifelong process. But
right.
for some reason at certain times, well, we know what some of the reasons are. Other things become more important, but we don't want to lose them during that time. That's really good. Another thing I want to ask about, too, is it sounds like some of this has to do with what is technically or formally called inquiry-based learning.
Mm-hmm. Inquiry-based learning, yep.
And that is just simply a matter of being hands-on. And we know that lectures can be boring. Depends on the lecturer. Does not depend on the subject, because any subject can be interesting. If it
right.
wasn't, then nobody would have learned about it in the first place. So if we know about it, somebody's been interested in it. But this is the way we learn. This is the way that 2-year-old I mentioned is learning about the world now. It's not
right.
by listening to somebody talking about it. It's not by reading. It's by putting hands on. And somehow, somewhere along the way, our educational system, and the U.S. is not unique here, this is most of the world, turns into something where we try to pump information into kids and we expect them to learn it. So how much of a factor is that? Where does that come in? I would think, and you can't put your hands on science too well, but history or some other things, but science you can.
Well, I think the one thing to keep in mind is that inquiry-based learning is partly hands-on, but it's also a process of inquiry. It doesn't have to be hands-on, although that's often a large part of it. Okay. The big idea of inquiry-based learning is that it's driven by the kids' exploration. So in many ways, it is a bottom-up exploration of scientific ideas as opposed to a top-down declarative statement.
Right.
And so part of what we're trying to integrate in is, for example, in the videos, we're modeling that inquiry-based process. So it is the questions that lead to an investigation of ideas that then lead to what the conclusions are based upon the evidence that they have. And although there's a lot of research that shows that it works, it's very challenging to implement in a classroom. It's much easier to dictate the facts rather than having the kids explore. Because if you're allowing the kids to explore, you have to be able to address tangents. As an instructor, you have to be able to be a guide and not a leader. And that's something that a lot of teachers aren't comfortable with. Even at the college level, they're not comfortable with that because it's much easier to just say, look, I'm the authority, I can do what I'm doing, and just listen to me. Mm-hmm. And so there is always that little bit of resistance to inquiry-based learning. And unfortunately, a lot of things that happen sometimes is you'll get hands-on learning will be seen as inquiry-based learning. So we're going to do an activity. I'm still dictating the activity from you upon high. You will do it this way, and you will write down the answers on your worksheet. We've done hands-on learning. Yay!
Right.
It's still not inquiry-based learning.
Absolutely, absolutely. So how much of this really has to be focused on teachers? You know, we can't fault teachers. My organization has an educational program in Tanzania, and one of the main aspects of that is teaching the teachers who have not had any training in science whatsoever. I've never had any labs, but they're the linchpin. So can that be done here in the U.S. as well?
It can, and that's part of the reason why with Prove Your World we've stepped somewhat outside of the schools. We're not just doing things where we're going to do hands-on lab kits or anything. There are two sides to Prove Your World that we're actually working on. One is actually producing things like videos that model scientific thinking and inquiry-based learning. But the other part of it is providing supplemental material. One of the big challenges of teachers in that age range is having the right type of materials. So they're going to be told these are the topics that you have to cover, but then they're left to the responsibility of trying to find these materials, and there isn't a whole lot of good material out there sometimes. It can be hard to find sometimes. And so part of what we're doing is connecting with schools right now locally in Rochester, but working with teachers, working with teacher training, and providing resources that they can then integrate in the class. So this is how you bring inquiry learning into your classroom in a way that's not disruptive to all the other things that you have to do. One of the things we have is we have 2 New York State certified teachers as part of the program for Prove Your World. So they have those connections, they know those skills.
Now, this is all based on what we know about education, what we know about kids, but you're doing continuing research on this as well as a part of the program to find out what works best. So, tell us about that.
Well, we've started some initial things because we've only done a couple of basic videos so far. So we're actually in the process of producing more. But one of the things that we have to look at is how effective is this? Because there's been general research on inquiry-based learning in the classroom that we know works, and we know what's effective in that. Media is something that's been less investigated. So you're basically looking at things like Sesame Street and some of the early childhood learning. And what's shifted probably in the past 5 years or so is that kids have now really come to consume media online. That's become a dominant way in which they get their entertainment and in many ways much of their information. There isn't a lot of research in how effective that is in their learning. And so part of what we've started doing is looking at, because we're partnered with several schools, we can do these videos, do pre and post assessments, look at their educational learning over time, how do they dispel misconceptions, what concepts do they get. And the initial research that we've had is actually very strong. It's in some levels it's so strong that you become skeptical of it.
Right. Well, every study needs to have confirmation somewhere else to find out what factors might have affected and how much it's applicable to other things. So yeah, you never know.
And it can vary based on not only age but demographic. For example, an urban school is different from a rural school. How do you adjust for those? So we're in that second stage of looking at both confirming the research and also looking at other aspects of it.
But I can tell you, as a retired researcher many years at the university, I'd rather have results that are so good I'm skeptical than to have no results. So you're in a good position.
That's true.
And one of the videos I see on your website is called "Why Do We Have Hair?" I'm not even sure I could answer that. In fact, I'm pretty sure I can't. So once I get off of this program, I'm going to have to watch that video and make sure I know the answer to that myself.
Okay.
If you're interested, that was proveyourworld.org again. And so how large is the program now?
The program, we are partnered with a group in Rochester. There's a nonprofit group called Encompass, And one of the things that's under that umbrella is the Discovery Charter School. So there is actually a school that focuses on, if I remember correctly, 1st through 6th graders. And it's actually a really good arrangement because they have moved into a school that had been used, and their class sizes are smaller than the school space that they actually have. So what we've done is we've partnered with them, and they've allowed us to have a space where we can have some office space and a studio space, which has been our biggest challenge in making videos. We've had to do them in garages and barns and attics, and so it's been set up some type of studio space and then record, and then you have to take it all down again. So now we have a permanent space there. And so our organization has about 8 members right now, and then is partnered with this other organization. And our big thing right now is we've just finished the set, and so we're entering a period of producing more videos. So we're going to be producing more videos that'll probably be released either summer to fall, and we are producing support materials for the topics that we're covering that are going to be test implemented in several schools in the Rochester area. And all of this will be publicly available. So, you know, even though right now we're focused specifically on Rochester area schools in New York that we have direct contact with, if some other school is interested in utilizing our materials, they are more than free to do that. By all means, contact us. We'll provide whatever we have for free.
Mm-hmm.
So this is available to anyone who wants to use it.
So that's a perfect segue for what I wanted to do now anyway, which is to make a little commercial break here. A commercial is a simple one, and I think everybody should be interested in this as well. This is the 36-hour Hangout-a-thon for CosmoQuest. You can see CosmoQuest at cosmoquest.org and all the partners. I'm Mike Simmons. I'm the president of Astronomers Without Borders. We support what CosmoQuest is doing. They support what we do. The trials and tribulations of Prove Your World that Brian is going through are not unusual. They are typical. And this is not just a matter of startups in nonprofits. This is an ongoing thing here. There are a lot of organizations that do very good work, and they have to be scrounging for funds all the time. CosmoQuest in particular right now really needs your help. And I would like to have your help because Pamela, when she introduced me when we started this segment, challenged me to do better than the previous hosts. And I won't mention names, but some did better than others in terms of raising money. This is always a very, very hard thing to do, and we have to do it ourselves. But right now it's CosmoQuest time. We are barely over the 50% mark on the funding goal of $36,000 for CosmoQuest during this Hangout-a-thon. We are past the halfway mark, and of this program, well past it, and we have 51%, $18,462. I would love to see that number go up. While I'm hosting especially, please help me look good to everybody else, okay? So if you're watching this, if you're interested in CosmoQuest, go to cosmoquest.org. You can take part in the program, citizen science programs right now, mapping the moon, mapping other planets. There is a race going on there to see which one is going to get the most, and let's see, I don't even think I have that up, so I can't say which planet is winning now, but you can take part. So help CosmoQuest do science, real science with citizen scientists, and to work with everyone else. We need CosmoQuest as one of our partners as well. And I don't see that bar going up. So I hope it will go up in the next half hour or so while I'm here. We should set a goal. I'd love to see $20,000 reach in the next half hour while I'm here, just to make me look good. But it doesn't matter when you do it, and it doesn't matter how much, frankly. If everybody who participates in any of these organizations gave $1, none of us would have a problem with fundraising ever again. So please, whatever you can do, if it's $1, if it's $10, if it's $100 or $1,000. I donated earlier despite being a full-time volunteer doing this kind of work because it matters. So
I would actually add to that. I would say, one of the things that I think some people don't realize is just how critical this funding support is and how much it's stretched to every penny. I mean,
absolutely.
Prove Your World is a perfect example of at the end of December we did a small fundraiser because we had partnered with this group where we had studio space. But there were costs. There are insurance costs. There were material costs for the set. And the people who stepped up and donate were an absolute godsend. I mean, it made it possible in a way that we couldn't do otherwise.
Absolutely.
And the same is true with CosmoQuest. Every dollar you donate is going to be used effectively. It's going to be stretched as far as it possibly can. No one here is getting wealthy off of this.
No, nobody goes into running nonprofit organizations to make a lot of money.
Right.
There is a misconception, and there are surveys that have shown this, that people think that the majority of every dollar they donate to charities goes to operations and management and things that don't actually reach the people. Well, your organization is a startup. CosmoQuest and mine are a good example of volunteers and some staff who are getting paid very poorly compared to being in a company. Money is not what it's about as far as why people do this and why people support us. It is definitely where it's at when it comes to getting things done. So, and you will find that nonprofit organizations generally are extremely efficient because there's no choice. But there are people who are passionate about it and they volunteer and are willing to do it for less pay than they would get somewhere else. So if you like what CosmoQuest is doing, please just click that button and give a little bit.
Right.
So that's we can stop the commercial right now, though. If that bar doesn't start going up, I'm going to start really ranting about this. Nobody wants to see that. So yes, that's a threat. But anyway, Brian, back to you. Now, in your tagline, you don't have Prove Your World. You have one universe at a time.
Right.
So tell us about that. What does that mean?
One universe at a time is basically my blog, and it's also a podcast. So I try to post once a day on topics in astronomy and astrophysics, and then there's now a weekly podcast that airs. It goes live on my site on Saturdays.
Mm-hmm. And what are the subjects usually?
Well, the podcast can cover pretty much any topic in science. So the basic idea of the podcast is you have two people who are experts in their own respective field, and they exchange questions on those topics. So you might have an astronomer and a physicist, or you might have a psychologist or a biologist. It depends on who's been recorded and when we air it. So
okay.
This week's is on cognitive dissonance and black holes.
Okay, I have a little cognitive dissonance just thinking about that. So back to Prove Your World. Now, this program, it does seem to have, it's really all about science. It's about STEM. It's science, technology, engineering, mathematics. But there are things involving not just physics, but astronomy as well. Is astronomy a big part of it? Is it just one of those things that you may use?
Astronomy is one part of it. The big fundamental thing with Prove Your World is the topics that we cover are driven by questions that kids asked. So we will actually go through classrooms and survey kids on what they're interested in and what they want to know about. And so all of the things that we cover are based upon questions that actual kids have asked. So we're not creating the content because we think that it's important. We're creating content in response to what the kids think are important.
Okay, well that's perfect, because once they start getting interested in something, the worst thing you can do, which sometimes you have to do, I suppose, and when you have a set curriculum, is yank them away from what it is they're trying to learn about. We want to foster that interest and that curiosity as much as we possibly can. Right. So, what other, and looking at your blog also, there is quite a bit of astronomy on here.
Oh yeah.
Is that the focus there, or is it STEM in general?
It's a focus there because my own research background is in astrophysics.
Oh, is
So
it?
that's the area that I'm familiar with.
So with Prove Your World, you're looking at all the STEM fields, anything that's good. So
Right.
why not, everybody says stick with what you know, but of course you're
Hmm.
dealing with 8 to 13-year-olds, so astrophysics is not necessarily the best topic. But why expand it out like that? What is it? Is it that children are ready for just about anything and you never know what it's going to be?
Right, right. And yeah, I mean the idea with Prove Your World is even though I'm one of the main players in it, it is not just focused on my area. So as it expands, you're going to see other scientists in front of the camera as well.
Hmm.
So it's not just going to be me. Right now it has been because that's where my area of expertise is. The one where we did the initial research project was actually on gravity. So it's related to an area that I'm familiar with. But when we get into biology, that's going to be someone who has a PhD in biology. It's not going to be me. And so it's really going to be driven based upon what they're interested in and science in general. So over time, you'll see more scientists participate. You'll see a wider variety of characters. You'll see different age levels rather than just kind of the average age level.
Hmm.
So as we now expand, you're going to see more targeted areas.
Right, right. Well, I know from experience that teaching to and holding the interest of 8 to 13-year-olds is not always an easy task.
No.
And that probably the ability to connect with people this age more than the extreme, detailed knowledge of a field that really matters most. Because we've all had
Right.
world famous professors who can't describe what they know to their students, and
Right.
certainly to the public. So,
Yeah, it's one of those things that when we started this, I guess Prove Your World started about 4 years ago as an idea, and a question that I and a colleague of mine kept asking was, why hasn't this been done? Why hasn't anybody done this? And after spending 4 years on this, we know why no one has done it, and that is it's just so incredibly difficult.
well, yeah, yeah, and that means if nobody else has been doing it, it's probably really necessary. Now, there
Yeah.
are other programs in education too. Galileo
Yeah.
Teacher Training Program that
Yep.
trains teachers around the world. Universal Awareness works with
Hmm.
the younger kids in the stage before yours,
Yeah.
and many other things. Those are international ones, so that's what I mostly work with. What about partners? Do you work with other organizations or others
We
out
do. We partner with, as I said, we partner with the Encompass Group, which is a nonprofit that focuses on supplemental education, again, largely in Rochester right now. But they actually work on helping with the fundraising and building those connections with larger organizations. And so that's part of the reason why we're now connected with several schools in Rochester. So we're now kind of at a nice advantage where we can be connected with both other nonprofit organizations and also things like the Rochester Public School System, so that we have the connections to the kids as well as to uh, some sources of funding. But right now we're still deeply dependent upon personal donations, and it's very much like CosmoQuest, where all of those personal donations really, really matter.
And every one of those partner organizations that you have, that we have, that CosmoQuest has,
Hmm.
they are another chair on that leg or table that we cannot do without. So we
Exactly.
rise and fall together. So what are the plans for Prove Your World? Where do you plan to be in 5 years or 10 years, and how are you going to get there? And how hard is that going to be? I know the answer to the last question.
It's probably going to be harder than I think,
Yeah, I'm afraid that's
but
probably true. Yeah.
our plan is to go in stages. So right now we have good connections with the Rochester area. So our next stages are going to be doing a series of videos on different topics. So we've done one set. We're going to build a set of about 5 to 8 of them, and they're going to cover a full range of topics. Parallel to that is going to be a whole research project looking at how these are effective, where they're not effective, for what age groups they're effective, and start looking at actual research publications looking at the analysis of these. From that, based upon the research there, we plan on taking it to the next step, which would be a more national approach. And so then it would be focused on topics across the country, working with schools across the country, distributed nationally, so that you would easily be able to use these resources in the classroom, as well as the type of teacher support that you can have in order to use them effectively. So we're starting in Rochester, and then over the next 5 to 10 years, we'll expand out nationally, maybe internationally, although we're still focused on the U.S. Standards for education.
Right, right, which is different than other places. So it'll
Exactly.
be a whole other completely different dimension when you go international. I
Right.
can tell you, but you'll find a lot of interest as well. So that will be another very difficult stage. It will also be very rewarding.
Right, right.
So tell me about your blog now, which is One Universe at a Time. How long have you been doing this so far?
Probably about 3 years, maybe a little bit longer. It actually started about 3 years ago. I was working on a textbook, and so I was spending a lot of time writing, kind of chiseled out time in my day to write all the time on this textbook. And then when the textbook was done, I had this gap. And so I started writing on Google Plus, just little topics on various astronomy and astrophysics. And over time, it's migrated to the actual website. I still write on Google Plus, but I've been doing a post a day for 2.5 years. So I think I'm up to, well, I'm over 900 posts now.
Wow,
So,
that's quite a
so
bit.
I'll be approaching 1,000 in the summer.
That makes you an old timer as far as blogging goes.
It does, yeah. So I'm kind of the young old timer.
Yeah, I've got a weed whacker outside the window right now, so I apologize to everybody if you're getting what sounds like a jet aircraft in the back, but that will pass quickly. So you explained what are these holes in your day? What is your day job? What do you do?
I'm a professor at Rochester Institute of Technology, so
Okay.
mainly I teach engineers how to do physics.
I see. Okay. And what do you find with doing the blog? I mean, there are a lot of bloggers out there. Where do you stand with that? Because I always wonder sometimes. I love to write, and I would like to do a blog probably on our own website as well, much more often. But I never find the time to do it. But how do you stand out? What's it like being a blogger these days?
I think if you have a unique voice, you can stand out as a blogger. Everybody has a unique perspective, and my own take on it has been, I write about astronomy and physics and astrophysics because that's my area. So I'm not writing science in general because I don't know science in general. You get outside of physics, you get into biology, and my level is basically a freshman high schooler. And there are far more talented and skilled people that can write about biology than me. And so I think in some sense, for me, the purpose of the blog is really to stand apart from kind of the mainstream science journalism sites. Someone who's a journalist is writing about science, and they know how to tell a story as a journalist. That's what they're trained in. And so they're integrating the science into a story about science. And my take on it is I'm not integrating a story about science. I'm taking my own personal view on this research area. So when new research comes up in my field, this is how I, as an individual scientist, take whether or not it's valuable or not valuable, where does it integrate into other areas. And so it's a much more narrow approach, but it's also closer to the mainstream science, I think.
Hmm. Yeah, well, I agree with you completely. Having done outreach for many, many years, everybody has a different perspective, and you think that you stand up in front of a crowd and you're going to be pretty much reciting the same things. I mean, you're covering a particular topic. It's going to sound the same. It doesn't sound the same,
Right,
and everybody has their own voice, and everybody therefore has their own audience. So,
right,
so
right.
you've picked a difficult one with the 8 to 13-year-olds.
Yeah.
That's for sure. So you mentioned with Prove Your World about doing more research in the future and so on. You also
Hmm.
mentioned there hasn't been a lot of research done in this area, but there is a tremendous amount of research in general in science education. Is that
There
mostly
is.
focused on university level or other
Right.
levels, or why is it you're finding this gap?
Well, this particular gap is specifically the use of media as an education form,
Gotcha. Okay.
partly because it's relatively new. So most of the research out there, and of course this is outside my field. We have people who are part of the team who really are education experts with PhDs who,
Right.
I only dog paddle. I'm the science person. So,
Right.
but a lot of the research on media focuses on television because traditionally that's been the avenue. And so there isn't much research on the use of videos. And there's a very big shift in the sense that um, television is push media. So you turn on your television and it just happens to be on when it happens to be on. You might choose to watch it at a particular time, but what you get is what's there on a narrow level of channels. In many ways, videos are pull media. People go to YouTube and they will choose to click on a particular video, but they will do that on their own time, independent of anything else. And that changes their attention, it changes their focus. So part of the question is when you have someone who's choosing, they're actually pulling the media to you, how does that affect their learning outcome as opposed to when it's pushed to them?
Yeah, I'm actually surprised by that because their YouTube obviously has a lot of people on it.
Mm-hmm.
And there's also time shifting so that people, or just simply streaming online television programs. So people are
Right,
more and more just choosing what they want to watch and when they want to watch it. So I'm
right.
quite surprised that this is an under-researched area.
Well, it's part of it is because it is specifically at education aspects, and it's
Hmm.
specifically at videos and education aspects. I think a lot of it is that the research takes time to kind of come into the literature.
Right.
And so if you look, YouTube, for example, I think is only 10 years old.
Hmm.
And that's when it wasn't as popular. So if you figure within the last 5 years, uh, there hasn't been much time to do literature. If you
Right.
figure it could take a year or two to get any literature out, 5 years ago, so we've had 3 years of time to do
Well,
this.
and less because the first thing you have to do is write grant proposals
Right,
and get
right,
the grant, and then that takes another year to get funded, and then you do the research for a year or 2 years, and then you spend another 6 months writing it up, and then you spend another year getting it published.
right.
So I don't know what that adds up to, but that was sort of my life for a long time. It's a long
Yeah,
cycle.
and I think I would agree with you that there's definitely other people who are working on this type of research. What we don't have yet is a wealth of publications in the literature.
Okay, and excuse me. Okay, so this is behind the scenes doing these programs like this. It's just you and I here, but just like every other process, there are people behind the scenes, and they can't speak into my ear very well, so they speak to me on another screen over here. I have to talk. None of this is easy. I mean,
No. You have to be
yeah,
both the host and the producer.
yeah, and I've hosted live programs and so on with entertainment industry people because I live in Southern California, so everybody's in the industry, right? But I do not accept an earpiece in my ear so that somebody can talk to me while I'm talking to someone else. That
Right.
requires abilities that are not human as far as I'm concerned. So So yeah, that's what it takes to do the research. Well, you certainly chosen a challenging field to do this. And this is on your spare time. You're not going to get
Right.
wealthy doing this.
No.
You have to be extremely motivated to do something like this. Where does that motivation come from for you? Why this field? This is a big investment in time out of your life.
I think for me, a lot of it, one of the motivations was when my son was younger and is interested in science and was the type of things that he was looking for wasn't there necessarily.
Mm-hmm.
And part of the hard challenges is the stuff that is there often is overhyped to the point that it's completely unrealistic. So if you go to the Discovery Channel, for example, you can find ancient aliens and mermaids are real or something like that, and trying to find actual accurate information is difficult, and that was one of the big motivations. And to the credit of YouTube and other places, it has gotten a lot better. There's still a ton of hype and misinformation out there, but there now are a lot of places out there that are putting out good science and good information that is valuable and accessible to the general public.
Well, yeah, and you know what? And it's bloggers like you too that make a huge difference. So, the Discovery Channel runs a series of programs on Megalodon, and
Yeah.
the bloggers jump all over it. And I'm sorry, that's not science. That's
Right.
pure hype.
Right.
And I know bloggers who are all over it and give the shark experts a voice and a chance to do it. So, and I noticed on your blog too, you are sometimes talking about the things that are in the news right now. Why are we
Right.
talking about that? Because the news is fantastic. We get a lot of coverage of big discoveries in astronomy, but then I get people asking me questions about it, and they don't get it because it doesn't go into enough depth. And
Right.
as a writer also, I know the difference between journalism and outreach, and they don't necessarily coincide. You got to be very concise in journalism and get your facts right, but it doesn't always translate to being able to get people to understand. So that's got to be a part of what you're doing with your blog as well.
Yeah. And because of the way the media is, everything is so saturated. There's a risk of overhyping things, particularly in things like news releases and stuff. If you overhype it just a little bit, you're going to get just that much more attention. And then it gets picked up and it's hyped again, and then it's like the game of telephone, and all of a sudden we have aliens on Mars.
Well, as a researcher, I've had that happen too, when things that I've done for some reason that I can't really figure out, they pick up a paper that I present someplace and focus on one thing, and it's really not what I was trying to say there.
Right.
So it happens. So back to your motivation, because this is the thing that I think a lot of people don't understand, and why it's really important for people to support organizations like this. You started Prove Your World based on personal experience with your own son and the way you saw things. I started Astronomers Without Borders based on my international experience through astronomy and saw how it worked. Pamela, I'm sure, founded CosmoQuest because there was a need, and she loved that. Most of our efforts for things like this are based on personal experience, things that we saw, and you'll see this actually even in commercial things. Why did you invent this? I needed it. Nobody had it, so I did it. Right. The difference is that if you figure out an invention that you needed and everybody else does too, you can get rich off of that. If you figure out something about a new way to teach kids science or a new way to involve people in science, like CosmoQuest, you are committing yourself to a life of difficulty, heartache, deprivation. It's not a way to get rich.
Right.
So, while I'm still here, I want to say I'm doing a terrible job here. Let me see if I'm supposed to reload this. And, we went over 19,000. I'm better than I thought. Okay, so there have been donations. I'm watching a static bar there thinking, people hate me. Okay, but I've got 6 more minutes. I don't know if you heard my personal plea, but please give while I'm the host. I want to look good here. That's just a gimmick to try and get you to donate. But you know what? CosmoQuest is doing this for 36 hours, and there are a lot of people involved in this. Nobody's getting paid off of this. We need CosmoQuest to raise more funds, to have a chance to involve more people in citizen science. I run a nonprofit. I'm here raising funds for a different nonprofit. CosmoQuest supports us. We support CosmoQuest. Prove Your World is the same thing with Brian here. We're all in this together. We can't do it alone. We have to do it together. And when one falls, another one, everybody else is hurt. And when one gets their funding up, you know what? We all benefit. So that's why I'm hoping that everybody who's watching this, everybody who will watch it, everybody who's ever watched it, and everybody else in the world will make a donation. It doesn't matter how much. You know what? It's self-satisfying. If you like this stuff, you should feel good when you give a donation. And whatever it is to you that is the right amount, that will satisfy you. That satisfies everybody else.
Right.
And I have to say that was an awesome thing for me to come back to hear. Thank you so much, Mike. You've actually done a really good job holding down the fort. We haven't exactly made up the distance that we got behind, but we kept moving forward. That's really all we can ever do, is keep moving forward. And one really awesome thing happened while we were offline that you may not have seen, because it popped up on Twitter, is Noel Rupenthal, who's an old friend of the show, built Moon Mappers spelled with a U, in Kerbal Space. Built during this Hangout-a-thon to help promote the fundraiser that we're doing. We inspire all sorts of different things with all of our efforts. I was promoting in the overnight hours the astropoetry that you do. Well, not you personally, but that Astronomers Without Borders does. We, with all of our science, are inspiring better poetry, better science fiction, and apparently better gameplay in Kerbal Space. And Noel,
Well,
awesome.
you know,
This gave me a really good giggle. And if you have a few minutes to come on and show us what you've done, if you're out there listening, and I'll tweet at you, we'd love to learn more. But Mike, you do have 3 more minutes left, so I'm going to tweet at Noel and let you keep going. And I just wanted to say we're listening, and thank you.
Yeah, and you know, it's a good point you make to Pamela about poetry. We have astropoetry. Well, you know, how does this happen? I started our organization to connect people through astronomy because that works really, really well. And one of the people who is a volunteer, Bob Eklund, said, you know, I write astropoetry, poetry about astronomy that I've done throughout my life, and he's been involved at a couple different professional observatories. I'd like to do a blog about it. And my reaction, well, it's not going to cost us anything, so no harm done. Well, it's hugely popular. And we had an artist who came in and said, I'd like to, you know, do some things in astronomy and the arts. And like Pamela mentioned, aside from poetry, there's science fiction, there's illustrations, there's videos, there's all kinds of things. And the reason this works is because, as Brian said earlier, there are so many different perspectives we have. We all have our own voice, and we all have a way of listening to the same thing. So this is what happens when people like Pamela and people like Brian and all the people involved in those organizations and people like Matt Francis, who's coming on now, and the people in our organization as well have a chance to do what they do. You're going to come up with something that is different than what you ever thought would happen. That's certainly been the case throughout my life. CosmoQuest should not be just trying to survive. It should be thriving so that we can find new things and give voice to so many more perspectives on astronomy, on science, like all the guests throughout this Hangout-a-thon. So, you know, I'm gonna close with that, with an appeal, and let's see if we're doing any better. So we're doing better than I thought. We have gotten some donations. We haven't gotten anything since I started ranting here. But you know what? Let's finish out the hour with what we can, and then it'll go back to Pamela. and Pamela will be on here, and she's got 30 seconds. I'll let her tweet away there. I can see her fingers flying madly while I'm talking.
Thank you. Just letting folks know, hey, we're here and we're listening and we see what you're sharing, and it's really kind of awesome. While I've been offline, I've seen the Meteorite Men. Jeff Notkin was tweeting. Sandy and him will be coming on later. Matt Woods was highlighting his appearance. Noel Rippenthal was sharing the awesome stuff he's been doing in Kerbal Space. Matthew Francis was promoting what he'll be on. In fact, I think he may be in the window now.
He is.
He's there.
Cool.
And Pamela, we've had Astronomers Without Borders. I understand I asked somebody to do the tweeting and posting and so on for us, and I did it earlier today, or yesterday, I guess, when you guys started. So hopefully we're getting some buzz from that as well.
So it takes a community. The potato salad that was able to earn $55K on Kickstarter that I'm starting to become very bitter about. I don't want to be outperformed by potato salad. Potato salad that earned $55K on Kickstarter, it was able to earn that money because it went viral. People thought it was funny to donate to Kickstarter. People raised $55K because it was funny. What we're trying to do is interesting, engaging. We're building an entire community. We're changing our understanding of the universe. Show that that has value, and use your social networks. I know if you're out there listening, you've probably already given what you can give, and thank you so much. Now, can you use your social networks to try and get us to go more viral than the potato salad?
I have just one question before I go, Pamela.
Yeah.
Potato salad? You being outperformed by potato salad?
I've been outperformed by potato salad. I'm becoming bitter.
Well, I am too, because I'm in the same position as you, and we're not going to be able to raise $55,000 that easily either.
No, but yeah.
Okay. Well, Pamela, I guess you're back at the helm.
I am.
And I just so don't want to see that.
Okay.
Kickstarter, potato salad. I'm making potato salad, $55,000. People, you can do better than this. Somebody just gave another donation. I'm glad to go out with a donation that came in. Looked like it was $25. I don't know who it was, but thank you. If just 1/10 of the people gave $25, none of us would have to be doing this and becoming bitter over potato salad. This is a terrible thing.
I'm bitter over potato salad in general.
Yeah.
Yeah, they didn't even pick a good dish as far as I'm concerned.
So a lot of you out there listening have amazing social networks. Use them. Let's try and get a message out there that science matters more than potato salad. It could be that it doesn't. It could be that maybe potato salad does matter more on a Sunday afternoon. I don't want to live in that world. Can we have a better one, please?
Please. Okay, Pamela, I'm going to take a break that I need after drinking coffee all morning before going on here. I don't know how you do this, and I don't know when you sleep. I just know that I couldn't have been on at 2 o'clock in the morning like you would have liked, because people would have been staring at a blank face that just mumbled every once in a while and maybe drooled a little bit. So I don't know how you guys do this, but I hope it's just as successful as possible. And
it's called need, determination, hope, fear, and bitterness towards potato salad.
Yeah, that last one is turning me into a particularly bitter person today.
So I will just remind everyone, coffee is for closers, and we're drinking coffee, and we want to close this deal. We want to close in on $36,000. I don't know if it's possible. I'm starting to think maybe it's not. But I don't want to lower my expectations, not yet. We can turn this around. We can make progress. We can engage everyone we know. Maybe we can get this picked up by Boing Boing or Laughing Squid or one of these wonderful sites out there and make the point. We're trying to create a new world that's a little bit more scientific than the world we had yesterday.
Mhm.
Okay.
Our goal isn't that much. $36,000 is a whole lot less than the $200,000 that people pay to reserve a seat on Virgin Galactic. It's less than the potato salad got.
Pamela, I will
It's
leave
twice
you
as much
now.
as a gold Apple Watch. We're trying to earn 2 gold Apple Watches worth of donations.
Yeah.
I'm going to leave now, Pamela. I'm going to go make some potato salad, and I'm going to go outside, and I'm going to stomp on it.
Oh, I love that. Can you please have a photo of the carnage to tweet?
I will take a video. Maybe it'll go viral, and we can fund everybody.
I see Office Space, except instead of the printer, it's the potato salad. We can make this happen.
Okay.
Okay.
See you on the other side, Pamela. Good luck.
Thank you. Thank you so much, Mike. Thank you, Brian. Are you going to hang out or
Thank you.
take off?
Whichever you want me to do.
That's up to you. We always love having you around.
She just wants to see us fight.
Oh, okay. Yeah. So we should fight. Two astrophysicists get into a cage.
Why would the two of you fight?
We've argued on the weekly space hangout before.
Yeah. Bracer likes to pit us.
Genially.
Yes. He'll pick
Okay.
a topic and then we'll fight over it.
I can't imagine. Okay. Two generally sweet individuals. I'm just having a moment of that's curious. So, for those of you just tuning in or just confused, this is the 36-hour Hangout-a-thon hosted by CosmoQuest. We are spending 36 straight hours this weekend trying to bring you awesome conversations about science and things related to astronomy, space tourism, art, music, all those things that are inspired by the science we do. And, well, we're trying to talk about that science as well. We are also trying to get your help doing some science. We have rearranged the CosmoQuest pages so that you can do science side by side with watching this Hangout-a-thon. With Moon Mappers, we are at 881 images. Mercury has now fallen behind at 735 images. Asteroid Mappers continues to race ahead with 1,433 images of Vesta having been analyzed, and Mars are at 1,155 images. We launched Mars Mappers yesterday, and this is a science project that was funded entirely through your donations. You make science possible both through your contributions of doing the science and in these post-sequestration days as we all try and figure out how to keep going. You are actually the ones making it possible for us to keep going. Your donations are going to keep us going until we get our next big grant, and you better believe I'm using every spare moment I can to work on trying to find a way to never have to beg for money like this again, because all I want to do is talk about the science. All I want to do is do the science. But right now, I'm here to thank you for helping. You have so far raised $19,115.42, the answer to life, the universe, and everything. And we have some door prizes to incentivize you. We have dragon eggs that are now part of a tradition. Whoever donates the largest amount of money this weekend gets to take those dragon eggs, have their name engraved on the plaque inside of the container. Like the dragon eggs in the book Aragorn, they pass to you for a period of time, and if they hatch, you have dragons. And if they don't, you're part of a new tradition. And your name goes on the plaque, and they continue to get passed around, more like the Stanley Cup, but less gross. We also have a lightsaber that has a belt clip on it, so it's ready to be attached for those of you who are part of the 501st. Actually, they're stormtroopers. You probably don't want a lightsaber if you're a stormtrooper. If you want to go battle the 501st, we have a lightsaber for you. We also have, along with that, three meteors, two indigo night prints of the city sky over a city of your choice on a day that is special to you. We have two $200 gift certificates to iTelescope, 5 children's books by Sarah Willis, Your Place in Space. We have Surly Amy pendants. And on the off chance that we conquer and dominate that potato salad, Matt Woods from Perth Observatory is going to get a tattoo of the Pillars of Creation. Now, honestly, I think Matt just wants that tattoo, and this is the added impetus he needs to go ahead and get it. So, you know, help us accomplish, well, help us get the budget we need to keep going until we get that next large grant. For the first time, I can tell you there is a call out from NASA, a cooperative agreement notice posted. There hasn't been anything like this since 2011, and when we applied in 2011, we got the funding that's gotten us here this far. Right now, we're in a no-cost extension year. This means they told us keep your project going until the end of this year when we'll let you know if you have funding or not. But we didn't get extra money for that extra year. We're just allowed to hold on to what we've got and keep our things going. But now that we're sitting in this no-cost extension year, we do finally, for the first time, have hope. We are in the process of applying to this cooperative agreement. Matthew is actually one of the people who's on this grant with me. And you're on this grant to help us with an amazing program that lets people learn science in a small classroom environment that's interactive and dynamic and not anything like these MOOCs you keep hearing about. This is you and 8 students. Can you tell us a little bit about Cosmo Academy and the great things that we've been doing?
Okay. Oh, you bowing out, Brian?
Oh, I'm going to bow out. I'm going to leave it into your good hands, Matthew. And
all right.
Everybody donate to Cosmo Crest. It's awesome, and I wish you all well.
Thank you so much, Brian.
See you, Brian.
Bye.
Okay, well, Cosmo Academy is designed to be perhaps the most individualized learning environment you can possibly have online. I mean, the only way you could get more is if it was one-on-one, just you and a teacher. We limit the classes to 8 students simply because that's the number we can handle through a Google Hangout. But that is actually also a very excellent class size for if you have questions, you can make sure that the teacher gets those questions. MOOCs are the sort of the
anti-learning
opposite
environment.
tack.
How I think of them, the anti-learning environment.
Yes, yes. If you are a member of a MOOC, you are an anonymous person among potentially thousands of others. You will probably never meet your instructor. You'll never get to talk to them. You won't get to ask them questions. But in the classes we offer with Cosmo Academy, you very much can. Another thing that we do that's special is our classes are very focused on particular topics. Do you want to know more about black holes? We've offered several classes on black holes covering different aspects. We have had classes on astrobiology from our very own Nicole Gulucci. We have had classes on gravitational lensing, which is a topic that's popular this year thanks to both the centennial of Einstein's theory of relativity, general theory of relativity, but also the Hubble Space Telescope's 25th anniversary of its launch. And of course, the Hubble Space Telescope has taken some incredibly beautiful images of gravitational lenses that are some of Hubble's most iconic images, and that's saying something given how many great images Hubble has taken over time. But of course, as we all know, it's not just the pictures, it's what they tell us about nature. And gravitational lenses are a way for us to see farther back in time than we'd be able to see. The gravity is giving us an assist. And so we have had a class that covered that topic. We've talked about cosmic inflation, which was a big deal in the news last year with the BICEP 2 results that came out about a year ago at this time. Oh, I'm not hearing you. I think I
muted my mic. We found out we got boing boinged. Cory Doctorow showed us some love and shared what we're doing on Boing Boing. This is awesome. If only we can appear on Laughing Squid, we will have hit my 2 favorite places to get lost on the internet. So hopefully this will help us get to the potato salad, the 55K potato salad. I do not want to be in the shadow of the potato salad. So thank you, Cory, for making that happen. And what I was actually asking, and then you reminded me I'd muted my mic while we had a moment of yay on this side. What were those results that you were mentioning? Because they really were quite awesome and quite confusing, and then became simply confusing. And you helped us all understand that.
Well, this was one of those cases where scientists go through this all the time, where there's a result that comes out, people wrangle over what it could mean, and the first thing you've got to do when you hear something really cool as a scientist is figure out, can you trust it? And that was a process that takes some time. And this all happened in the public eye, which is rare enough that I think it was actually kind of cool for the public to see this, because this is the sort of stuff that scientists go through all the time. But last year, about this time, so members of a collaboration known as BICEP 2, and don't ask me to recall what the acronym actually stands for. Cosmologists love really elaborate acronyms that that spell out something that you can pronounce, and then nobody ever remembers what the acronym actually is. But the main thing is that what they were doing is something very complicated, very difficult to do. They pointed a telescope, which is located at the South Pole. They pointed it at the sky, and instead of producing the kinds of images we're used to thinking of from telescopes, what they were doing is they were mapping small distortions in the light from the sky, something called polarization. If you wear sunglasses, a lot of sunglasses are polarized. Because if you've all seen this, if you look out on a pond on a sunny day, or you look out on wet pavement, you get a lot of glare from light bouncing up. Polarized sunglasses don't just block the light, they actually filter out that light that's bouncing up off the pavement or off of the water at you. If you look at the sky to look for polarization, you can see all sorts of cool stuff. You can see places where, I mentioned gravitational lensing. You can actually see where light has traveled to us from very early moments in the universe. But as it travels, it's like weaving through all of the galaxies that that have formed since the beginning of time until now. And so as this light travels, its path gets just a little bent and the light gets a little bit twisted as it goes. And we can actually see that in maps of the sky using polarized light. But even more interesting is the notion that maybe we can see something that may have happened during the very first moments after the Big Bang. And that's something called inflation. The idea there is that the universe expanded very, 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 very fast, incredibly, increasing its size many, many, many fold within a tiny split second. Now that's a pretty wild notion, but we have trouble. We cannot see back that far in time. That far back in time, the universe was completely opaque. But if inflation happened, what it would have done is it would have produced gravitational waves, which are ripples in space-time, distortions in space-time, and that would have polarized light. And BICEP 2 people said, we have seen this. Now that is really amazing. That's an amazing claim. But
and this is data that's extraordinarily difficult to work with.
yes, it's very hard to get in the first place. So so of course, anytime you come out and say, oh yeah, we found signs of inflation, everybody is going to say, okay, let's figure out what it could be, what else it could be. And right now, what it looks like is we cannot conclude anything one way or the other about inflation from the BICEP 2 data. That's not surprising because, like Pamela was pointing out, this is a hard measurement. This isn't something you can do with a backyard telescope. This isn't something you can just set out and say, oh, we're going to do this. And you have to have specialized equipment. It takes a long time. And part of the reason that we know now it's a hard measurement to do is because there's dust in our galaxy. And when we say dust, astronomers say dust, we mean very much the same kind of thing you mean in your house. I've been cleaning today, so dust is very much on my mind.
Of molecules that are kind of gross and tend to collect in clumps.
Exactly. And of course, dust is what made planets and stars too. Dust bunnies we came from dust bunnies in a sense. Not quite as hairy as the dust bunnies in my house with my cat. Or I suppose with your dogs, but
yeah, exactly.
But the thing is, though, is that dust is if you look at a dust bunny, you notice that it's strands. Okay, the clumps tend to be strand shaped, and what happens is when dust is illuminated by light from stars, it kind of heats up. Okay, and it emits light that is itself polarized. So you can, yeah, go ahead.
So the punchline for this.
Yes, long story.
The punchline for this is you took the time to work not quite one-on-one, but one with 8 with students, and then you came on with the weekly Space Hangout, which works with CosmoQuest. We're all part of a collaboration, and we worked together to make sure, first of all, we understood what had happened, and then to make sure that the public could understand what happened. And this is what we do with CosmoQuest: is we take the results, we process them, and can you tell us the punchline for this result now a year later?
Well, the punchline is we're still waiting for the punchline. We can say clearly that the initial excitement was premature. We should, this wasn't because of this dust. We cannot say for sure whether there's gravitational waves from inflation there. There may be some hiding in there. I would, but the thing is, the story isn't done. There are a lot more experiments out there that are going to be doing, including one called, predictably, BICEP 3, that are taking data as we speak, and we will know more. And so it's quite possible we could be having a class this year in Cosmo Academy where we talk about this topic again. We talk about how this measurement is done, and talk about, hopefully, probably not as soon as this year, but hopefully at some point we will be able to say, and we'll be able to bring this directly to you in our classes, how we can separate out this dust in our galaxy from something that could tell us about the first tiny fraction of a second after the Big Bang, which I think we can all agree is a pretty phenomenal idea.
And I think one of the cool things that we can now finally say is these classes from here on out are going to be taught through Southern Illinois University, Edwardsville. They're not for college credit. but you can get certificates through our university's continuing education program. And we will be offering continuing professional development unit, CPDUs in the state of Illinois jargon, to educators. And one of the things that we're hoping to be able to do in the future, we don't quite have the money to do it yet, but we're dreaming of a day when teachers can take as many classes as they like, taught by professional astronomers, a lot of us who are focused on communications and science, so we're actually good teachers. Our dream is for teachers to be able to take all of these classes completely for free as part of how they learn to better bring modern science into their modern classrooms.
Because I think we can all agree that the elementary school teachers, high school teachers, junior high teachers, the people who are teaching kids about science, how great is that if they can actually come in, we're speaking to teachers, if you can come in and take a class from people who are experts on astrobiology, the study of possible life on other worlds. This is really exciting stuff right now because we are sending probes. We have a probe orbiting Saturn right now, the Cassini probe, and it has found that the conditions on the tiny moon Enceladus might actually be right for life. There's been a lot of talk about Jupiter's moon Europa, which also might have conditions that could be right for life. These worlds do not resemble Earth at all, but they have this thick shell of ice over a global ocean, which in some cases, some of these moons have more water on them than Earth's oceans. That's a lot of places. That's a lot of place to develop. This is exciting stuff.
And what
bringing that to kids. Imagine bringing that information directly from scientists into the classroom.
And what I really love about what we're doing is this is a chance for people to talk about what they're passionate about while teaching. A lot of times when you're teaching university classes, you're told you need to go teach. I teach computer science classes. You need to go teach about computer hard drives, keyboards, and how the modern computer works to people who are there because they require technology credits. But with Cosmo Academy, one of the classes I'm planning to teach is one that will probably ask you to go through a draft of a textbook that I'm working on. Math-intensive astronomy that helps you understand not just the images that let us know what we're seeing, but the math behind them that gives us context. We're trying to share our passions with you and, well, make them your passions as well. Now, of course, all of this unfortunately takes money, and this is one of the things we've really been struggling with Cosmo Academy, because universities, they come with full infrastructures where there's people who are paid off of state fundings to make sure that everything happens. It's not like we have state funding coming in to, well, make sure someone's salary is always getting paid to keep everything going. You've been the poor soul doing that all along, and we're hoping to turn this into a salary in the future, but we're not there yet. But we're trying. We're writing this proposal to NASA. We will be writing proposals to NSF. I will be knocking on the doors of anyone whose inbox I can get that might be able to help. But right now, you are helping. We are sitting at $19,225, which is still putting us at less than half of what the potato salad was able to get on Kickstarter. The fact that I'm at less than half of what the potato salad brought in, it hurts. The pain. But one of the things that I'm seeing on Twitter that I'm going to ask all of you to do, because it's actually a pretty cool idea, and I'm not sure why we didn't think of it earlier. I see Jeff Seltzer going through and challenging people to donate. I see basically saying, hey, all of you guys, give $20. This is real STEM and it needs your help. so many people are challenging people they know to give and to donate. Hey, reach out to the group that matters to you. Reach out to your personal community. One of the things that I've said, and I keep hoping it'll make a difference, is if everyone who follows me on Twitter donates just $2, we're done. And my programmer, Joe, or actually he's an alumni of our project. He now has a real job. Joe just was like, and Pamela can go to sleep. Things I do to myself that others might science. Yeah, it doesn't take much, but it takes someone taking the time to click that donate link or to go to bit.ly/C Q 2015. It takes effort. And just how low do I have to put the bar before you'll help? A lot of you listening, you have helped, and thank you. But there's so many of you out there using science, doing science. Give to science. Don't just tweet. Don't just retweet. Do something to make this the world you want it to be. And let's conquer that potato salad. Seriously, I am bitter about potato salad. And I'm going to holler at my programmer. Apparently, we have more guests who are downstairs that my dogs are barking at, but we're all in the attic. So some of the folks that have arrived to help can't get into my house. So we're sending help. So Matthew, you've had a long journey that has winded its way through cosmology, planetarium sciences, book writing, and
Let's not bring up the book. Yeah.
Oh, sorry.
That was a bad experience.
Sorry. What we've talked about this some before. We live in a nation where it seems like science is getting slowly defunded, one painful slash at a time. How do we turn this around? How do we get the world we want instead of the world we have?
Well, I don't know. I think that may be a bit above my pay grade to talk about how to fix the problem. But the thing that I always see is that people are very interested in science. It's just that we have been perpetually told that we can't afford it. And at the same time, we're told that we can't afford not to have science in schools. People warning about us falling behind, which is a real problem. There's been a lot of effort in trying to address, things on the level of curriculum in schools to try to enhance education. And again, this is something that I see entirely as an outsider. I'm not in primary or secondary education, but I think people are interested in science. People love science. This is not anything. This is, I think, one thing that has been successful in the internet era and the social media era is that people feel like science is something that they can read about, they can understand. They watch TV shows, Neil deGrasse Tyson on Cosmos, and now his late night talk show. There's all sorts of things where we can. There's all sorts of ways to get science. I'm a science writer. What I do for a living is I write about news stories. In fact, I saw on my Twitter feed, my latest story just came up. In fact, it's relevant to the poster behind me. It's about blowing up nuclear weapons near asteroids in hopes of trying to gently nudge them out of a path that might carry them close to Earth. This is what I do for a living. Is I say, okay, these papers that scientists write are written for other scientists, but we can all understand them if we take a bit of time to, dig into them a bit. This is something that everybody can get, and I think that's one of the lessons that we're seeing more and more is people love this stuff. People want to know more. They want to know about black holes. They want to know about asteroids. They want to know about comets. And I think what we need to do is we need to point this out to those who hold the purse strings and say, look, you're telling us, oh, we have to do all this stuff without money. But people want it. People want science. We need to get that through to the people who have the purses.
We have also this strange perception problem. I encountered it last week. I was in Prague. My job lets me travel all over the world. I have to admit that's kind of cool, but there's a difference between having someone send you airplane tickets so that you can fly to a foreign country and get off the airplane and immediately be on duty doing your job in another country, and going there on vacation. They're not the same thing. And I love what I do, and luckily I can sleep absolutely anywhere. So last week I flew to the Czech Republic to jury the Central European Full Dome Planetarium Film Festival. And while I was there, a fabulous planetarium director, who shall remain nameless, was like, we're getting ready to open our new dome. You absolutely must be there for the opening. And I looked at him and said, I'd love to, but do you have any travel funds? And he's like, I don't think so, but you're one of the most famous, and I don't agree with this, but it was sweet, but you're one of the most famous astronomers and you must be there. And I sort of looked at him and said, well, yes, but I have no money. And he got very confused. You could see that there was this disconnect in his head between but here's this person with 20,000 people who follow her on Twitter. And I mean, there's people like Phil who have 1 million. And there's this disconnect between but I see you on YouTube and you've been on the History Channel, but how do you not have funding? And the truth is, yeah, there are astronomers out there who make lots of money. There are astronomers out there who charge lots of money. There are astronomers out there who charge per talk what I pay with medical insurance and benefits postdocs for an entire year, and the idea that they earn that much in 1 hour, I don't know how to ask for that. That may be my problem, but I'm right now just asking for $36,000 for me to talk for 36 hours. Can't you help? And somehow we need to get people to understand that those of us who are doing this, those of us who are internet famous, internet fame doesn't pay the light bills, and it certainly doesn't pay for Amazon Web Services. And I'm suspecting you have this problem as well, where there's this confusion. But wait, hold on, you've done all of these things. How, huh? Do you deal with this as well?
Oh yeah. I run into people occasionally who think that because I publish articles frequently that, I must have, $100,000 disposable income and the like. Yes, but I'm not as internet famous as many of. Not as internet famous as you are, Pamela, I'm afraid.
Well, so I do have the question: do you have an asteroid named after you yet?
I do not.
Yeah,
I don't think I have anything named for me yet.
So there was one time where I was really put in my place. I was out to dinner with a bunch of other science communicators, including Fraser and Phil, and they started getting into this argument over whose asteroid number was lowest, because apparently that's a thing. And I'm like, I don't have an asteroid named after me. And here they are arguing over who has the lower numbered asteroid named after them. So now you know what happens when truly famous astronomers get together. They argue over the number of the asteroid that was named after them.
Well, if somebody wants to name an asteroid after me, go ahead. But I don't know.
I think they need to find an asteroid and name it Bowler Hat.
There we go. Well, actually, I have appeared as Pluto's moon Nix in a comic strip. That's actually I should talk to my friend who drew that comic to see if we can do a revival of that this summer when New Horizons arrives at Pluto. In fact, I think New Horizons should be seeing Nix fairly soon. I think they said as soon as next month it should be able to see the moons of Pluto that have already been spotted. I mean, other than Charon, which Charon's a gimme. Charon's almost as big as Pluto is. So,
I'm not sure it counts as a moon at that point.
yeah, well, that's we can get into that later. But I've always felt that if Pluto's a planet, Charon has to be as well, because they're comparable in size. They probably have
And the center
a
of
twin
mass
birth.
is external to the surface of Pluto. As soon as your center of mass exits the primary body, you are now binary, not moon.
Yeah, it's a binary world as far as I'm concerned. So if one's a planet, the other's a planet too. And I know we wouldn't get any criticism from the likes of Alan Stern on that one, because I think he says that Charon is a planet. But in fact, I'm positive he says that. But no, I mean, I have appeared in that is one of my moments of fame, was appearing as Pluto's moon in a comic. But in my bowler hat, of course. But
so we are currently sitting still. You guys are breaking my heart. I love you, but you're breaking my heart. I said earlier in this hangout that Keats wrote about a love as constant as the stars. Well, stars explode. Don't be a star. So
your
we're
love is
currently
constant as a
battling-
black hole, which is stable over many trillions of years.
Yeah, but it's a dead star, and I don't want to have a love affair with something dead. I'm just not that kind of a girl.
Oh, I love black holes. Black holes. I love black holes so much. And I can talk about why I love black holes, but let's. You pledge lots, and I will tell you exactly what I love about black holes. Why black holes are my favorite things.
And hopefully we will get to the point that you can teach class after class about why you love black holes. But for now, we're sitting at $19,295.42 of awesome. Now, there is this potato salad. I keep talking about this potato salad. This potato salad wasn't special. It wasn't great. It was just potato salad, and it wasn't even grandma's potato salad. It was some dude's potato salad. He may have been a nice dude. I don't know. I don't know him. I just know he raised $55,000 on Kickstarter for potato salad through crowdfunding. Probably a nice potato salad. Now, wouldn't it be a shame if something happened to that potato salad? We don't want to do harm to any potato salad, but I'm currently feeling like doing harm to potato salad. So why don't you give? Why don't you go and you can find this image on our Twitter feed and, well, work on getting people to donate to support science, to support CosmoQuest, doing science, learning science, and creating opportunities for teachers to learn, for people at home to learn, for anyone, in fact, who just wants to spend some time with 7 of their newest friends and 1 instructor in a class taught about something that the instructor is passionate about, to classmates who are hopefully going to become long-term friends, peers, and future collaborators as we all work to explore our universe. Please give. Do not force me to do harm, at least mentally in my head, as I think angry, bitter thoughts towards it, to potato salad. It's amazing how the job we have is so different than the job we imagined in graduate school. When we were in graduate school, we were told, you're going to spend the rest of your life doing science, and as long as you publish results, as long as you work hard, you will succeed. They don't tell you about the begging on the internet for money. I don't think that existed so much when I was in graduate school. We had the internet, we did indeed, but crowdfunding and crowd science, well, we had the AVSO. Crowdfunding wasn't so much of a thing unless you remember the NPR telethons. We're now at $19,360. We're not slowly creeping up on the potato salad. We are maybe growing moss toward the potato salad. How do we get people to understand we're people who just want to do science? I don't understand how to convey that message in a way that gets people to understand that when science is funded, it's it's funding jobs, it's funding careers. It's not just giving money to people who are doing weird things in the ivory tower. There's so many misunderstandings. How do we communicate that out, Matthew?
Well, I don't know, but I feel like there is sort of a myth that scientists are somehow wealthy people, and well, okay, maybe a handful are, but most scientists, there's a great comic, and I haven't been able to find it in ages. I need to, but it's two people talking at a dinner party, and one of them saying to the other, "My biggest mistake was going into cosmology for the money." And this is a very much true. It's if you think that if you're going into science to get rich, you're picking the wrong field. It is possible to do it, but it is very rare, and most of us do it because we love science and we can't think about. It's hard for us to think about doing anything else.
Yeah.
It's more than just it's more than just this is a default path. This is something that, it's an easy, obvious thing to do. This is something that people make serious sacrifices. They will take all sorts of hardship for the ability to do science, and it's not something that if you want to get rich, there's far easier ways to do it, and in this era where there's less and less government support than ever for doing basic science, people are looking elsewhere, and they're looking at crowdfunding. They're looking at can people help out? If you love science, if your tax dollars aren't going to helping science, maybe think about throwing a little money into other places, funding science directly. Again, this, understanding how all that works is well above my pay scale. It's, I'm not a rich man either, obviously. But science is something that Science is really what I love best. It is something that I have the strongest affinity for. My Twitter biography says you can't get me to shut up about this stuff, and it's true. As you can probably tell from this little conversation, this is who I am. This is what I do, and I hope you will throw a little money our way and help us keep doing it.
We are currently sitting at, reloading the page and hope the numbers change. We are currently sitting at $19,381. So we're making progress slowly. We got $21 in the past 3 minutes. And I really appreciate all the people who give $3, $6. All of it matters. All of it adds up. Our average donation is $30. And so that tells you that while we do have the $1,000 donations, for which we are immensely grateful, if just 36 people gave $1,000, we'd be done. But at the same time, if we can get 1,000 people to give $36, how much more does that say that science matters in a way? So all of you, all that you do, all of it matters. And I see you out on Twitter threatening the potato salad. I love that we're threatening potato salad as part of this hangout-a-thon. If you're going to have an enemy, make it potato salad. And so we're doing the best we can, and we're trying to create a world. But this is not a humble brag. I don't mean for it to come across that way, and it's inadvertently going to. When I went to Michigan State University my senior year, our university president was asked to testify before the Senate subcommittee on science and technology on the Democratic side. And he grabbed a student to take with him. And it was known even when I was an undergrad that I could actually talk coherently in front of people. It's a thing I do. And so I was taken along to be the science student. And I remember as part of what I said during that subcommittee hearing, when you fund science, you fund dreams. I was lucky. When I was a high school student, there was a researcher at Haystack Observatory who had some extra money. And he was able to say to me as a student, hey, why don't you come work at the observatory? So instead of doing like a lot of my high school friends did and flipping burgers or serving ice cream out at Kimball's ice cream farm, Kimball Farms ice cream in Westford, I got to work on VLA data. I got to work to study T Tauri stars. When I got to Michigan State University, I got to study pulsating variables. This to me has been a long-term dream, getting to follow my questions. And they always tell us, if you're smart enough, if you're good enough, you can keep going. And we're people who've spent our entire lives having to be in the top 3%, top 10%, the top 1% every turn that we're at. And at a certain point, it's no longer quite good enough to just be the best. You also have to be lucky. You also have to not be the wrong person to get the wrong congressional funding cut, wrong state funding cut. The university I'm at, the state of Illinois, has cut our budget 19%, it looks like. Things aren't final, but that looks like what the final numbers are going to be. And that is huge. That means there are faculty members who are going to lose their jobs. You worked at a planetarium that deeply suffered under funding cuts. We're facing NASA funding cuts, NSF funding cuts. It's not good enough to be the best. It's also a matter of not getting stepped on by Congress. But the tax dollars Congress takes away from us. Some of you have tax refunds. We broke even this year. Maybe you can give a little of that. Some of you know people who have tax refunds. Give away somebody else's money. I'm in favor of that. But help us move forward. I'm trying to figure out, I just had a chart passed to me. I'm trying to figure out what this chart is. Money stuff. Oh, this is awesome. Can you put this up? Okay, so for comparison, different things. We have, and I'm, okay, is this live? This is live. So we're trying to raise $36,000 this weekend. So far, we've brought in $19,331, which is enough to fund a graduate student for a year and a half. Now, for comparison, the gold Apple Watches, which sold out within about 2 hours of them getting launched, that's $17,000. If two people who bought gold watches instead gave that money to science, we'd be done. The potato salad, I'm gaining greater bit. I'm gonna say that my evil nemesis is the potato salad. My evil nemesis, the potato salad, got $55,000 on Kickstarter. And there are a lot of people, and we're going to have to Google how many is a lot. There are a lot of people out there who've spent $200,000 to reserve a seat to fly on Virgin Galactic. That $200,000 would pay the salaries of everyone that we're currently working with. And I'd like to think that we're as valuable in our own way as that couple of hours that you spend in that spacecraft that probably causes you to puke, because that's what zero G does. I promise I will do nothing to induce vomiting. Potato salad does that too. In fact, two of the things on this list can cause vomiting. CosmoQuest is not one of them. So won't you support science?
Guaranteed to be listeria and salmonella free.
Exactly. So yeah, let's. Wouldn't it be a shame if something happened to the nice potato salad that brought in the $55,000 on Kickstarter? Make me stop being bitter towards the potato salad. Anyways, I don't know if this is helping. I don't know if this is doing anything other than amusing the people in the room with me. And Matthew, who's virtually in the room with me.
Yes.
We're now up to 19,491, so we're slowly making progress. Let's keep going. Tweet, shame your friends who like science into giving money to science. We can change the world.
And
If
I have
you could
promised
what was that?
that I have promised if we were talking about our path as scientists, I have promised to share a photo of myself from 20 years ago when I was an embryonic physicist, to show me in 1995, back when I had, let's put it this way, I'm looking at the photo right now, much more hair than I do today. It's rather impressive, and actually a lot more glasses too. Man, the 90s were horrible about
And
glasses,
I will
weren't they?
actually take that challenge, and I have some photos from 1990 of me at space camp that I'll share.
There we go. Did you have 80s hair?
Okay, I'm being told to set a target. If we can cross $20,000 in the next 10 minutes, no, that's unreasonable. I will be nicer than that. I'm being told, no, there's only $600. Go for it. Okay, if we cross $20,000, I will share pictures from middle school when I had awesomely big hair.
There we go.
So let's get to the 20K, and I will share pictures of when I was an embryonic scientist with big hair. Yeah, I'm being told we're now making humiliation part of the game. What caused you to go from science to science communication? You're a theorist. You could have spent your life working with computers and pens and paper. And what made you interact with humans?
I don't interact with humans. I'm a writer. No, ha. I was teaching at a small liberal arts college, and the way it often works in these days is a lot of instructors are, not permanent employees. They're on contracts that last a few years. And I was doing a 2-year teaching job at a small liberal arts college. And when that position was starting to run out, I had landed a class assignment that was kind of fun. It was a class where, unlike most of the classes you teach as a scientist, was a class that was based on reading and writing. My class was science versus pseudoscience. I designed it myself. It was a lot of fun, but since I was making my students write, I thought, okay, well, it's only fair for me to write too. So I started a blog, because I'm not going to write essays for my students to read, force them to read those. But I figured, well, if I put it online, at least I'll have a platform and an excuse, and probably get 20 people to read it, maybe, and that's what it was at the beginning. But then when the position ran out, and I was thinking, okay, do I want to move every 2 years for the rest of my life? Not really, but I enjoy writing, and I found that I really enjoyed writing. I have always enjoyed writing. It's just that, when you're doing academic writing, when you're writing research papers, it's kind of a chore, and it's also, if you're writing a technical paper, maybe a few people will read it, because there's a lot of scientific papers out there, and you're writing primarily for the people who do the same kind of thing you do. If you're writing a popular article, for a magazine, for a website, whatever, you might get a lot of people reading it. I have no idea how many people read some of my articles, but I know it's a lot more than have ever read any of my technical papers, and ever will. They're not anything that's going to change the world. People have said things like, oh, you're jealous because other people got a Nobel Prize or something like that. It's like, no, most of us who do, if you go, just like getting rich, if you go into science to get the Nobel Prize, you're way misguided, because most people don't win Nobel Prizes.
No, that's entirely true. And it's amazing to talk to people who think that they will get the Nobel Prize, because there are people out there who, for instance, if they think a discovery is interesting, will not share the authorship with more people than could share the Nobel
Right.
Prize.
Yes, and I know who you're talking about. I know the specific person you're talking about. But again, it's like this is not the reason we do it. And so, when I realized that, I can actually explain things to people, and people will actually read what I write. That was actually a pretty fun discovery. Teaching is another way of communication. I think some of the articles I write are still in the teaching mode. So I don't see a strong distinction between the kind of stuff I do with Cosmo Academy and a lot of the writing I do. It's all about, can we take science that takes, a lot of the esoteric science, a lot of the cutting edge science can take decades, literally, to get to the point where you can understand all the ins and outs of it on the basic technical level. But everybody can understand the concepts by this process of teaching it, of writing about it, and frankly, by explaining it to other people, I understand it better myself. So this partly a selfish thing too. It's like, I want to understand everything there is, and so one way I can understand it is by teaching it to other people, to talking about it, writing about it. I think your mic's off again. I think your mic's off again. Never mind.
So we have experimentally determined that people do not want to see what we looked like when we were younger and more beautiful. In the time since we made that offer, we have had $0 in donations come in.
Okay, so that's the opposite tack we should be taking. I will burn my picture if you donate enough money. Nobody will ever see it if you.
I was just handed $20, and we'll add that to the tally. It doesn't get us up to the 20,000 goal, but it does get us $20 closer.
I literally have the picture in my hand. It is right here, hiding.
So yeah, I'm kind of sad. Oh, it's hard doing what we do, but how many people can say they've gotten to follow their passions their entire lives? I think that's one thing that through all of our struggles, we can say we have most of the time managed to find a way to keep doing.
Yes.
And the writing you're doing is leading to amazing graphics on your wall. Can you, before you take off and we bring in the next guest, tell me the source of that awesome poster of Spacey Revenge?
If you have read the comic strip Saturday Morning Breakfast Cereal by Zach Weinersmith, this is from this is from his website. I believe he still sells this poster, and of course it depicts an angry Tyrannosaurus in a spacesuit charging asteroids and shouting revenge. And when I saw this poster, I knew I had to have it because dinosaurs and asteroids. I mean, what more can you want?
We crossed $20,000 as soon as we took showing the pictures off the table.
There we go.
So apparently the key is to not show pictures of ourselves when we're younger.
There we go. So what is the lesson we have from that? Do we show the pictures, or do we say that was the opposite? Did anybody put strings on their gift to say, I'm only giving you this money if we can see Matthew's curly hair and Pamela's big hair from...
I have no idea. So yeah, if you don't know Saturday Morning Breakfast Cereal, I mean, there's certain comics out there that are must reads, and Saturday Morning Breakfast Cereal and XKCD should be two that are on your list. And
there's a lot of science in both of those strips. They're not specifically science comic strips, but there's a lot of science in them. And so if you love science, you would probably enjoy these strips very much.
And both Randall Monroe and Zach Wiener-Smith, I can't say his last name. Both of them are people that have done a lot to support science education, along with the author behind PhD Comics. There's some really good people out there looking to use their art to communicate science. So show them some love by showing them some, well, reading of their comic strip. So we're sitting pretty at $20,061, which still leaves us $25,000 behind the potato salad, my arch nemesis. We are slightly ahead of the price of an Apple Gold watch. We are at 1/10 the cost of a reserved seat on Virgin Galactic. When you start comparing what these numbers are and what they mean, we're trying to accomplish a lot, but what we're asking for to do it just really isn't that much. So as you look at, well, what it is that you value, what it is that brings you a little bit of joy, if we're more valuable than potato salad, let us know. So it's been really great having you on, Matthew, even if we did sort of wander the conversation all over the place, which is part of the fun of having you on.
I was going to say, did we have an agenda? I didn't get one.
No, not really. No.
I didn't even use my props, though. I've got Admiral Akbar, because actually we should have done that on the hair thing. You know, it's a trap to...
So if you could leave our audience with one thought, what would that one thought be?
Well, the thought I have is, if you love science, in this era where science is facing continual, more than continuous. I blame lack of caffeine today. Continual funding difficulties on the national level, and not just in the United States. We're hearing bad news from the UK and from Australia and elsewhere. If you love science, the way to support it is active participation. Participate in citizen science projects, take classes, donate money when you can. I know not everybody can. It's you know, hard times for many of us, but if you have the money, if you have the spare money, you throw a little bit toward the projects that you love, because if you love science, you can own it. You can be part of it, and this is one way you can do it. So I hope you are enjoying the Hangout, and I hope you will consider taking our classes when they resume. And I hope that you will support science in whatever way you can and however you can. And feel free to say hello. Just let us know that you support the kind of stuff we do, and that's something that we appreciate very much as well.
Thank you, Matthew. As always, it's been absolutely great having you on, and here's to making it a more scientific universe, and I'm sure that we'll be continuing to work together on the Weekly Space Hangout, on Cosmo Academy, and so much more. And thanks for just being another person who's trying to communicate science out to the masses.
Thank you, Pamela.
And coming on next, we have Greg. He is a retired professor from George Mason University.
Anybody.
Hello, can you hear us? We see Greg's icon. He's apparently still working to sort out his technology. While he's doing that, just to go over things one more time, this is the CosmoQuest 36-hour Hangout-a-thon. We are spending our weekend bringing you awesome guests.
Pamela, I cannot hear you if you can hear me.
I can hear you. We are working to tweet towards you or message towards you. We also can't see your video, so looking to see if the folks in the green room can give us some information.
Pamela, can you hear me?
Yes, I can hear you.
Okay, I can't hear you.
Okay. Not sure how to fix this other than asking people to
Try leaving and coming out. Coming back in. Okay, I got it.
what
Okay, I will try that.
So, okay, while Greg is working to sort things out, for those of you just joining us, as we hit the 1 o'clock hour here in the Central Time Zone in the United States of America, we are continuing our 36-hour Hangout-a-thon. We are working to bring you guests who are talking about science, science education, and art related to science. Mostly we're talking astronomy. And as we do this, we're also trying to raise science itself, getting people engaged in participating in science at cosmoquest.org. We have rearranged our website to make it possible for you to both watch this hangout and participate in doing science. To look at the numbers as we race the worlds, we hope all of you watching are working to do your part to do science. Moon Mappers is at 899 images, Mercury 914. Vesta is pulling ahead with 1,510 images completed. Mars, a project we launched yesterday, thanks to donations from you that happened in the past year, it's at 1,185 images. And as a reminder, if you'd like to see Ceres join the CosmoQuest family, we have to finish Vesta first. The data that we use to map out these two little asteroids, well, actually two giant asteroids, is coming from the Dawn mission. And they want to see Vesta done before we bring in Ceres. So let's finish one so that we can do the other. I wish I knew how to fix poor Greg's problems, but
I think we're okay.
you can hear us now. Okay.
Yes, I can.
That's absolutely awesome. What was the solution?
Click back out, came back in. Everything looks good and sounds fine to me, Pamela.
Okay, I guess it's the old kick the machine until it works problem.
Right.
The beatings shall persist until morale improves.
It's all in the technical crew. They're a great group.
I do want to do a shout out to all of our volunteers, and we've been joined by two new volunteers here in the attic where we're doing all of our shooting. We've been joined by Greg and Victoria Wells. Dang it, sorry, his name's Greg, your name is Eric. Okay, it's been a few hours, folks, I'm sorry. We've been joined by Eric and Victoria Wells here in my attic, who are now laughing at me, which I deserve. And Chris Miller, as always, is here running production. In the green room right now, we have both Richard Drum and Jim Meeker holding down the fort and making sure that all of our guests are able to transition in as smoothly as the technology allows, which isn't always as smooth as we would like. This entire Hangout-a-thon was actually organized by volunteers. I had a bit of a, oh dear, I have a lot of work to do because I'm currently working on a proposal to NASA that, if successful, will mean I don't have to beg for money next year. Instead, I can simply say, hey, come do science. Let's hang out and do science for 36 hours. To give me back the time needed to work on that proposal, I turned to a group of, volunteers who really bailed us out. Nancy Graziano, Jim Meeker, Guido Bibra, Matt Woods, Eric Wells, who's here, Victoria. What? You're laughing. You guys, they're breaking me. They're breaking me, folks. Richard Drum, Aviva Yamani, so many others. Fraser Kane hosted through the midnight hours. Mike Simmons, whose name I'm also determined to mispronounce, was on to give us a break for a couple of hours earlier today. So many people, Christy McGonnell, I could just keep going, have all been there to help make this happen. You are there making this, well, Success, we're still working to determine, but we're making progress, folks. We're slowly, I see the tweets keep going by. Our donations are currently at $20,181. We are still at less than the potato salad that I'm getting bitter towards. If you give, the person who gives the largest amount of money, last year it was $1,500. These dragon eggs that are sitting beside me are now part of a tradition. They go to the largest donor who gets their name engraved on the plaque in the case. And if the eggs hatch, you have dragons. And if not, like the dragon eggs in Aragorn, they get passed on to the next person and the next person, adding the names to the list inside the box. We also have 2 3 random people who have contributed science or contributed money or both. We're hoping for both. We have 3 meteorites. We have 2 Indigo Night posters. We have 2 $200 gift certificates to iTelescope. We have 5 books by Sarah Willis, Your Place in Space, and we have Surly Amy pendants. Help, please help. We did a chart up earlier and realized that, well, an Apple Gold iWatch is $17,000 and sold out in a couple of hours.
Wow.
That's just something you wear on your wrist that tells you how many emails you're ignoring. Our goal is $36,000. That's basically 2 iWatches. It's a little bit less. It's a little bit more than 2 iWatches. There is space tourism. For $200,000, you can reserve a seat on Virgin Galactic. Or for $200,000, you can basically pay the salaries, not the insurance and benefits and everything, but the salaries of everyone who will be working on CosmoQuest this year. And there's that potato salad, my evil arch nemesis. It raised $55,000 on Kickstarter. Isn't science better than potato salad? So we're hoping that in this next hour, well, we have until 10 p.m. tonight to get to 36,000. How much closer can we get this hour? I'd love it if we could get it to 22. I don't know if we can get to 22. Can we try? Folks, can you challenge everyone you know? Hey, if you enjoy that Wi-Fi connection, that's astronomy. That was radio astronomy that got that Wi-Fi connection. I'll give you back your Wi-Fi connection if you donate money to CosmoQuest. How's that for? I'm apparently getting punchy at this point in the day. So to stop spieling, now that we have Greg with us, welcome, Greg. I'm so glad that you got things working. You have a PowerPoint presentation.
I sure do, but it's not going to be death by PowerPoint, Pamela. I think people will find this to be a very interesting subject. And I have to say, I've been a fan of yours for a long time, and it's a real honor to meet you at long last, and let alone be on CosmoQuest. Come on, people, hit that donate now.
So you're coming to us. You're a retired professor from George Mason University, and you were part of the space age, and you're here to share with us a little bit of history of manned space, from what I understand.
And where it's going to go. Most importantly, a lot of people don't know what NASA is doing, and good luck on your NASA proposal, by the way, but a lot of people don't know what NASA is doing in the U.S. manned space flight arena. But I guarantee you, Pamela, by the end of my presentation, they're all going to be up to speed on the right stuff.
well, let's talk our way through this instead of death by PowerPoint. So,
right.
So where are you taking us first?
Where we want to go with the presentation when we start that is people are going to learn about why I wanted to do this presentation, the genesis, talk about where we are in terms of the U.S. manned spaceflight right now, and what we are going to be doing in the next couple of years. NASA is building some new spaceships, some new rockets, the Commercial Crew Program. We're going to talk a little bit about the year in space. So, as I said, by the time we finish up, people are going to know what NASA is doing and how they're doing it, and it's a fascinating story, Pamela.
Okay, so let's get started.
Okay. Over to me now, right?
Yep.
Well, everybody, welcome. Again, This is a really good donation process. Science is important. And there was a great line in a movie called The Right Stuff. And the line said, no bucks, no Buck Rogers. So it takes money to do science and to put people up in space. So what is the future of U.S. manned spaceflight? The cover picture here is of the moon and Mars, which are two of the three destinations NASA wants to go to. They want to go back to the moon in some capacity. Mars is definitely on the radar, and the asteroid belt. Now, for me personally, I was inspired to do this presentation when I saw this tweet that said, when will we use this again? And this, of course, is the famous countdown clock that was used for all the Apollo missions. And on this KSC, Kennedy Space Center tweet, July 22nd, nothing's on the pad. The countdown clock is dark, which, by the way, has been replaced by a new unit. And NASA itself was wondering, when will we start sending U.S. astronauts back to space? But as we all know, space is not easy to get to. Launching rockets, it's never a done deal. This was the explosion at Wallops flight facility earlier in the year. We had two big accidents. We had this one of the Orbital Sciences Corporation booster blowing up about 16 seconds after ignition. And then, of course, we had the first spaceflight fatality since Columbia, when Virgin Galactic, their space plane, had a apparent breakup in flight and killed the co-pilot. And that is under investigation by the National Transportation Safety Board, as well as other governmental entities. So what is the state of the American U.S. manned spaceflight program?
Hey, Greg, your slides are actually not quite fitting into your display area. Can you turn off the investigator on the right and fit your slides to the screen at least?
If I hit play and it takes it up all the way and I just hit it, will it work there? Let me try that.
I think if you hit play, it actually breaks things, but go ahead and try. We'll find out.
I won't do, okay. What are you seeing now?
Black screen.
Okay, let me go back. Let me try to do this. And I apologize, I'm new to this, so hang on. Let me see if I can do, hang on.
So honestly, we can just talk if you turn off screen share so that we can see you instead of your slides.
All right,
let's talk about the future.
All right, let me do that. I'm sorry about that.
No, it's okay. So you were talking about Virgin Galactic, and this is something that came up earlier when we had Charles Black on. Virgin Galactic, this was a horrible tragedy. They were up with Spaceship Two at, what was it, 54,000 feet when they lost structural integrity for reasons that are still being sorted?
Yes. And it was, as I said, the first space fatality since the Columbia accident. And the thing I want our audience to understand is we are always thinking that space flight is so easy. Everybody sees these rockets launch. Everybody sees that we're trying to do space tourism. It is not easy. Every time that you light a candle on a rocket and send it up, there are risks. So when the space shuttle program retired, maybe our audience is not aware, but when the space shuttles retired in 2011, the United States lost its capability, its indigenous or inherent capability to put astronauts up into space. And that's when we had to rely on the Russians at approximately $76 million. That's $76 million a seat on Soyuz. And at the rate we're paying that's roughly equivalent to about $500 million, yes, $500 million a year that NASA is having to spend or pay the Russians to gain access to the International Space Station. But that's coming to a close, or at least a modification in the next couple of years, because NASA now has the Commercial Crew Program. And NASA,
and this is,
go ahead.
This is actually something where we're looking at multiple different ways to gain access to space.
Yes.
We have the Space Launch System that's being worked on by a consortium that considers the usual suspects of Lockheed, Boeing. We have SpaceX with their Dragon capsule, which they're hoping is reaching the point of human space flight. I believe X-Corps is the other person who's been awarded a contract. Am I correct on that?
Well, there's two that NASA has awarded to specifically, and that was Boeing with their CST-100 spacecraft, and then SpaceX with their man-rated Dragon Falcon combination. Those are the two right now.
And so right now we're in this horrible place, like you were saying, $76 million a seat. For comparison, NASA, the budget for all of education and outreach is just over $100 million. So while $1 billion isn't a lot if you're a general in a war, or if you're building a military aircraft, $1 billion is a lot when you're NASA with very, very limited funding.
And while you bring up the subject of numbers, Pamela, people may not know, but the entire budget for NASA for FY 2016 is 18. That's $18 billion. And that's not just spaceflight. That's James Webb Space Telescope. That's all astronomy. It is aeronautics. Everything NASA does, and sometimes people aren't aware of everything NASA does. Earth satellites, weather support, all of the NASA missions, all of that comes out of that 18 billion, including the building of the new Space Launch System, the Commercial Crew Program, and of course the Orion spacecraft.
So when you start hearing these numbers, it suddenly makes the 36,000 that we're trying to get with Cosmic Quest seem like, well, less than peanuts. But apparently, while it's less than potato salad, it's more than we can get. NASA's been struggling to get its budget, but with every dollar it gets, it stretches as far as it can.
Really
How
does.
is it stretching to help us get back up?
Well, the main thing that's going on right now, Pamela, besides Commercial Crew was designated to provide access to low Earth orbit and primarily the International Space Station. That's what the Commercial Crew Program is for. NASA made a decision that says we're going to get out of the business of sending people to the International Space Station. And it's really good that this is a two-program contract award. And I've seen some criticism from Congress saying, well, why are you paying two people? Simple answer is, you got an accident on one system, you've got a backup system. Every time that we've had some kind of an accident, we've had to stop flying. So God forbid any accident happens to either program, you've got the other program as a backup. So you've got assured access for manned space flight on America going to the International Space Station. And then NASA said, we're going to take on the big projects. We are going to go to the moon someday, Mars, that's the big one, Mars, and the asteroid belt. We are going to go, we, NASA, are going to take astronauts beyond low Earth orbit. And to do that, NASA is building the Space Launch System, which will be the largest rocket ever built, and the spacecraft, the manned spacecraft to go with it, the Orion multi-purpose crew vehicle, which will be able to take astronauts to those destinations. That's what NASA's doing.
Now, as to build this brave new future, there are people asking, why is NASA spending money putting people in space? It's awesome when commercial space does that, because commercial space is looking to make space profitable.
Yes.
But NASA nominally is going to space to make it scientific. Robots. So why are we putting people in space?
I hear that an awful lot where people say, well, why are we spending money on humans and why aren't we doing all robotic? Well, the bottom line I always say is that you really need to have both. Robots are always going, you can't send humans, and the robots will be the ones that pave the way for humans to go. Being a child of all the way back to Mercury and so forth, so on, I truly believe that in order for the human race, our species to survive, we have to be able to go from the home planet to other worlds to set up other colonies, for lack of a better term, or in a non-military sense, bases, so that we have enclaves in the solar system from which we can get natural resources, where we can exploration, plus We also have the species off the planet in case of, heaven forbid, an extinction type event that takes out civilization like the dinosaurs, but hopefully we'll be able to beat that someday. I mean,
And
we really got to go in space with humans as well as robots.
and I don't disagree with that, but it starts to become a question of we have limited finance.
Mhm.
And the one argument I've heard that really, I think, to me at least, makes the most sense is as we're starting to figure out how to explore, there's no replacement for, well, the human thumb. Canada built amazing robotic arms, but at the end of the day, it wasn't a robot that serviced the Hubble Space Telescope.
Absolutely.
It was a human. John Grunsfeld did amazing work. So did the other gentlemen that he worked with across the years. Humans, well, we are the animals with thumbs and fingers and brains that allow us to figure out how to build things, how to fix things. And, well, I think if you read the book The Martian by Andy Weir, it details
have.
all the things that a human can come up with when they're stranded because everything went boink in the night. We are the
Can you
great
imagine,
construction workers.
Pamela, can you imagine building a robotic equivalent that would be able to bring back at one time several hundred pounds of lunar samples? Being able to go out there and, wow, there's orange soil. Wow, there's a Genesis rock. I mean, it has to be both. And one thing I'd like to address as far as the cost, I mean, $18 billion is so small when you compare it to the federal budget. And as I'm fond of pointing out to my audiences, I'm an animal lover. But people in America in 2013 spent $65 billion. I'll say it again, $65 billion on just pet food. The greatest criminal, white-collar crime criminal in U.S. history was afforded a $250 billion fine for his crimes. So you compare to what the U.S. manned space, or excuse me, what NASA's budget is, and I've done articles on this and talked about it. NASA does more than just space flight. I think there was one study that said for every dollar spent by NASA, there's a minimum $8 return. Your MRI, Velcro, electronics, computers, GPS, weather forecasting, improvements in air traffic control. The list goes on and on and on. And people don't realize, Pamela, that all gets back to NASA.
And this is where programs like CosmoQuest are working so hard to try and get people engaged, to try and get people thinking more scientifically. But the problem that we're dealing with is, well, since sequestration, we've had a whole lot more forbidden expenses than we've dealt with in the past. We've been told you're not allowed to do, well, communications.
Yeah.
What, huh? We've been told you're not, we've been told so many, you can't, you shan't. Oh, by the way, we're sorry, but we have to zero your funding now because Congress.
Yeah, let's don't even talk about climate change and what one proposal is about taking Earth science and Earth monitoring and all that away from NASA and putting it elsewhere. But I mean, there's other governmental entities that depend on NASA for those Earth satellites, those weather satellites that access to space. And I'll tell you, one thing is that some of the people in Congress are pro-NASA and like to see a little bit of an increase because they don't like the reliance on Russia for things like rocket engines to support U.S. commercial missions. That's a big thing right now. The whole thing about the use of Russian engines and wanting to get back into space with U.S. assets. So you're dead on with what you're saying there, Pamela.
And this is where sometimes we have to take back what's going on and make it our own and be the change that we want to see, not just in the world, but in how we see the universe. Mm-hmm. This is part of what we're doing with the Hangout-a-thon this weekend is we're trying to say, okay, so Congress is not going to give NASA that penny on the dollar of taxes. That's just not going to happen. But maybe you can give us a penny for every dollar of your taxes. It's possible. Unfortunately, the money has been slowing down. I know this is because so many of you out there have already given everything that you can give, and I'm so very grateful. We're currently sitting at $20,000, $20,218 in donations. And I'm so grateful for all that you've done. I'm so grateful for all of your tweets. I have so many people in my Twitter stream saying they're here to help, challenging other people to donate, to give, to do science, to threaten potato salad, my arch nemesis. I can't change what Congress does. I've tried going to Capitol Hill and talking to my Congress critters. It really doesn't help a lot in the short term. It can help in the long term. But you can help in the short term.
One thing I tell my audiences too, that they are, for the most part, taxpayers and they vote. So that's a pretty powerful weapon. And I'm thinking that as we get closer to things like James Webb Space Telescope, October 2018, plus in the next 2 years, roughly, Boeing and SpaceX should have their man-rated vehicles ready to go. And the big point will be when we get Space Launch System up in about 2018 for a test launch. That's going to be something for people to see. Did you see Exploration Flight Test 1 on the launch December 5th of last year, Pamela?
I did, but one thing I have to say is all of this stuff is great coming down the pipeline. It's very engaging for people to be thinking, hey, we're going to start getting NASA astronauts flying NASA assets again. But the problem is trying to survive until then. We're looking at massive layoffs in science. We're looking at losing an entire generation of people who've spent 10 years of their lives in university, who have been the valedictorians, the salutatorians, the top 10 in their high school, who've gone on to be the top 10 in their university, who've gone on to be the 1 or 2 graduating with a PhD from their program. And now being told, we're sorry, we don't have money for you. This is what's happening, is we can't wait to see people get enthusiastic in 2018 when we start launching again, if it happens on time. We can't wait. Last night at the American Astronomical Society meeting, if we were walking up to one another and saying, hey, when's your funding end? What's your expiration date? Right now, all of us have an expiration date of September 30th. That's when all of our existing NASA money ends, and we either get successful funding off of the current cooperative agreement notice, or we find new jobs. The scientists who are applying for funding, there's less and less of it. It used to be 1 in 5 you'd get your proposal. And women, we pretty much 20% of the time are downgraded an entire mark based on our gender and gender bias that builds in. Study after study has shown that there is subconscious bias in who gets funding. But when you're at 1 in 5, you can still make it as a woman in science. But now it's more like 1 in 10, 1 in 20. One of the grants I applied to, I got back a rejection letter that said, we funded 1 in 30 proposals. We can't even send you back comments. It's awesome to imagine that we're spending these billions of dollars on manned spaceflight. But where is the $65,000 for the postdoc who just finished his PhD and is being told, we have no jobs for you? There's no more funding for Mars because we spent it all on Mars Curiosity. How do we save the lost generation? Well, the last of the Apollo generation holds on to the jobs.
Well, it's like I've always said, it goes back to either Congress providing funds to be able to invest in our infrastructure and our future, or maybe the opening of space I'm a big believer in the private sector becoming the space private sector, being able to put things out there. But I agree with you 100%. And sometimes Congress is going to have to wake up and realize that if they don't do something, we're going to fall behind the power curve of other countries. I mean, Japan's getting ready to send a mission to the moon. China will probably have the next humans walking on the moon in terms of taikonauts, and you've got to keep that flow of brain power going in to government and private industry. I'm a total believer in that, but it's got to be coming from either the private sector or Congress. They have to do that. There's no other options. They have to.
Well,
And
the other option is what we're doing right now is we're saying we're going to have to do this on our own because they're not listening. We haven't had any of the commercial agencies step forward and say, hey, take this money and go do education. Take this money and design projects to launch on our vehicles. Instead, they're saying this is how many $1,000s it will take to launch your science fair project. And yeah, they're giving discounts. But I work with schools that can't afford paper. It changes your perspective.
And that gets back down to the whole problem about funding of the infrastructure and so forth. I mean, we have had, I've seen it too, where you've got the educational funding ends up going away. I think that is a nationwide problem, and it's going to require a nationwide solution that trickles on down. And unfortunately, I'd say to some extent we're in tough times, but then I keep hoping that at some point everybody will wake up and start working together and realizing that we've got to invest in our future. And when I say future, I'm talking about the present, which feeds the future. We can't wait.
And
we
there
keep
are
getting
those of us who are working to make that change happen in our spare time, because that's all we can do. Just as a heads up to those of you out there listening, we're sitting at $20,358 in donations at this point. We're looking at a year and a half of graduate student funding, and still less than half of what Potato Salad earned on Kickstarter. And those of us that work on CosmoQuest, those of us who you're raising money to help support, we're trying to implement the needed change, and we're having massive results. Except we're fighting the fact that everyone kind of expects us to do this for free because that's what good people do. We're working with the Galileo Teacher Training Program that has over 20,000 teachers engaged in getting their students to do inquiry-based activities in the classroom. They're working on trying to use astronomy to develop our global society, to get people engaged with not just astronomy, but technology, engineering, mathematics. We're trying to create a more scientifically literate world. We're doing it by working 20-hour days sometimes. I'm working a 20-hour day today. We're doing it by, when we travel, cramming 4 people into a room smaller than the dorm room I had in college, because that's what we can afford when we travel, when we go to teach teachers in remote places in the developing world, and sometimes even in the more developed world where teachers still need all the help they can get. We're doing what we can to implement this change because we're tired of waiting for someone else to step forward. We're tired of waiting for Congress to wake up. We're tired of waiting for the commercial sector to decide that instead of earning money, they can give it away. And I understand our world needs capitalist people. They drive the economy, they pay salaries, they do a lot of good, but we need more good. And so we're trying to be that change. And we just want a little bit of support. We just want a little bit of help.
Have you guys tried going to old Bill Gates and Melinda and then also Elon Musk to see, and maybe even Google? I know that they have been funding different projects and stuff like that. I'm just curious. Have you guys tried doing contact with them, Pamela?
Elon Musk does not have any listed foundations for giving money. We've had people try and approach him privately. So far, we haven't cracked that shell. The Bill and Melinda Gates Foundation gives money to things other than what CosmoQuest would count as. They're looking to correct health problems in the developing world and other very specific problems. We have tried it all. The problem is right now there are so many problems in this world. We live in a very broken place.
Sure.
And the money that is out there is rightfully going to solving health problems, to solving problems of people not having sufficient food, not having clean water, problems of malaria and HIV. There are so many things broken that need money. And many of the massive foundations are choosing to give their funding to fixing the basic problems. Because a kid that doesn't have food to eat can't think about learning science.
Very true.
And so we understand the choices those foundations have made. We've applied to the National Science Foundation, but again, the funding keeps getting cut. And while we get success now and then, we currently have a grant to create a planetarium show from the HST EPO system. We have pending 2 different NSF grants, and we've had several in the past. We keep fighting, we keep trying, but at the end of the day, we're trying to make our future, and this is how we're trying to make our future right now in this moment. Tomorrow morning, I go back to writing the federal grants. But right now, I'm asking people out there listening to put their wallet where their willingness to yell science in the crowd is at a show.
Yes.
Everyone's willing to say they love science. Everyone's willing to buy that Think Geek t-shirt that says science. But can you send me the $25 instead of Think Geek? We're trying to change the world one t-shirt's worth of funding at a time.
Well, we have to do what is necessary, and it's I didn't know things were quite that bad on the grant side, but it has been tight everywhere. And one thing I tell people is, with the presidential election coming up, we really can't afford, and I mean that literally,
yes,
can't afford a change in the program that goes from what one president had a vision of to what the next president has a vision of. Because the one thing that I'm adamant about is we've got to have capabilities, and we can't afford to have that all pushed back because there's a change in politics. We did that in 2004. We've got 2016 coming up, but we've got to have capabilities. And to me, the building of the Orion, the building of space SLS. I mean, the humanity has no way right now of being able to put anything into low Earth orbit in the terms of heavy lift capability. The Russians don't, we don't. We couldn't do that if we wanted to. So the one thing that the Space Launch System is going to do is give a capability of being able to put 286,000 pounds in the low Earth orbit, which hopefully may end up making people think about building capability of low Earth orbit refueling, low Earth orbit station, so forth, so on. The Orion spacecraft will be rated for 4 individuals and have a mission length from 21 to 210 days. But as I'm fond of pointing out, there isn't any money right now for a lander to go anywhere. You want to land, you got to be able to put a lander together. But we'll have a spacecraft that can really go out and stretch. But I'm hoping that as these capabilities improve, NASA and the private sector, the government sector is going to need more people to be able to do that. I was very worried about what was going to happen to the workforce when the shuttle shut down, because you have very, very talented workforce there. But thank goodness, Elon Musk, SpaceX, with the Falcon and the Dragon for the International Space Station resupply, Orbital Sciences, which just bought ATK. There are things going on in the space arena, but you've got to have the people demand your vision and make that happen. So I'm hoping people will wake up to realize that you got to have that steady flow, because we saw that happen in Apollo. I mean, when President Kennedy made his speech and mobilized the effort that James Webb, as a second NASA administrator, made happen, you really saw the influx, but it was all done by the fact that the federal dollar was fueling it. So maybe somewhere down the line.
It's a very different age. As I mentioned earlier in this hangout, There's a point last year, maybe the year before, I went out to Washington, D.C. after sequestration hit, trying to figure out how do we build this brave new future that we're in when we have people sitting on the House Science and Technology Committee saying that they're there to make sure that science doesn't get funded.
Yeah.
And I met with a program officer. I won't say from which agency. We met off in private places, not on federal grounds, to have a private conversation off the record. And one of the things this person said to me was the word coming down from Congress was the space race is over. It's time to send the scientists home. The current expectation coming from the National Science Foundation is we aren't supposed to ask for more than two months worth of salary. 2 months. Now, if I teach a class, which is what they're hoping I'll do,
Right.
I get $2,500 per class for the entire semester. So full-time teaching load, that's 4 classes, that's $10,000. I teach 2 semesters, that's $20,000 for 10 years of education. This is what we're hearing from Congress.
Now, that meeting was, you said, a couple years ago?
Yeah. It's not changed. It's not gotten better.
Yeah, one thing that but there's been a couple things I've been reading about lately on space policy, about what's going on, and I try to follow that kind of closely, is, again, the space race, they may have said that, but there's been concerns, again, like not having indigenous or U.S.-based engines. There's a push right now, and this is coming from
Congress.
But
that's separate from funding the people doing the science.
Well, that's true.
They are more willing to pay for the hardware. This is one of the problems that we're dealing with. And this is new to the U.S. It's been around in Europe for a long time. The European Space Agency specifically only pays for the spacecraft. And scientists who want to use the data coming off the spacecraft have to independently find funding to do that science. This is where Europlanet was created, to basically go to the European Union and say, help, can we have some science, please? What we're dealing with now in the United States,
you're not doing science, right?
Right. So what we're facing here in the United States right now is roughly 30% of our budget for astronomy and space science is going to fund ALMA, Curiosity, James Webb Space Telescope, and LSST. Those are facilities, and not all of them are generating data yet. And we're losing the funding needed to pay for the humans to utilize these facilities.
Well, okay. Has anybody, well, I'm sure everybody's been talking to NASA about that, right?
Oh, yeah.
And NSF?
Yeah.
Well, the only thing I can say to people is I've told my audience is you're a taxpayer and you're a voter. And hopefully people will donate to CosmoQuest, but then maybe people will pick up their computer or a pen and paper and send a note into Congress. Because you may recall this, James Webb was going to be killed by Congress when it had already spent $3+ billion for JWST. And it was a social media campaign, Save James Webb Space Telescope, changed the mind of Congress in doing so. I don't know if a grassroots level like that would help or not, Pamela. I've always believed in the power of the written and or the emailed word, but when I read about that, I was pretty impressed about what social media did. And I don't know if a campaign like that would help. Don't know.
We've been trying. A lot of us have been trying. Phil Plait has been one of the people on the forefront arguing to try and get people engaged with their congressional representatives in their particular area. The issue is, I think we're facing a lot of exhaustion.
Yes.
It's been since sequestration. It's been since 2012.
Yeah.
People are giving up. They're just switching careers. We are losing an entire generation. Like I was saying, back in May at the AAS meeting, we were going up to people and asking one another, are you okay?
Yeah.
What's your expiration date?
Right.
And a lot of people were saying, don't say anything but hey, and now they've made the jump. I'm leaving, I'm doing project management, I'm going into computer programming, I'm going into finance. All of us have backup plans. At LPSC back in March, we were all we've reached the point of this either works or we're done. What's your backup plan is what we're asking one another. And we've been laughing that some of our careers, my backup plan is writing books and voice acting, and that shouldn't be a backup plan, but that's easier for me to earn money doing.
Yeah.
We've been trying since 2012.
Well,
But
I know that the general public, in my own outreach efforts through NASA and then what I'm doing on my own and stuff, I will say that the general public, which is an important component because they are taxpayers and they are voters, aren't aware of a lot of the things that are going on. But once people have had an exposure, Pamela, I'm talking about mom and pop and again, general public, once they get a understanding that they can understand the universe and or what NASA is trying to do, I tell you, they get a fire lit. And a lot of them do get some passion on that type of stuff. So that to me is kind of where this has to go in terms of getting people interested in the plight. And I disagree with one thing, not what you're saying, but what Congress is saying. Space race, that's not true. You've got other countries that are really pushing in space. And quite frankly, there may be, this is just me talking, Greg Redfern, that's all it is. But I got a feeling there's going to be one country in particular that is going to bring back shades of what things were like in the 60s when some of their successes start to roll in and it's known what it is that they want to do. And you start getting into this militarization of space and so forth. So we'll see what happens there. That may help fuel some fire in Congress.
I'm sure it will fire up the need to fire instrumentation into the stars. I just hope that, unlike in the Apollo era, when there really just wasn't quite enough money to pay for the science and they were sending test pilots and one scientist off to the moon,
Yeah.
I'm hoping that we can find a way for science to matter as much as chest thumping and proving a point.
I agree.
Doesn't science matter more than proving which nation has more technological prowess? This is
Sorry, go ahead, Pamela.
This has been one of those hours where we've hit on a lot of the struggle that's going on. We're currently sitting at $20,743 in donations. We have 4 minutes left. If 4 people donate $100, 8 people donate $50, 16 people donate $25. If people just give, enough of you just give, we can get that to $21,000 by the end of this hour. We won't be caught up to where we need to be to hit 36,000 in these 36 hours, but it will get us that much closer. Can you find someone who hasn't given yet and say, hey, Wi-Fi, it's because of astronomy. Give. Find someone wearing an XKCG shirt and ask if they've supported science or only supported, well, whoever made the t-shirt. So in the next hour, we're going to be joined by the Meteorite Man and Sandy Springheim, and we're going to talk rocks from space. Before we do that, we're going to...
He's cool.
What was that?
Jeff Notkin's cool. I know him quite well.
Yeah, Jeff is coming on in the next segment. And the real question is, can we hit 21,000 before he's here? We're going to take a break and watch another video from our dear friend, Uncle Bob. But before we do that, do you have one final thought that you'd like to leave our audience with, Greg?
Yes. Based on everything we talked about, humanity has to explore the stars. It has to be done robotically. We have to go there ourselves, and we have to take care of funding to make the future generations want to be part of this grand effort. And Pamela, you kind of enlightened me a little bit Thank you for having me on. I hope you make your goal, and I will be out there spreading my outreach, telling people about some of the things you've said here today. Thank you.
Thank you so much, Greg. And thank you for joining us and talking about the good things NASA is doing as we work to get human beings flying on American rockets once again, or at least on rockets built by Elon Musk, a South African now living
Right.
in Southern California.
Thank you, Pamela.
Thank you. It's been a pleasure. We are currently sitting at $20,943. Can someone please give $60? Please put us over the edge. You've gotten me to the point of begging on air. I have no pride. I'm a scientist. I'm being told that's a t-shirt I now need to own. Our next guests are in the green room getting ready. They're mounting the webcam on a tripod. Folks in the green room, let them know they're going to have a 10-minute warm-up period while we watch a video. Oh, we are so close. We're $60 away. Can you donate it while we watch this video from Uncle Bob? I hope so. I'm going to go take a break. I'm being handed another $20. So we only need, doing math in my head, we are currently at 20,948 plus 20, which means 68. So we need $32, folks. Can you give us $32? And we're going to add the 20 into the online tally. Can you help? We're going to go to this video. I'm going to take a short break. I'm actually going to find a slightly lighter weight shirt because it went from like -20 in here to actually warm again. I'll see you on the other side, and hopefully you'll make me smile with 21,000 in donations. I don't know what my crew is laughing at. Okay. I'm being told to sign off. We'll see you in a few.
This iPhone is a truly remarkable device. It has about 500 billion transistors inside it. According to Jack Gansel, if you tried to build this out of 1950s technology, ENIAC technology, it would require 170 vehicle assembly buildings simply to house the vacuum tubes. It would weigh as much as 2,500 Nimitz-class aircraft carriers. It would consume a full terawatt of power, requiring 500 2-gigawatt nuclear power plants, the biggest plants we build. And it would cost a mere $50 trillion, the economic output of the world. And once we had built it, there would be no one to call. It's remarkable for another reason. This device embodies Einstein's dilemma, the theoretical dissonance between general relativity and quantum mechanics, because this device can't do its job without both. All iPhones contain a GPS receiver that calculates its position on the surface of the planet to within a few inches. How? Imagine that you're in the woods on a road that connects two distant towns. Each of these towns has a clock tower, and the two clock towers keep perfect time. At noon, they will both strike their gongs. You can use this fact to determine your position on the road if you can hear both clocks chime and if you happen to know the speed of sound. You simply wait until noon and listen for the two clock towers to chime. The clock tower you are closest to is the one you will hear first. Sound travels at about 340 meters per second. So now imagine that you hear the clock in front of you chime 1 second before you hear the clock behind you chime. That means you're 170 meters past the midpoint between the two towns. If you had a map of the road, you could plot your position precisely. The reason this works with two clocks is that a road only has one dimension. If you want to find your location in a two-dimensional space, you'd need three clocks. And if you want to find yourself somewhere on a three-dimensional space, like the planet Earth, you need at least four clocks. So we took a bunch of atomic clocks, we put them into satellites, and we launched them into orbits. And we arranged the orbits such that anywhere on the planet, any time of day, there are at least 5 or 6 of them in view. There's about 30 of these satellites up there. And each of the satellites continually broadcasts its precise location and the time. My iPhone listens to the time signals being broadcast by the satellites, and it notices that they arrive slightly out of sync. The reason for this is that the time signals move at the speed of light, and the satellites are all at different distances from my iPhone. So my iPhone measures the differences in arrival time of the time signals. My iPhone uses those small differences in arrival time in order to calculate my position on the Earth in exactly the same way that we calculated our position on the road by measuring the arrival time of the 2 clock chimes. But there's a problem. You see, the satellites are whipping around the Earth at over 17,000 miles per hour relative to my iPhone. Now, special relativity says that my iPhone will see those clocks running a bit slow because they're moving so fast. And so my iPhone must take this into account. There's another problem too. Those satellites are several hundred miles above the surface of the Earth. And according to general relativity, the space-time curvature out there will cause clocks to run faster than down here on the planet. My iPhone is going to have to take that into account too. So in order for my iPhone to correctly determine my position, it's got to do calculations in both special and general relativity. Cool. But how does it do those calculations? Well, it does them in a computer. And that computer is made up of transistors. A transistor can be thought of as a switch that turns electric current on or off. It does this by altering the conductivity of the silicon atoms within the crystal that it's made from. It accomplishes that change by taking advantage of the quantum characteristics of the atoms and electrons inside that crystal. The way this works is fascinating, and we are liable to end up talking about it later in a future episode. For now, I simply want to make the point that the calculations of both special and general relativity are being performed by a computer whose operation depends upon quantum mechanics. Now remember, it was Einstein in 1905 who started both the quantum mechanics and the relativity revolutions. And this is ironic, because while these two theories are the most successful scientific theories we have, they're wildly incompatible with each other. Relativity describes the universe as a curved continuum, the space-time continuum. The word continuum means exactly what you'd expect it to mean. It means something that is unbroken, continuous, something that has continuity. The equations of relativity describe smooth curves in energy, space, and time. Quantum mechanics is all about discontinuity. A quantum is a discontinuous chunk of space, time, or energy. A continuum cannot be made out of quanta, and a quantum has no existence in a continuum. The two theories disagree about their basic assumptions of what the universe is. They couldn't be any more dissimilar. And that was Einstein's dilemma. And it's also one of the biggest problems that faces science today. Yet here they are in my hand, working together almost perfectly, so well that I can get into my car and travel to destinations relying solely on their guidance, blissfully unaware that these two theories are utterly incompatible.
Hello and welcome back to the 36-hour CosmoQuest Hangout-a-thon. We are, oh God, I don't know how many hours any longer. We are 36 minus 8, which makes it 28 hours in to trying to raise money for science and science education. Our goal is $36,000. We're currently a long way off of that goal. We're sitting at 21,000, which is still amazing. We crossed the 21,000 mark during that video, and that was exactly what I was hoping to see. So thank you, all of you who took a few moments to give a few dollars to something I hope that matters. We're also in the process of trying to raise money for, not raise money, raise science itself. We are saying go to cosmoquest.org, go and watch this hangout while you do science. You can help us map out the moon. You've so far mapped out 959 images. You can map out Mercury, which is languishing at 936 images marked. You can help map out the asteroid Vesta. When we're done with Vesta, we can start in on Ceres. We're currently sitting at 1,594 images marked. You can help map Mars. We've had 1,190 images marked during this Hangout-a-thon. You are helping us accomplish science. And as Stuart Robbins talked about yesterday when he was on the Hangout-a-thon, the work that you're doing, we've statistically proven you do as good a job working as a group of professionals do. We need your help. There's too much data out there for those of us who are professional scientists to handle on our own. And unfortunately, we also need your help with the funding. There's just not enough dollars out there anymore. We're spending a lot of money to keep our facilities going. We're spending a lot of money trying to build new space telescopes, and we need these assets. But what isn't left over is money to pay for the salaries. What isn't left over is money to pay to communicate the results and to engage people in learning and doing like we do at CosmoQuest. So we're asking for your help. We're asking for your donations. And we're not beyond bribing you. We have on my desk 3 different meteorites that we're going to be giving away. And we have 4 more that we don't have here on my desk that were donated in the last hour that we're adding. So we will be giving away a total of 7 little tiny meteorites to random people who do science and contribute dollars. Each image processed, each dollar given counts equally in your opportunity to, well, get these awesome door prizes. We also have 2 Indigo Night prints that we'll be giving away, 2 $200 gift certificates to iTelescope, 5 Sarah Willis books, Your Place in Space, and some Surly Amy necklaces. We also have, for the person who gives the largest amount of money, these amazing dragon eggs that are now part of a tradition where each year the largest donor, and hopefully this is the last year we're asking for dollars. We hope in the future we're only asking for science. We have a tradition where the person who gives the most gets their name on the plaque and gets custody of these eggs for 1 year. If they hatch, you have dragons. If they don't, well, just like in the book Aragorn, the dragon eggs get passed on to the next person. These are creations of the prop designer and costumer, Tim Legower. He also made us a rather sad face lightsaber that has a belt clip. I don't know why I'm so enthusiastic about belt clip, but I am. It has a belt clip. It's removable, but you are ready to go and fight the 501st. So that's where we are, and that's where we're hoping to get, is $36,000 by 10 p.m. Central tonight. This is only possible if you help and if you get everyone you know to help. As I've said several times so far, if everyone who follows me on Twitter just gave $2, we'd be done raising funds and could just focus on talking about science. Jenny Dowding, she made it clear just how every little dollar matters. She tweeted out yesterday, I just gave $6, 3 for me and 3 for someone who really wants to but just can't right now, because sometimes that person is me, and I get that. There's so many times I wanted to give to so many different good causes, and sometimes I'm in that position to be able to give, and I do. And sometimes funding is short and it's just not possible. So if you can give. And if you can't, use your social media to find the person who just might have that extra million stashed under a rock. As we've realized, as we've thought about things, the amount of money we're trying to raise is just a little more than twice the cost of a gold Apple iWatch, something people readily bought the moment they went online, having never seen them before. We're trying to raise less than potato salad raised on Kickstarter. We're trying to raise just a little more than 10% of what it costs to reserve a seat to potentially fly into space on Virgin Galactic. It's one of these frustrations, but instead of talking about frustrations, we're going to talk about joy. I have 2 awesome guests with me, 2 fabulous people of science and rocks. With me is Jeff Notkin and Sandy Springman, coming from the fair city of Tucson, Arizona. Welcome to Hangoutathon.
Oh no. Okay, sorry.
I can hear you.
Internet's a little choppy here. We're sort of in the 20th century here in Tucson.
Can you guys hear me?
We can hear you great. The video's just a little weird on our side.
Can you hear us?
I can, and I'm trying to figure out. It looks like you're in some spaceship. Where are you?
Well, sort of. And lovely to see you again. Thank you so much for inviting us on board the Hangoutathon again. It's my 3rd time, and it's my first time ever with a co-host. This is tons of fun. Sandy just just messaged me the other day and said, "Hey, can I do some of your Hangoutathon with you?" And I said, "Heck yeah!" So we are broadcasting from the actual filming set for my new TV show, which is called Meteorite Hunters Unlimited. You heard it here almost first.
That is awesome.
Thanks. So I've reunited with my co-host Steve Arnold from the Meteorite Men Show. It's been years since we did any new episodes, and I am so inspired by our fans who are relentless in their demands for more Steve and Jeff adventures. Really, I've never experienced anything like it. There isn't a day that goes by where we don't get a tweet or a Facebook message or an email saying, "Are you guys ever going to do more adventures?"
And you have the most awesome logo ever.
Is there
Thank
a call?
you.
Did I see one of those around here? Colander?
So I have to give a shout out to Roman Casillas, who is a marvelous artist here in Tucson. And funny story about the logo, actually. I commissioned Roman to do a t-shirt design for us. It's a beautiful illustration of a young lady with a shovel and a space helmet standing on an asteroid, mining. So I was quite clear in what I wanted for this design. And then Roman comes over for our get-together, and he brings me this. And I go, "What the heck is this?" And he said, "The sketch that I came up with of you and Steve, kind of with colanders on your heads and looking a bit like Tweedledee and Tweedledum, and also 6 and 7 years old." And I said, "I absolutely love it. Can I use this? Can we use this?" And he goes, "But it's just a sketch. I just kind of did it for fun." I go, "It's the most brilliant thing ever. And we just like to license it from you." So I'm not allowed to say too much, but the pilot for the new show is nearly done. And that illustration features prominently in the intro. And all I can really say is that if you enjoyed Meteorite Men, or STEM journals or any of our other adventures, you're going to love Meteorite Hunters Unlimited. It's bigger, funnier, louder, more crazy.
So Jeff, I was living in Bonneville and Lair for the last 2 years.
You were?
Where do I watch TV? Like, where do I find this show? Where will I find this show?
Well, this is the interesting part. Rather than go the conventional route of making a 5-minute sizzle of the networks to see who likes it and who has comments, we put together our favorite crew of all time, all our dream people that we've worked with over the years, and we just made a pilot episode, a full pilot, full half-hour pilot, and we're going to see what happens. We're gonna give it its world premiere at CosmicCon UK in Manchester, England, on June the 6th. So any viewers, space, science, meteorite, STEM fans in the Midlands, or in fact anywhere in England, because let's face it, I grew up in England. It's about this big. To get from London to Manchester or Glasgow to Manchester is no great shakes. You just get on the motorway, put your foot down, stop at the calf, have a cup of tea, and you're there. It's a doddle. So June 6th and June 7th we'll be premiering it, and then after that we'll see. We're entertaining offers. We have 2 outfits that are interested in it. We may do it as a web series. Sky's the limit. No meteorite joke intended. So,
well, if it was meant to be a meteorite joke, the sky isn't a limit.
I shall now drop this on my own head. If you are connected with any of our social media, whether it be Jeff Notkin or Meteorite Man or MH Unlimited, you'll know where to watch it. It will make a sound much like the Chelyabinsk meteoroid exploding in the atmosphere in February of 2013, I'd wager.
I have a piece of that.
I have a piece too.
I bet
I do as well.
I have actually quite a collection. I should have brought the little collection out. We've got some teeny ones. So
from Russia with Love.
Yeah, exactly. Now that's already our number 2 James Bond reference, and I have a feeling there will be more. You know, we don't invite just anyone to come to the Secret Bunker. No. Only accomplished meteorite scientists. You know, I fully intended to print out Sandy's CV because I was going to read it out. It's so impressive. No, really, it's so impressive. I've been doing some research on her since we first met.
But it's really funny because last year when I was applying to grad school here, I brought my CV and I gave it to a certain emeritus faculty member, and he looked at it and he didn't say much. And then later in the day, he was telling other grad students that I was too advanced.
You know, that is a weird kind of, I don't know if it's an insult or a compliment.
He's German, so who knows? It's probably.
Well, you know, Germans typically say it the way it is. You're too advanced. You're too advanced for.
Anyway, so we're here and we're talking meteorites.
And
we've got quite a collection here.
You have worked hard to find meteors, asteroids, rocky bits from space in 2 very different ways. Jeff, you have gone on some wild rides through wild country in search of the rocks that made it through the atmosphere. And Sandy, you have sent radar beams bouncing off of the ones that hopefully choose not to attack us in the night.
Right, we zap them, they bag them.
See, we've got it covered between us.
Well, really, next year what we need to get is we need to get Richard Kowalski from the Catalina Sky Survey on the show, because Richard Kowalski is the only person who's discovered asteroids before they've hit the Earth.
That's
a fantastic idea. He's a charming guy too. He's a fireman. Have you ever been over to his house?
No.
I was really impressed. So his wife is a marvelous pastry chef and cook. So I went over for dinner, and Richard's a very lively guy. He's a very brilliant guy, and I just always think of him as a scientist. And he's got one of these giant old classical fire chief helmets sitting in his living room. And I go, wow, where did you find that? Antique Mall or something? And he goes, no, that was from when I was a fire chief. So a man of many talents. But yeah, what a great claim to fame. The only person ever to have spotted an incoming meteoroid while it was in space. Predicted very accurately its landing spot.
So in the fall, I was taking an asteroids, comets, Kuiper Belt objects class, and the instructor, who's really great, she's a theorist, she says to the class, all right, class, you have to go up to the Catalina Sky Survey and you have to write a report on how an observatory works. And I said, before I could say, "Are you kidding me?" she said, "Oh, well, Sandy's worked at an observatory. If you have any questions, you can ask her." And so I actually have a photo of Richard here. Let me do a screen share.
Oh yeah, nice.
They're not great photos, but this is Richard at the Catalina Sky Survey telling a couple of undergrads how the observatory works. So in 2008, he discovered this object, 2008 TC3, and everyone very quickly found out that it was going to hit the Earth. And so everyone looked at it with as many telescopes as they could find. And so most asteroids, if they're out in space, you see them rotating. You see them rotating like this. But this asteroid was rotating.
We can't see you, Sandy. You're screen sharing.
Sorry. I need I need more screens. We need to get Jeff's laptop working next time. All right, so if you have an asteroid out in space, imagine this chunk of an asteroid is a whole asteroid. It's rotating like this, but a tumbling something hits it. So it not only is rotating, it's also rotating along that dimension. So it's sort of tumbling. And they could tell from their observations that this asteroid was doing some pretty wonky things. And then they figured out that it hit the desert in northern Africa. And people actually went out to go collect chunks of it. So they found out that it's a total mess. It's made out of a whole bunch of things that we don't expect meteorites to be made out of. And Richard Kowalski actually has a piece now. Someone gave him one.
Alma-Hattasita.
Alma-Hattasita.
And they call it a rubble pile. So they started finding meteorites, landed in the desert, and they had a fairly good idea of where they were going to land. So it wasn't that difficult to find these super black fusion-crusted fragments. But to everyone's surprise, they represented what we would normally think of as all different meteorite types. So some sort of conglomerate breccia rubble pile, as we sometimes describe asteroids. So exploded in our atmosphere, and so you can actually collect the Alma-Hattasita meteorite because they're all different. Come collect the entire set.
It's like playing Angry Birds, and with getting one bird, getting 5 or 6 or 7 or 8 pigs. So.
And there you have it, ladies and gentlemen, our meteorite Angry Birds analogy. You're welcome.
Here all week, try the chicken.
So we got a table full of meteorites for if we need to do other displays, other demos, asteroids crashing together in space and that sort of thing.
Please just don't hit my laptop.
So I want to hear about what you're working on now.
What am I working on now? So I am a grad student here at the University of Arizona in the Lunar and Planetary Laboratory.
Fancy.
Because you're British.
Very well pronounced. Bloody marvelous that was.
Thank you. Cheers.
Top Cheers.
We have these British postdocs at Arecibo Observatory. And so working on the OSIRIS-REx asteroid sample return mission, and I think OSIRIS-REx stands for Origins, Resource Investigation, Origins, In Situ Analysis, Resource, Regolith Explorer.
Nearly. I used to know this because we did a STEM Journals episode all about OSIRIS-REx.
I knew this at the last science team meeting last month. Anyway.
It's the most complicated acronym ever. How about that?
It was initially proposed as OSIRIS, and then they were proposing it again, but it needed to be bigger and stronger, so they added REx to the end. So it's a spacecraft that's going to go to an asteroid. It launches in fewer than 500 days, according to the countdown clock outside my office. And so it's a spacecraft that will go to an asteroid. It will get in orbit around the asteroid. It will take photos of the asteroid. It will get a shape model of the asteroid. It will land on the asteroid and bring home samples.
I'm not running away. Don't worry. I just thought in honor of that, I just put on my space helmet.
So you guys are awesome, and there needs to be a second show that is the Jeff and Sandy show.
Well, yesterday we had the Sandy and Morgan show. Morgan and we're adept at goofing off over at Hangouts. So you have the spacecraft. It's going to go to the asteroid. It's going to land poke on the asteroid, bring home some rocks, and it's going to crash into the Utah desert. And people are going to take these samples. This will be 2022, 2023. Depending on what launch vehicle we get. And they're going to take these samples, they're going to analyze them. But this asteroid that they're going to land on is called Bennu. It was named by, I think, a kid from Virginia. It was a planetary science contest to name this asteroid. And they wanted a mythological name, and they wanted something from Egyptian mythology that had to deal with origins. And so Bennu is this bird that stands on one leg, and it sort of looks like the sampler arm of OSIRIS-REx. So they're going to land on this asteroid, they're going to sample this asteroid and bring it home. And we think that this asteroid is very primitive. And when we say primitive in the asteroid business, we mean it hasn't been changed much since it was created. And I have a couple of meteorites that we think are similar to it. Allende? Do you have any Allende?
I do. I'd have to run into the other room and get it.
You want to get another piece of a Yende? We can show it to.
I'll do that.
We can screen share it to Pamela.
Okay.
There's a Yende.
I'll be
There's
right back.
what else is there? Villagrosa. I've been analyzing some data on that.
Murchison.
Murchison. There's also Orgay. You're ready to graduate if you can spell Orgay correctly on the first go, and a couple others like that. And so we think that these ones haven't changed very much since the solar system was formed, but in all likelihood they have. They've probably been heated up by spending a lot of time close to the sun. And when these meteorites, these asteroids get close to the sun, they get heated up. And when they heat up, various things change on them. They have various metamorphic processes, but also even before you have things melting, you have various elements on board them that on these asteroids that can heat up and release. And so these aren't elements that we think of a lot when we're thinking about rocks, but we think of mercury, sulfur, cadmium, arsenic, tellurium, things like that. That's sort of that part of the periodic table in high school chemistry that you never really got to do much with. Those are on asteroids, and those will change as the asteroid heats up. And so my advisor took some.
It's very delicate, that one, very thin.
It's beautiful. So can you see this?
See, when you broadcast from Aerolite Meteorite headquarters, you can say, hey, do you happen to have a big piece of Yende lying around? And we just say yes.
So this is a Yende. And so a piece of Yende I have is about the size of my thumb. And it's an end section, but you can see on this piece of a Yende, Pamela, can you see the little white bits?
Yeah, it's actually shiny in both the actual and the Firefly sense.
All right, well, it's shiny just because it's been cut and polished. Thank you very much.
You're welcome.
So those white bits are calcium aluminum inclusions. And if you've been paying attention in chemistry class, which I certainly wasn't, they're refractory, which means they have a really high condensation temperature, so they're the first things to solidify as the solar nebula starts cooling down. And so those things are older than Earth. They're about 4.6 billion years old. So we're looking at something that's older than the Earth, that has pieces that are older than the Earth itself, which is pretty cool.
It is. And there was a paper published recently that you may have read, talking about microdiamonds, nanodiamonds inside carbonaceous chondrites. And I found the wording of the paper fascinating because it was kind of unusually definitive for a science article. It didn't say, well, we think possibly could be. It was, this indicates clearly that the microdiamonds in some carbonaceous chondrites are remnants of a supernova that predates our own solar system. So much older than anything that formed in the solar disk in our solar system. They're actually remnants from a long dead star, and I found that pretty cosmic.
Are you ready for the third Bond reference?
Yes, please.
Diamonds are forever.
Oh, of course. Good one.
So diamonds are forever, and you guys are as captivating as a giant diamond. The problem is you're so captivating that the people watching have stopped donating.
What?
Yeah, we're 30 minutes into your segment, and we've only gotten $33.
What?
All right, well,
Yeah.
I'll stop talking about meteorites, and I'll stop talking about my research, or we can watch cat videos until people donate again.
No, I think we should offer some prizes.
I think we should offer some prizes. I think.
Okay.
Yeah.
So I'd like to mention, Pamela, that my third book will be published very shortly. And unlike my first two books, which were largely about meteorites and my search for them and so on, this is about a little known facet of my life primarily. Before I got involved in meteorites and science and television, I worked in the comics industry. And comics have always been a great passion of mine. And in a sort of Forrest Gump-like series of fortunate coincidences, I ended up knowing and working with some of the most famous cartoonists of the last century. And a lot of you know that Neil Gaiman's my oldest friend. We met when we were 10, and we grew up together. He wrote the introduction to my second book. But I also worked with Harvey Kurtzman, founder of Mad Magazine, the great Will Eisner, who created The Spirit and American Visuals, Art Spiegelman, who won the Pulitzer Prize for Mouse and is a comics historian, and many, many other people. So I've written a humorous book about my life in the comics field. And it's called My Incredibly Strange, Unexaggerated, and Real-Life Adventures in the World of Comics. So we're doing a limited edition of 100 signed and numbered. They'll be ready in a few weeks. So I'd say anyone who is willing to start getting some pledges, putting some pledges in, is going to get one of those signed and numbered copies. So What would we say? What would we say that that would be worth for a pledge? $100 each? What do you think, Pamela?
I'm willing to go with that. I know your last book, my husband had to donate in order to get it because he wanted your book, and you've had an amazing life story in terms of all the things that you've experienced, exploring TV, music, meteors, and now I find out comics.
It's a little known facet of my life, and I realized that it's something that I should share, because a lot of the people that we're friendly with, people who are science and STEM enthusiasts, meteorites, spaceflight, a lot of these areas have a big crossover with comic books. So many of our friends are science fiction and comic book fans. And somebody noticed on my poster. I should probably show you this.
Yeah, it's pretty cool.
Give you an idea of how busy I am at the moment. This is my spring tour poster. So I've been doing public events. I am doing public events across the States, Canada, and then on to England and Scotland. And one of the big stops will be Phoenix Comic Con, which is the last weekend in May. It's one of the largest Comic Cons in the country, of course. Over 80,000 glorious nerds were there last year, including Dante Loretta.
He's a glorious nerd.
He is a glorious nerd of the Osiris Rex mission.
He was a Grateful Dead fanboy.
So we're going down a rabbit hole. I love you both.
We are.
We're going down a rabbit hole.
There is a point to my divergent madness. So I'm going to launch the book at Phoenix Comic Con, and I will give away, what should we say, 5 signed and numbered copies for the first people that are willing to pledge $100.
And we can tell you in real time when we get each of those.
Okay. And I will mail them to you at my own expense. And it can be anywhere in the world. It doesn't have to be in the States. So I think if you enjoy comics and science fiction, you're going to find it a very entertaining read. And I should mention that Roman Casillas, the brilliant artist that we were talking about earlier, who did the Meteorite Hunters Unlimited art, is doing the cover of the book and illustrations. And there will also be some reproductions of pieces from cartoonists that I've known and worked with over the years. So if you like weird comics, you're going to dig this book. What do you think of the title? My Incredibly Strange, Unexaggerated, and Real-Life Adventures in the World of Comics. Do you think that's overblown?
No. I mean, you're British, right?
I mean, brain wraps a few times.
Overstatement of the millennium.
Beautiful.
So we're tweeting this out. If you want to give us a retweet.
Oh, yes.
Once my producer's in the process of tweeting this. I think this is awesome. And we also heard just from Amy Davis Roth. She's the creator of Chuck the Squirrel is currently wearing a pendant that has a pendant within it. It's very meta. That has a little bit of Mars meteorite in it. She created this, and she created the necklace I'm currently wearing. And she's donating 5 regular, like the one I'm wearing, pendants that we'll also be giving away during the Hangout-a-thon. So,
man, I feel so boring. I'm just wearing an olivine and basalt necklace today.
Yeah, you're going for the pure science look.
Well, the chain for my Campo de Cielo meteorite necklace broke, so I haven't gotten a new one yet.
Small things. It's okay. It all happens.
Yeah.
So it sounds like a lot of amazing things are going on down there. You're getting ready to try and get a new TV show going. You just finished off STEM journals. You've done Meteorite Men before that. You have a shiny new set. You're working with a shiny graduate student right now.
I mean, come on.
Yeah, we got oscilloscopes and everything.
Serious business down here.
And Sandy, you're gearing up with Osiris Rex to launch in less than 500 days. And this is a mission that CosmoQuest hopes to be a part of. Everything is always funding pending until you actually take off into space. Because there's kind of a choice. Get a whole bunch of undergraduates at the cost of $250,000 to during finals week. Search through images to try and find a landing site, or ask the public to help. Save yourself, well, $250,000. And do a little science that gets people learning about asteroids, meteorites, and basically rocks in space that didn't quite form planets.
Rocks in space.
It's a thing. It's a good thing unless they come down. So as long as the rocks stay in space. Well, I guess you like them to come down so you can collect them.
Yeah, this is the really the dichotomy that we face in the meteorite world, because yes, we definitely want meteorites to land, but we don't want them to be too big because then we get into a dinosaur situation. So yeah, it's really a size matter.
You realize that the dino killing asteroid was 10 kilometers across.
It's not really that big when you think about the size of our planet.
Right, but it left a 100-kilometer crater.
Right.
So,
and it launched dinosaurs into space, which is my favorite random astronomy factoid. So the shockwave was sufficient to launch any nearby dinosaurs, who became quite dead in the process, into space.
You know, I don't know if they're like. I think dead is kind of a binary state, right? Dead. I mean,
all right. So here's a technical question for you then. So if we do not believe that there is any meteorite material left from the Chicxulub impact because it's so many million years old, although a meteorite was found by a ship that was drilling for cores in the area of the crater. That could just be coincidental. But how about this? Here's something to wrap your mind around. So Yucatan impact is so tremendous that it throws dinosaurs into space where they instantaneously freeze because it's almost sub-zero. Maybe they wander around for a few million years. So there could be some frozen dinosaurs in space. What if we re-encountered one of those and it went through the atmosphere? Is there any chance that any of it could survive its flight and become a dinosaur meteorite?
Probably not, because they're kind of fleshy.
I know, but it sounds so good, doesn't it?
No.
What if it was really what if it was a triceratops and it came in head first? It might be a kind of almost a heat shield.
Maybe.
I know I'm stretching the bounds of reasonable scientific
that
thought here
like
a bit.
Good premise for a comic book.
It does, doesn't it?
Or
maybe
so I'm interrupting you. I love you both, but please be quiet. Shush, shush. We just got a tweet. We're going to screen share with you. You're going to have to add parameters to this. I'm sharing. You always have the right to say no. Firefly Ops, oops, I can't quite read from here. I think it says Ops. Firefly Ops tweeted, Starstrider, if Jeff Nopkin would ship us one of those large meteorites, we will donate at least $2K. Now, I think your large meteorites are probably worth way over $2K. But I just wanted to say you have some bargaining people out there.
Well, I think this is an offer that we cannot possibly turn down. Which meteorite do they want? You can't have the Allende, I'm afraid. That's a museum piece. But I could pony up a piece of this sort of scale for a $2,000 donation. What do you think about that?
I think that you're in the small screen, and my producer is going to embiggen you so I can see you. Can you get that up?
We're gonna do an asteroid flyby here.
Oh, that's gorgeous.
So this is an iron meteorite. It's a 1B. It's a Campo del Cielo.
I have a necklace made out of that.
What, one this big?
No.
You must have an extremely strong neck. So this actual one is spoken for, but I will find one of comparable size and beauty for a $2,000 donation to the cause. So would you please pass that along? Or hopefully
so Firefly Ops, we'll tweet back at Firefly Ops. If you're watching Firefly, just tweet back at me. I'm actually going to follow you so you can direct tweet me if you'd like. My producer, Chris Miller, is also helping. Wow, hold on. Tweets are flying fast on my screen.
I love that, Pamela. I love that you've got like a minion horde this year doing all your producing.
Yeah, I want that. Can we have that?
So Chris Miller, his head just poked around the IMAX screen that he's mostly hiding behind, and he looked very excited and goes, "I'm a horde." So.
So if you're in the astronomy community, there was an email that was going around that was referring to a group of individuals they should not have been referring to as a lying horde. So I've decided I'm going to be a horde. Or, you know, there are lots of minion hordes.
Firefly Ops has tweeted back, CosmoQuest, Jeff Notkin, Star Strider, done.
Fantastic. Thank you very much. I will make it my personal task, my personal happy task, to select a beautiful meteorite for you. So please send your shipping information to Pamela and she'll forward it to us. Or you can tweet me, follow me, I'll follow you back. You can direct message. We'll sort it out. We'll make it happen.
So Twitter tells me that they are interested in real estate opportunities for investors. So I guess meteorites are just real estate from space.
That's pretty fantastic. Well, I'd really like to thank Firefly Ops. That's the kind of generous donation that really makes these events fly. So we'll include some literature, and I dare say we'll throw in a signed book or two and a few extra goodies for you. So look for a meteorite package. Like none other.
So we still
did we have any interest
we
in the
still
signed
haven't
book?
had any takers on your signed and numbered book. So just to remind everyone, you've offered 5 signed and numbered copies of your short run book on your days in the comic industry with a title that line wraps multiple times that I'm going to let you say because I didn't write it down fast enough.
Okay, the title of the book is my amazing now I've already forgotten my incredible, unexaggerated, real life amazing adventures in the world of comics, and the subhead is Close Encounters with Gaiman, Eisner, Kenneth, Gilliam, Spiegelman, and Turnbloom, who are some of the cartoonists that I knew and worked with over the years, and it's going to be a funny read. Which reminds me, I feel I'm going to have to send along some of these chapters to some of the characters who are mentioned in the book just to make sure that they're okay with it being published as is. Not that there's any libelous material or anything. It's just, you know, you like to check before relating some of the stories about your very famous friends when they were very young.
When I write my memoir about Arecibo, there are going to be a lot of names changed to guilty.
Oh, I have definitely also changed the names of some innocent characters, and I use that to protect the guilty as well, because they surely were guilty. So my new book, it's my 3rd book. It'll be published next month, and I'm doing 100 signed and numbered, and so to donate 5 of those, and they'll be very low numbers too. They'll be in the first 10. 5 signed and numbered copies for 5 participants who would be willing to pledge $100 each. How about 50? We're not getting $100. You don't think a signed and numbered limited edition of my 3rd book is worth a $100 donation? That's really
I
sad.
do. Your last book that my husband got, he kind of like disappeared into the book until I lost my husband to you for a few days.
Gosh, no one said that to me for ages. I'm very flattered. Well, thank you.
I'm hoping this is just lag in our donation site. That happens sometimes too, but we're currently sitting at $21,103.
Well, that's not bad.
Not bad.
No.
Better than Morgan.
We're trying to get to 36,000 by 10 p.m. tonight. So we have 7 hours and 14 minutes to go. Not sure we'll hit our goal, but it's always good to have lofty goals. It's
we need a couple more companies like Firefly Ops.
We do. We really do.
So generous and supportive. That's a fantastic thing.
You know, when I have a real job, Pamela, when they're not paying me starvation wages, I will be sure to be donating to CosmoQuest.
I could go get something else interesting. Do you think we should offer another gift? Do you mind if I keep jumping up and going and getting stuff? It feels very
I'm good with that. I don't know how many extra people we're gonna get, but so far I'm happy and kind of excited.
Oh, good. Well, I'm going to leave you in somebody's capable hands for just 2 minutes while I exit the headquarters bunker and
take one of these.
Oh, and I should tell you sci-fi fans out there, Pamela, I know you know that I collect sci-fi props. That's my hobby. This actual walkie-talkie is from Stargate Universe.
Whoa.
One of my
cool.
favorite shows. Love it. This, I put some fun things on the table here. This can of emergency drinking water is from X-Files, so screen used. And these rifle grenades, which are actually plastic and rubber, are from Terminator Salvation.
They look.
So,
You've seen that episode of Top Gear where they're doing the beach landing with the Royal Marines.
I assure you, I've seen every episode of Top Gear.
It's like, oh, these smoke grenades fit perfectly in the cup holders.
So our donations just exploded.
Oh, wow.
We have we have 2 books and the $2,000 donation coming in.
Well done, team.
I'm really pleased because that means we beat my record from last year.
You did.
Yes.
It's awesome and shiny.
Shiny. Okay, I'm going to run and get something else exceptional.
Yeah, okay.
Give away because I'm in a giving mood, and I'll leave you in the capable hands of Sandy for a minute.
So back to research. If anyone cares, someone heated up meteorites and they looked at arsenic, tellurium, cadmium, elemental mercury that came off these meteorites. And so it turns out that when you heat meteorites a lot, things come off and it doesn't really change the meteorite. And so we're going to be looking at that, and you can use that to make predictions of how heated asteroid Bennu, the target asteroid for OSIRIS-REx, has been, and also other objects, and you can make predictions on what elements it's going to be depleted in compared to what we expect it to be. And then also you can start making predictions on sun-grazer comets, what sort of things they would be depleted in. And so if you're not familiar with sun-grazer comets, these are comets that come really close to the sun. The SOHO spacecraft has discovered thousands of them. And as they come close to the sun, they're heated up by quite a bit. They get really hot, and a lot of various volatiles come off, as well as other elements. Volatile elements are things like gases, water, ices, methane, things that melt really quickly and dissociate or form gases very quickly. But there's also elements that are a little less prone to melting that can be changed on these objects as well. So that's the research I'm going to be doing. Trying to wrap up some projects from Arecibo, trying to make shape models of asteroids. Most of the time when you look at an asteroid through a telescope from Earth, you see it as just a point of light. If you want to see an asteroid really well, you have to send a spacecraft to $1 billion. So radar bridges the gap between asteroids as a point of light and asteroids as an expensive spacecraft target, because you can get resolution on asteroids of about 30 meters. And so when you have an object that's a couple miles across and you get 30-meter resolution, you can start seeing craters, where they've been hit, things like that. Oh, this looks exciting.
I have returned.
This is really exciting.
But I have 2 items here.
Oh man, I'm jealous.
2 different ones.
Oh yeah, this is totally sweet.
Okay, so the first thing, this is our Asteroid Miner t-shirt.
She's a total badass.
Isn't she great? This was also done by the brilliant illustrator Roman Casillas, who did the Meteorite Hunters Unlimited artwork. And we have men's and we have ladies and we have all different sizes, and it's a super comfy, soft,
I've been lusting over this for 2 months.
Cosmo
Over
Quest
2 months
Memo
now.
line.
So, what do we think those are worth? Like a $50 donation, maybe? What do you think, Pamela? Is that reasonable?
I think that's reasonable, considering most of the t-shirts I get are usually like $25, and that's prettier than most of the ones I end up getting.
Oh, thank you.
It's more comfortable than the shirt I'm wearing.
It's super comfortable too. Okay, now I have something really amazing. And t-shirts, I got a bunch of them. So make donations. I will send you t-shirts. We will pay for shipping, of course.
So I was at the Gem and Mineral Show in February, and he was selling these. So if you can't make it to Tucson, $50 is a lot cheaper than a ticket to Tucson.
That is for sure.
And trying to find a place to stay in Tucson during the Gem and Mineral Show.
Now this is a very limited edition collectible that I had made, especially for aerolite meteorites. It's a slice of the Simchan palisite from Russia. So it's a nickel iron matrix with olivine crystals suspended within, and
just like my necklace.
There you go. And that is the gemstone peridot. So literally a gem from outer space, and it's been beautifully suspended in this lucite pyramid. So if you want a paperweight for your high-powered desk that will really knock people out, that would be it. And they're made in very limited quantities. We're never going to make any more. They were very difficult and expensive to produce. So I would say whoever whoever makes the second largest donation after Firefly Ops will get the meteorite pyramid. Space pyramid, as we like to call it. Space pyramid, man. It's cosmic.
Currently, the second largest donation is $150 to give you a perspective on where you need to donate, and try and be closer to the 2,000 than the 150, maybe.
So, and I should say that there were about 100 of these pyramids made. Some of them were imperfect. We weren't able to use them. And the ones with this palisade, there were only about 30 in existence. And we've sold a few. And this is one of the last really good quality ones. So pretty unique gift. And we're the only company in the world that has these. I designed them. They were made specially for us. And they're not widely available. So that could be a marvelous memento of your generous donation to CosmoQuest, Hangout-a-thon, and science education in general. And every time you looked at this magnificent collection of space gems sitting on your desk, you could think to yourself, just remember that marvelous thing that I did.
We just got another pledge for a $2,000 donation for that.
Sorry?
We just got another person saying, I'll donate $2,000 for it.
That is absolutely marvelous.
Well done, team.
Thank you very much to that donor. That is a wonderful gift. I'll send this to you directly, and as with Firefly Ops, we'll put in some other goodies. I'll include a sign book and some other things for you. So I hope you enjoy that for many years.
My Twitter mentions are just exploding during.
Are they?
Yeah. Jeff just tweets, and then people tweet back, and it's like, okay, well, cool. This is great. Congratulations, Firefly Ops. and the anonymous donor. Thank you, anonymous donor, for this. You will enjoy this meteorite a lot. I really like pallasites. Pallasites are my favorite meteorite type, aside from these ones like a Yende. So the deal with pallasites is we don't actually know how they formed. You'll read some papers in some LPSC abstracts saying that, well, pallasites formed when you had a metal meteorite collide with a stony meteorite, or stony asteroid filled with this peridot mineral, and they collided and they mixed together, and you get these peridot gems in this iron nickel matrix. But the current thinking is that they're actually from the core mantle boundary of an asteroid that was blasted apart. And so we think the core of a lot of asteroids was made from iron nickel, and that the mantle of the asteroid, we know that the Earth's mantle is made of peridot and other similar minerals, and we think that they mix together at this core mantle boundary of an asteroid, and that from impacts, these asteroids are blown apart, and these meteorites are from this one little bit of the core mantle boundary of an asteroid that just couldn't make it.
And that explains, and that's a marvelous explanation. And I tell you, there's nothing like having a meteorite scientist sit next to you when you're doing this, because I can tell you how to find them, but it's wonderful to have the technical explanation presented so very clearly. And Sondi's explanation demonstrates why pallasites are so very rare. So we have now in the literature, as recognized by the Meteoritical Society and the Nomenclature Committee, 50,000 odd officially recognized different meteorites. And out of all of those 50,000+, there are only about 120 or 130 pallasites. I don't remember the
they're
number
not
exactly,
very common,
but they're extraordinarily rare and very beautiful. So when you hold them up to the light, you can see the crystals glittering in the sunlight.
Show you all.
So I'm going to interrupt you for a moment. Again, love you dearly, interrupting you nonetheless. We have one pledge of $50 going for a T-shirt. We have one $100 for the book, one $150. I don't know if you want to do a book and a T-shirt for
With
that.
pleasure.
And the two 2K donations, and we've started a Firefly theme. David Joseph Wesley, DJW Film Music on Twitter, has tweeted us, I'm the composer for the Firefly video game, and I'd love to find a way to give soundtracks for you to give as donation gifts. So we're working with him to try and figure out how to make that a thing. And as someone who happens to totally love Firefly, this kind of, thank you. Squee. Can I say squee?
You can say squee, Pamela.
So we are slowly catching up on the potato salad, my arch nemesis of this hangout-a-thon. And this is largely thanks to the two of you and your wonderful enthusiasm and your willingness to give and give and give. And I'm going to toss it back to you because you're far more amusing than I am.
I wouldn't go that far.
Well, I
but
haven't
you're
had
very
caffeine
kind.
yet today, so.
You know, I have to own up, Pamela, and tell you that I'm partially responsible for the potato salad thing, and I'm sorry about that, although it was an incredibly funny and amusing story. So very, very
People
early.
like you are why I moved out of San
You
Francisco.
see, I just get blamed for so many things. It was an accident, but here's what happened. A friend of mine who knows that I love potato salad happened to come across this Kickstarter when it was very early, when it was just a few $100s. And I think the original goal was $50, and it was already hundreds, in the hundreds. And I tweeted, and I said something like, "Marvelous Kickstarter story, potato salad fundraiser soars past its goal." And my friend Neil Gaiman saw it and retweeted it to his 1.6 million followers, and then it exploded like a hydrogen bomb. So I did play a significant part in that by accident.
So you're telling me that like Neil Gaiman is like reading these tweets with my name going by, maybe?
Well, who knows? He could be in space. He could be writing his new book. He could be in a submarine deep underground. He's a very adventurous guy. So I couldn't divulge his actual location, even if I knew it.
I had this very weird Twitter spheres colliding when he and Amanda Palmer married, because I'm from Massachusetts and lived in Somerville and went past Dresden Street or Circle, I forget which it was, coming home from the subway stop. And one of the guys I dated when I lived in Boston had run soundboards for Amanda. And so there was that part of my life that was filled with people who knew her personally. So I was 1 degree of freedom away from, well, one of my favorite musicians. And then my friend Kelly McCullough, amazing author, and is in a writer's group with Neil Gaiman. And my friend Carrie with the Polish name I won't try and pronounce on air, knew him through living in Minnesota. So I have this entire group of friends that is 1 degree of freedom between me and Neil Gaiman. And then the two of them got together. And now friends that were from completely different circles are tweeting the same things. And it's amazing.
Isn't it great?
How amazing creative people sometimes come
because,
together.
So as you know, I'm sorry, I keep stepping on you. After you.
No, I was just saying it was actually Amanda who, her way of getting the Dresden Dolls and her own music career and everything going by simply using the internet to ask has been a real inspiration to everything that we've done. And I just love the way everything keeps coming full circle, and good people beget good people, and we're all working together to make the world better.
That's the spirit. And Amanda's a marvelous performer. And when I met my fiance, Libby Eggleston, one of the first conversations we had was, she said to me, "Oh, did you know that your oldest friend is dating my all-time favorite rock star?" So she is a lifelong Dresden Dolls fan. And we got to go see Amanda perform in New Orleans, and Libby got to meet her. So that was a nice instance of worlds colliding. And there was a very funny story that evening because, of course, a lot of Amanda's fans are fans of Neil's also. Neil was at the show. And after the concert, we were outside the theater in New Orleans, just talking, catching up. And I see this big steampunk guy running down the street towards us with a monocle and a top hat and everything. And he's yelling, he's going, "Oh my God, it's you, it's you, it's you, you're here." And I just, of course, I assume he's pointing at Neil because Neil is so famous. And in fact, he was pointing at me. And he ran up to me and he goes, "You're the guy from Meteorite Men." And he didn't know who Neil was. It was really funny.
I would know. I would know who Neil Gaiman was.
Well, fair enough, but he's very recognizable. And so I was chatting with this guy, and Neil was smirking at me. He's going, "Oh, look, you're getting recognized in the street like a celebrity." And then someone turns around and goes, "Oh my God, it's Neil Gaiman." And then he got mobbed right after saying that, right after teasing me. And I mean, it was things like, "Please sign my Dresden Dolls t-shirt, sign my face." In fact, I tell this story in the new book, sign everything. And he just got so mobbed. And he's absolutely fantastic with the fans. I've never seen a celebrity better with his fans than Neil. and he's writing autographs and he's shaking hands and he's being nice to everyone. And then there's just kind of a momentary lull. It was just, it's like a Beatlemania moment. He looked at me and he goes, "Run!" And we just ran at full speed down this little New Orleans dark cobbled alleyway in the middle of the night. And it just reminded me so much of when we were in school and we'd be caught kind of bunking off school. We'd be seen by a teacher, so we weren't allowed to leave the school grounds, and we'd sneak off to the comic book shop or to the pub, and we'd kind of be walking down the street and the teacher would go, "Gaming and knocking, you two get over here." And I remember just when we were kids, he'd look at me and go, "Run!" So it took me right back, and it was almost a Beatles.
You were
type
sneaking
scene.
off to the pub in grammar school?
Yeah.
Well, that explains everything.
Sorry. I
He's
apologize
British.
retrospectively for my behavior. But I only drank hard cider at the time, so.
So I'm going to cut you off on that one because hard cider in your country needs a warning label at the border.
Yeah,
I met Scrumpy, and it takes no prisoners. It just takes you down the dark alley, beats you up, and you pray to God you can find a kebab before it wins the battle. Scrumpy is terrifying.
I think you're describing several incidents in my early life. I was having a conversation with one of my British friends on this subject the other day, and I remember when I was about, I'm guessing 7 or 8 years old, I would go most days to this beautiful little country shop that had sweets and fresh baked bread, and it was like something out of a Dickens story with the little thatched roof and little Tudor style, beautiful. And we used to drink shandy all the time, and it was in a brown bottle. And shandy is lemonade and beer mixed together. And this was very normal when I was a kid for school children to drink this at lunchtime. And I remember in later life, I had this realization. I was going, we were actually drinking at school when we were kids. I didn't really realize it. But I found a bottle of shandy a few years ago, and it said, contains not more than 2% alcohol. And that's the same as Budweiser. It's because English beer is so strong, real ale is so strong, they think, oh, put 2% beer in the shandy, that'll be fine for the boys at school, nothing to worry about. But we really did routinely drink beer at lunchtime as kids. And it explains a lot about England in general, and me in particular, I think.
I think it turned out for the best. And I will say, having you guys on has turned out for the best. We've had another $500 donation. The person who put in to get the pyramid on your desk, Richard Drum, the astronomy bomb, who's responsible for the Martian meteorite on my desk, or grain, as the case may be. He decided he needed to take home that lucite encased awesome. So between Firefly Ops and Richard Drum, the astronomy bomb, that got us part of the way there, but then we've had help from others. We had a $500 donation come in. We still haven't given away all the books, and this really bothers me because your books are awesome, and part of me doesn't want to let you leave until we give away all of those books, and I'm confused at why people aren't falling over themselves to get these books.
Well, I am asking a lot. I mean, $100 is a lot of money. So we gave away 2. We've got 2 books pledged, have we?
We currently so we're now up to 4 books.
Oh, 4 books.
So we have one more to give away. And we just broke 26,000. So we're 10K away from our goal with 7 hours left. We're catching up. I'm starting to see, I don't think we're going to catch up to the potato salad, for which I am now bitter at you. You created my arch nemesis. But
how could I have known that my innocent tweet about potato salad would have such far-reaching consequences?
It's okay. I still like you.
Ever be part of crowdfunding history.
It wasn't the worst thing on Kickstarter.
That is true. I have seen some things on Kickstarter that weren't as appealing to me.
But everything on CosmoQuest is better than, CosmoQuest is an excellent thing.
Dun, 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 dun.
Every hero needs an arch nemesis. So, if this turns me into a hero, it's okay.
I was asked, I'm glad you used the word nemesis, because I was asked at a public event recently when I was speaking, when I was doing Q&A, someone said, I know this person knew that I worked in the comics industry, and we made some superhero jokes, and she said, who is your what is your arch nemesis in life? And I immediately said magnetite, because it looks so similar to certain meteorite types. And we get sent magnetite in the mail all the time by people who think they found meteorites. And we sometimes get into these lengthy discussions where we'll say, no, it's not a meteorite, it's magnetite. And then they'll say, well, how do you know? I say, well, I've been doing this professionally for 21 years. I can tell the difference between magnetite and an iron meteorite. Of course, Sandy could, and many academics in the field. So one guy said, he called and said he had this meteorite that had fallen through the roof of his grandfather's barn around 1906 or whatever, and had been in the family ever since. And he described it. He said it's heavy, it's dark, and we've had it on the mantelpiece ever since. A magnet sticks to it. And I thought, well, this sounds fantastic. This could be a new witnessed fall, the first barn-destroying meteorite in history. So please send us a piece. And he did. And it was magnetite. And so I called him back. I was really disappointed. I said, I'm so sorry to tell you, it's not a meteorite, it's magnetite. And he went berserk on the phone. He goes, are you calling my grandfather a liar?
Yes.
And I said, no, not really. I don't know him. And maybe a meteorite did fall through the roof of his barn, but it surely wasn't this rock. And maybe he picked up the wrong one. And then the guy said, I know where you live. I'm coming down there to see you. You insulted my grandfather. So fortunately, that's why we use a P.O. box address for the company for this sort of thing. But yes, magnetite, my nemesis. Meteorite identification is no joke. Don't do it voluntarily.
That is an awesome story. And we still have one book to give away. So we're waiting for $100 donation. $50 gets you an awesome t-shirt. And tell us about this book one more time for people who are tuning in partway through this episode, this part of the Hangout.
With pleasure, Pamela. And as you and I think some of your viewers will know, I'm best known as a science writer. My first book was a nuts and bolts guide about how to find meteorites, and it's called Meteorite Hunting: How to Find Treasure from Space, and it discusses metal detectors and hunting strategies and how to get permission from landowners, and there's also some meteorite identification. It's the only book in existence. It's the only real nuts and bolts guide on how to find meteorites. My second book, and here we have a metal detector. This was actually used in the Meteorite Men pilot. It's a vintage Fisher 1266X, which is a fantastic old detector, great for finding iron. Found some beautiful meteorites with that very detector. These are not just props on the wall. These are actual metal detectors. So my second book, Rockstar Adventures of the Meteorite Man, which is the one that had a fantastic introduction by my great friend Neil Gaiman, is my memoir. And it's about my life as a rock and roller turned meteorite hunter, and recounts a lot of my adventures around the world filming Meteorite Men and other shows. And so for my new book, I really wanted to tell the story about my life in the comics industry. And I went to School of Visual Arts in New York City in the 80s, which was an absolutely fantastic school. And through a quirky series of events that I have had difficulty explaining accurately, I ended up working with Harvey Kurtzman, who was the founder of Mad Magazine, with Art Spiegelman, who's a Pulitzer Prize winning cartoonist, Will Eisner, creator of The Spirit, and I met Jules Pfeiffer and Kim Deitch and Sue Coe and so many other famous cartoonists. I mean, probably 50 to 100 well-known cartoonists. I crossed paths with them. Some of them I knew very well and worked very closely with. And I worked at Raw Magazine with Art Spiegelman and his wife Françoise Mouly for several years. And it was just in that period when their company, Raw Books and Graphics, went from being kind of a beloved but sort of obscure avant-garde comics publisher to this incredibly famous publisher, because Art's book, Mouse, his comic strip about his father's experiences during the Holocaust.
And there's a beautiful movie, a documentary about Art Spiegelman as well that people should go watch.
The Arena one, the BBC documentary. I remember when that one was filmed. That one was done back in the 80s. I imagine there's probably a more up-to-date one. But he's a really great talent. and he spent many years working on this book. And while I was working at Raw, at his company, the book was collected and published by Penguin, and he won the Pulitzer Prize for it. So he suddenly became a world-famous cartoonist after decades of good work. Anyway, I put all of these stories about my adventures and my travels in the comic world into a new book, and it's called My Incredibly Strange, Unexaggerated, and Real-Life Amazing Adventures in the World of Comics, and it will be published next month. And in addition to the regular print run, we're doing 100 hand-bound copies. They're going to be made by my print manager here in Tucson, one at a time, by hand, in the spirit of underground comics and micro publishing. And everyone will be signed and numbered. And we've got one left. It doesn't exist yet, but it will very soon. We've got one left to give away for a pledge of $100, mailed to your door. If you don't laugh out loud while reading this book, you can send it back to me for a refund. How's that? Or credit, maybe, would be better.
No returns. Returns within 30 days with receipt for store credit.
Yeah, that sounds fair. Something like that. We'll take care of our readers, don't worry.
I'll send you a 3D printed model of Bennu if they fix the 3D printer.
Oh, yeah. Oh, you know, and I meant to mention this earlier when somebody was giving this wonderful description of Osiris-Rex. The headquarters of the Osiris-Rex mission, the Drake Building, is right over there. It's not
within drunken stumbling distance from a British club.
You could probably throw this meteorite from the back door of our headquarters, of Airlight headquarters here, and hit the Drake Building. And for those of you who'd like to know more about the Osiris-Rex mission, which is amazing, I would recommend that you do a web search for STEM journals plus Osiris-Rex. And we did a special edition of my show, STEM Journals, with Dante Loretta, who's the principal investigator. And did you know that I got to go to Lockheed in Denver?
Oh, cool.
So I'm going to cut you off again. I'm sorry. I love you. I'm cutting you off again.
Am I talking too much?
So no, I just have things to interject, and I have this horrible feeling. I said we were going to keep you until someone donated to get the fifth book, and no one's donating now, and I'm not quite sure how to react to that.
Well, who's on next, Pamela?
Oh, we just got it. Never mind. I said that, and someone promptly gave. So we've now given away all 5 books, and I had someone ask. I don't know if this will lead to anything. If for another $2,000 donation, if you'd give away another one of those lucite pyramids. I know that's a whole lot to ask, but I'm passing on.
I absolutely would be delighted to.
Okay, so that's on the table.
One better for the people who are purchasing not purchasing, but pledging in order to receive these pyramids. I'll print up and sign a beautiful certificate of authenticity for you. Sign it personally that will explain what it is, and that you'll know for sure it's the real thing. Gems from outer space. Ta-da! So
space.
Yes, absolutely. I have a very few left, but I would be glad to donate the second one for that generous pledge.
So we'll see what comes from that request.
Pamela, are you going to do a happy dance for us?
I'll put my face up.
One more thing, and then I'm at this point strictly at the desk happy dance stage. So one more thing to pass on. The Weekly Spaced Hangout crew, who are responsible for most of our organization of this event, I was wrapped up writing a grant. I said help. I took a lesson from Amanda Palmer. And they stepped up and they helped, and they're now saying, this is passed along from Nancy Graziano, the Weekly Space Hangout crew is brainstorming. We are going to solicit crew members for their best favorite potato salad recipes, and we will self-publish via an on-demand service our recipes with all profits going to CosmoQuest. That is the most awesome and silly thing I have thus far seen today.
There's nothing silly about potato salad. I want some now.
You should come to our grad student parties. We always have potato salad.
Fantastic.
We go to lunch at Bentley's on Thursdays. They have really good potato salad.
Where's Bentley?
It's on Campbell and Speedway. It's right by campus.
Oh, I didn't even know that.
Yeah.
See, you're teaching me things about Tucson.
No, it's
Fantastic.
like it's within stumbling distance of Kuiper, the Kuiper building.
Oh, okay.
They have tamales on Thursday. They have tamale scramble.
I say it's a very proper British name. Bentley's what?
So,
Pamela, are you able to give us a total for how many pledges we got in our hour?
hold on, doing math, trying
Not
to
that
find,
I'm putting you on the spot or anything.
Asking a physics professor to do math is sometimes fraught with danger.
I'll put
okay,
the
so I'm
screen
being
on him
told
while
by
you're doing
people
that.
who can scroll faster than I can that we brought in $5,000 this hour.
Woohoo!
And the other thing that you made possible is we surpassed last year's donations. We still have 6 hours and 42 minutes to go. So it's still possible we could hit our $36,000 goal. You helped make this possible. Are you willing to leave that $2K on the table for the pyramid if someone comes along and says, yes, I want to give $2K?
Definitely. There's no expiration date. Right up till the end of the Hangout-a-thon. And I mean, I will give away as many pyramids as we get $2,000 donations. I don't have many left, but I think I would have enough. So if anybody else wants one, I will make sure that you get one.
They're pretty cool.
They really, really are. That is.
Hard to find good pallasites. You can find palisite. We have a palisite over in the Osiris Rex building that's on loan from Marvin.
Oh, I know.
It's the size of this table. It's this big. I have a photo of a postdoc buddy licking it. The joke's on him because like everyone else has licked it. But that thing, you can't. It's not locked down or anything because you can't move it. There's no way to steal it unless you bring in like a pickup truck or like a pitchfork. It's probably in the millions.
Yeah, it's got to be one of the most valuable meteorites in the world.
And so there's thin slices of it that are this big, and they look like stained glass windows. They're pretty thin, and they've got these peridot gems in this iron nickel matrix, and it really looks like a stained glass window when you hold it up to the light. If you search for palisite on Google and you go over to the image search, you'll find just these amazing images of palasites.
And they're one of my favorites to look at underneath microscopes because at every scale size, they look like stained glass windows. And
yeah, they're really amazing.
So,
well, I have to say it's been a rather successful hour, Pamela. Do you remember when, I don't know if you saw this tweet, but when, and I'd like to send out a special thank you to Susie Murph and Richard, both of whom spent a lot of time communicating with us to get this. Susie's a personal friend of mine for quite some years. So when Susie first invited me to participate, and then Sandy said, oh, can I come and share the hour with you? I sent out a tweet saying, well, this is obviously going to be the best Hangout-a-thon ever. And we certainly have done rather well financially. So I also extend my personal thanks to everyone who donated their time and money to this very worthy cause. You're helping change the world for the better.
And it's been absolutely amazing. Now we have left poor Brian Venturdo, whose last name I think I just probably mispronounced, for which I apologize. Ventrado, I'm being told. Okay. Pronouncing last names is not my forte. Everyone needs a skill. That one is not mine. He is waiting in the wings. I'd invite him to join us. And I'd ask the two of you, what one thing would you ask our audience to walk away with thinking today?
Meteorites are awesome. Rock on.
I would like our audience members who clearly are science and education enthusiasts to think about how they could pass along the essence of what they care about most to the next generation. And that might be to one of your own children, or it might be to a neighbor's kid, or if you're a teacher, it might be a student. And we know that these out of classroom learning experiences that young people have, such as going to a museum or going to an observatory and looking through a telescope, these form lasting memories that can change a child's life for the better. So try and touch a kid's life and share a little bit of your love for science with someone who could make a difference in the coming generation.
You get to engineer the next generation.
That's a good slogan. I like that.
And I have one final question. Jeff, what's the thing behind your right shoulder that I can't quite make out?
This giant structure here
Yeah.
Or this.
Those are canteens.
Yeah, so here we've got a couple of desert canteens, and this is a steel girder structure that is part of the filming set, and it was inspired by Fritz Lang's 1926 film Metropolis, which is one of my favorites. It's not actually steel. It's actually, hey, it's delicate. It's actually an entire prop structure that my team at Aerolite Meteorites and I built. We built this whole thing ourselves. We didn't have prop makers come in.
It looks pretty cool in here. It looks like the real deal until I
Thank you.
knocked on it.
And so I must tell you that I had a photographer, a celebrated photographer who used to work for Rolling Stone, visit here during the Gem Show, and he's an old friend, and I wanted him to see the set. And he walked in and he looked at these and he goes, how did you get all these steel girders in here? How did you where did all of this come from? And I said, we just made all of this ourselves. And up here, you'll see these are all my actual meteorite hunting tools. This is my fantastic King Digger shovel from the UK, my rock hammers. And so this is actually styrofoam that's being painted. And these bolts are actually made out of plaster of Paris. They were painted. These are my canteens, water bottle. It's all real stuff that we use in the field. So anyway, my friend was so astonished by all of this that he said it was the most realistic filming set he'd ever seen. And he said, do you know how many film sets I've been on in my career? So I took that as a real compliment. And here we have the high atmosphere tracking system. And this is a representation of asteroids and potential incoming meteorites. And this is my favorite up here. This is the SOS, the Stratospheric Observation System. So we built all of this stuff except for the old oscilloscopes, of course, which are, just one of my favorite things. You can't be a mad scientist and not have some oscilloscopes.
You've got to have green flashy lights in your lab.
Definitely. So we used this set for a primary filming location for the new Meteorite Hunters Unlimited series, for our pilot. And this was an idea that I had many years ago. I thought it would be fantastic to have a secret headquarters and have my co-host Steve and I meet here at the beginning of each episode and kind of plan out our adventure and go, well, this episode's going to be about craters, or this episode's going to be about asteroids, or whatever it would be. And we kind of set our goals and look at our maps here in the lab. So it's just a dream come true. One of the networks we were working for, when I floated this idea, they go, no, it's too complicated and too expensive. We never be able to get all of that done. So my staff and I built this ourselves in 2 weeks. So
that's pretty awesome.
Don't let anyone tell you anything's too complicated and expensive. Just do it yourself.
That's the rule Fraser and I kind of live by. Do it, make it happen, see if people then fund what you've done, and hopefully they will. And you've helped people fund what we do today. And I really thank you from the bottom of my heart. It's been an amazing hour and 25 minutes, and another T-shirt has been donated for another $50 just came in.
Fantastic.
Thank you. And I hope to work with you, Sandy, on OSIRIS-REx. Yeah. And Jeff, it's always a pleasure. And one of these days, we're going to see each other face to face again.
Yes, please. It's been too long.
And if you're on May 13th, I'm giving a talk at 7:15 p.m. at Borderlands as part of the Spacecrafts series. So there will be beer and pizza and talk about Arecibo Observatory.
Oh, nice.
So more Bond villain references and contact references and asteroids and radar. And
excellent stuff.
Yeah.
Yeah, Pamela, do please be sure to come visit if you're in Tucson. Again, it's been a few years since I saw you last in the real world, and we'd love to host you here anytime. Should you find yourself in the raucous Southwest?
You can sit in the secret lair.
Oh, and I should just mention, I'm sorry, I know we've gone over. This is really my last thing. I just wanted to mention,
sorry,
anyone who's going to Phoenix Comic Con this year, we're taking the entire filming set up to Phoenix Comic Con. We're setting it up. That's going to be our booth. Our booth is the Meteorite Hunters Unlimited set. So you can come and stand in it and take your photograph and fondle the meteorites.
That sounds wonderful.
That's the end of
the story. That is why you build girders out of styrofoam.
Yeah, that's the kind of thing I do in my spare time, to keep me out of mischief.
And make it so that you can transport your set and not have it weigh 10 million pounds.
I did actually think think forward on this. I thought we might want to move it after we finished filming. We might want to move it to a different studio. We might want to set it up at events. And so, yeah, the whole crazy thing is portable. At least we think it is.
We'll find out in May.
Right.
Well, thank you. It's been amazing. And I would ask you, you have now used your social media for evil and created my arch nemesis, the $55,000 potato salad. If you can please use your social media for a little bit more good. And this goes for all of you out there. You never know who your tweet is going to reach. You never know what difference you're going to make. Keep helping us change the world one tweet, one tumble, one Facebook post at a time. And thank you, Jeff. Thank you, Sandy. You're two of my favorite people. And beware of the avocados from space.
Thank you. You too, Pamela.
Pamela. Have fun, Brian.
Thank you.
Hi, Brian. Thank you so much for your patience on that.
Hello, Pamela.
You're back.
There's a couple of thousand people out there, or maybe more, thinking, who's the poor guy who has to follow Jeff and Sandy? That would be me.
So how are you doing?
I'm doing okay. How are you holding up?
I think so far we haven't had any birds fly in, so I'm pretty good.
Well, it looks like you're having a good time.
Due to wind, but my set is even more ephemeral than Jeff's, I'm afraid.
Okay.
So, looking at the schedule, you are here to talk about the search for the first stars. And there's lots of amazing ways we can do that. So I'm just going to let you go and tell us what your topic, where you want to go with this topic. You've been amazingly patient. Thank you so much.
Well, to redeem ourselves here and catch up with Jeff and Sandy, we've got to start with a couple of good quotes, my two favorite astronomy quotes. So my favorite, of course, is we're all in the gutter, but some of us are looking at the stars. Oscar Wilde, right? That's the best one. Neil Tyson loves that one. My second favorite is we had the sky up there. It's from Mark Twain. We had the sky up there all speckled with stars. And we used to lay on our backs and look up at them and discuss about whether they was made or only just happened. So that's from Huckleberry Finn, when Huck and his friend Jim are talking about the stars as they float down the Mississippi on a raft, right? So, of course, when you read Mark Twain, he's quite a clever fellow, so you have to think about what he's saying. So were the stars made or did they just happen? So whether someone or something made the stars, science really can't answer that, at least yet, right? But whether the stars happened or not, we can say something about that right now. And in fact, with new telescopes coming online, it's possible we can see the very first stars that ever formed in the universe. In fact, earlier you had people, I think you had a couple of talks, one from ALMA and one from the Square Kilometer Array. And they're going to be part of this search in the coming decade or so. But the amazing thing, and I don't know if many people know this, but just 20 years before Mark Twain made his wrote Huckleberry Finn, you know, in the mid-1800s, astronomers and no one had any idea what a star was. In fact, one of the most eminent astronomers of the day, Friedrich Bessel, the person who I think first measured the distance to a star using parallax, he said that figuring out the composition of stars was of no real concern to astronomy. And Auguste Comte, who was a French philosopher, said that never by any means will we ever be able to study their chemical composition. So that was just 150 years ago, which isn't that long. So amazingly, just 20 years before Twain wrote Huckleberry Finn, an English amateur astronomer, again, an amateur stargazer, did find out what stars were made of. His name was William Huggins. His name's fairly well known. And he was the first to attach a spectroscope to a telescope and invented single-handedly the science of astrophysics, which most of us are involved in one way or the other here. And so he found out, of course, that stars were made of the same things found on Earth, things like hydrogen, traces of iron, calcium, sodium, and helium, which wasn't really discovered on Earth until I think late in the 19th century. So this was an amazing discovery that we could figure out what stars were made of. And that sort of cracked things open for the next 100 years for people to study these stars. And something that both of us have studied in our work at one time or another, of course. So, of course, once people knew what stars were made of, they needed to figure out how they were powered. And that took the next 50 years or so. When, of course, the late 19th century, people had no idea what atomic energy was, or nuclear physics had not been worked out yet. But by about 1920, people had an inkling that nuclear energy had something to do with what formed stars, or sorry, what caused stars to be powered. And it was, I think, Hans Bethe, who in the late 1930s actually worked out the cycle by which stars generate their energy. And there's a cute little story about Hans walking down the city street one night. I don't know if he was at Cornell at the time, but he told his girlfriend at the time, and she was admiring how beautiful the stars looked that night. And he said to her, "Yes, but I'm the only person in the world right now who knows why they're beautiful and why they burn." So that's a nice little story. So by the late 1930s, people knew what stars were, and it came down to figure out where they came from and how they happened, as Mark Twain said. And things were getting, as you know, fairly interesting at that time in cosmology. So Edwin Hubble discovered that the universe was expanding. He had no idea why it was expanding. He was very cautious. He himself said it was rather startling that the universe was expanding. Now, of course, if the universe is getting bigger, it must have been smaller in the past. And it was a Belgian monk who used Einstein's theories to explain why the universe was expanding, based on general relativity. And he mused that the universe must be quite small in the past, and maybe came from a giant explosion in the distant past of the universe that he called the Big Noise. And of course, this was Bernard Lemaitre. And of course, people thought he was crazy. Fred Hoyle made fun of him, and he came up with his own name for the Big Noise, and he called it the Big Bang. And no one really believed that was true. But of course, if the universe was packed into a tiny little spot millions or billions of years ago, they didn't know how long it was at that time, then of course the universe must have been really dense and really hot and quite possibly really uniform, which meant there could not have been any stars.
And at this point in time, they were actually trying to sort out between two different models. There was the competing Big Bang, as they derisively named it, model, and there was the steady state model. And the one model had the idea that there was constantly new stuff coming into our universe. And it wasn't that the universe was expanding due to everything started out tiny and the entirety of space and time, no, not time, the entirety of space was expanding outwards. There's no center in this. I just don't know how to do no center with my hands.
Right.
But the other concept was that there was simply, if you have a cubic meter of space, there was new stuff kind of oozing out of nowhere into that cubic meter of space. And these two models were competing, and it was the prediction that Big Bang would leave its signature on the sky that allowed us to differentiate between these two different theories of the time.
That's right. I mean, that's the beautiful thing about science. You can have all the theories you want, but a good theory needs to make some predictions, and it needs to be verifiable by observation or experiment. So I think the Big Bang made 4 predictions. One is that the universe should be expanding, which Hubble observed, and we still observe today. The other is a little more esoteric, but it comes from nuclear physics, and there should be a certain balance, a certain ratio of hydrogen and helium.
Lithium, beryllium.
That's right. Yeah. And it seems to be that prediction is also true. When we look back to the earliest material in the universe, that seems to bear out. And then the other, the third tenet is that the universe should look different in the past than it does now. It also seems to be true. When you look in the past, there's quasars, that you don't see around in the nearby universe. You see it in the faraway universe, which means the distant past universe. And galaxies look different. They're less formed and so on. And then the fourth, of course, is that there should be this glow coming from everywhere that's left over from the Big Bang. And not only should there be a glow, but there's actually a prediction of what that glow should look like and at what temperature it should look like. And that also was observed in, I think, 1964 by accident. But the amazing thing, so that glow, most people may know who are listening, but that glow, of course, is the first radiation that was able to travel freely through the universe when hydrogen recombined, protons and electrons recombined into neutral hydrogen. So that took away most of the charged particles in the universe, and light was able to travel freely. And that's what we see as the cosmic microwave background. But the amazing thing about that is that it's extremely uniform. So I think.
And this is the cosmic microwave background that we've been studying at increasingly higher and higher resolution. And the thought is that we can use this to try and understand if we live in a finite or infinite universe within limits. And we've already reached the point where, in looking at this cosmic microwave background, we've been able to say we are looking at no more than 3-4% of the total universe. Because if we were able to see more of the universe as we look out at the cosmic microwave background, we'd start to see in a finite universe the same thing that gave off light. That light would have a chance to cycle around and be seen in two different places in the sky. Sort of like if you manage to shoot a light beam through a donut, it will follow the donut around and hit you in the back of the head and the front.
Right, right.
So the cosmic microwave background is really one of the most powerful things that we use as a tool to understand the evolution of our universe.
Yeah, I mean, this is an amazing discovery. It's one of those things, you know, as a scientist, or in my case, a science student, you actually remember where you were when this was first announced. And I was deep in the bowels of a sub-basement in a laser lab somewhere when I heard this on the nightly news. This was a great discovery. And so this is Planck's latest data. I don't know if you can see it on the screen here.
Yeah.
So this shows the temperature, a representation of the temperature of the universe across the whole sky about 380,000 years after the Big Bang. Now, it looks pretty lumpy, but what we're looking at here is, well, the blue is the regions of the sky that are a little bit colder than average, and red and orange are a little bit warmer than average, but just a little bit. So the whole variation across the sky is only 1 or 2 parts in 100,000. So the universe was extremely smooth. That's the main point I'm trying to get across here. About 380,000 years after the Big Bang, there are no stars here. There are no galaxies. It's you know, it's as smooth as a bowl of consomme. There's really nothing going on. So, and right now with our telescopes, we can see maybe 400 or 500 million years after the Big Bang when there were galaxies. So some time in between, stars happened. Again, if you want to go back to the Mark Twain quote. And so it's a big field now in theoretical astrophysics to predict how the stars happened, and in observational astrophysics to actually see these stars. So
I'm going to actually cut in here because I've been tracking the donations, and
Okay.
I think it is time for me to remind everyone we are trying to raise $36,000 by 10 p.m. Central Time tonight. We have 6 hours and 19 minutes remaining to hit our goal. Now, we have a lot of support coming in from a lot of different people. The newest thing that we've had is the folks who are working on the Firefly video game. David Joseph Wesley, the composer for the video game, he has donated 10 copies of the soundtrack. This is still being worked on. The video game is still in production. David Joseph Wesley has donated 10 copies of the upcoming Firefly video game, which has well over 200 different planets with different themes. So there's going to be a whole lot of music involved. We'll be giving away 10 of these to people who contribute to both helping to fund science and do science throughout this Hangout-a-thon. We also have, to anyone who gives $2,000, a extraordinarily rare palisite meteorite bit that has been beautifully polished and embedded in a lucite pyramid. This will come to you from Aerolite Meteorites out in Tucson, Arizona. This is being donated by Jeff Notkin, who's a dear friend of the show. I know a lot of you don't have $2,000 to give, but this rare rock from space by itself is more than worth the donation. And wow. We also have 7 different meteorites, much smaller, ones that are suitable for either showcasing on your desk or adding to a chain around your neck. Most of these are Sikhote-Alin meteorites. We have 6 of those, and then we have 1 larger Nantong Quang-Kai meteorite. These are being given away, and these were donated by Richard Drum, the astronomy bum. We have 5 Surly Amy space pendants and posters. We're going to pull up one of these posters. These are posters commemorating the New Horizons mission. These are really, really beautiful. Sorry, they're also at an aspect ratio that is taking a bit of rearranging of our screens. So this is what the poster looks like. Again, it's New Horizons Explorations. We have 5 books by Sarah Wills. These are Your Place in Space. These are kids' books. We have 2 $200 gift certificates to iTelescope to allow you to, well, help explore our solar system on your own time using amazing telescopes, including the 24-inch Henrietta Leavitt, Annie Jump Cannon, Jocelyn Bell Burnell telescope down at Siding Spring Observatory. We have 2 prints from Indigo Night. We have then, for the largest donor of this Hangout-a-thon, 3 gorgeous dragon eggs. Currently, those are going to the same person who nabbed one of the meteorites, and the lightsaber is going to the other one. These eggs are part of a new tradition. The largest donor of the Hangout-a-thon gets the dragon eggs for a year, and if they hatch, they get dragons. And if they don't, they get their name. Well, it will be engraved on the plaque either way. And each year, we pass these eggs through to the person who's done an amazing job to, well, support our programs. We also have, from the same artist, this is Tim Legower. He's an amazing prop designer and costumer. He also put together a lightsaber that looks a bit like it has a Futurama sad face on it. And it has a belt clip. I don't know why that excites me so much. It does. We're here to try and keep our programs going until we get, hopefully, funding that will make it so we never have to beg again. We are working to apply for grants to hopefully get things going through more traditional means. So help however you can. And you know, a lot of you out there watching, you've already given everything you can, and thank you so much. Every dollar matters, and every single one of you, I will be personally writing you on Monday. And if there's enough of you, it's going to carry over to Tuesday. I'm good with that. I'll be personally thanking all of you because this matters to me. And I ask you to please help us reach $36,000. Now, while I've been talking, no one has given. We are still sitting at $26,176. So, yeah. But I see more people working to tweet, more people working to get the word out. Boing Boing has put up a post. It's awesome. Thank you, Corey. Thank you, all of you who are helping to get the information out as far and wide as you can. And now, we're here to talk science. We have 3 goals for the weekend. To talk with awesome guests. Brian of OneMinuteAstronomer.com is one of those awesome guests. Goals 2 and 3 are, again, $36,000, 36,000 images done. We're working towards those goals as well. Brian, let's talk science.
Well, let's.
So when we last left our heroes discovering the early universe, we were looking at the Planck map of a very flat universe with variations at the level of 1 or 2 parts in 100,000. Where does the story go next?
Well, where it goes next, no one knows for sure, but we know right now the universe is not smooth. It's pretty lumpy. I mean, it's full of stars and galaxies and planets and people, right? In fact, I mean, there's, so I mean, when you look out in a clear sky, you can see maybe 2,000 or 3,000 stars. It seems like more. With a telescope, you can see millions of stars. And we know indirectly that there's maybe 100 or 200 billion stars in the Milky Way. And thanks to the Hubble Space Telescope, we've got a pretty good idea. There might be 100 or 200 billion galaxies in the universe. So somehow we went from that smooth consomme to a place where there is 10,000 to 100,000 billion stars. So the universe has been pretty busy in the last 13 billion years or so. Now, so the theoreticians tell us that out of those little small variations in the cosmic microwave background, the little hotspots presumably are where matter started to collect. So there's a little more density there than in the colder spots. And so gravitation, while it's the weakest force by far, weakest of the 4 fundamental forces, it is relentless. So over hundreds of millions of years, those little dense regions started to pull in more mass. It collected a lot of dark matter. Now, we don't know what dark matter is, but we know it has mass, so it can be modeled. And it turns out that gravity just kept going. It amplified these little spots to make hotter spots and hotter spots still. And these spots started to warm up and eventually collapsed either into the first stars or the first galaxies. No one really knows what came first. So that's one of the first big questions that are going to be settled by the next generation of telescopes, like the Webb telescope or the Square Kilometre Array. So the models can't really tell what happened first, but they can tell it happened maybe 200 or 300 million years after the Big Bang. And the amazing thing, these first stars that turned on were quite a bit different than the stars we see. The physics is a little bit, I mean, it's a little bit complicated, but stars now can form out of clouds of gas that have heavier elements, like iron and whatnot, silicon. And these elements can help get rid of the heat from clouds that collapse out of gas and dust.
And this is actually one of those things that people don't think about. In the early universe, when it was pretty much hydrogen, 24% helium, trace amounts of lithium and beryllium, without those metals, with all of their complex atomic lines to radiate away the light, stars were able to be much bigger, and things, the physics was the same, but the way it was implemented with this entirely different composition was radically different.
That's
and
right,
as
yeah.
we've built up more and more metals in our universe, we've changed how stars appear.
Yeah, the entire universe has changed by this small bit of waste product from stars. I mean, we're made from some of these waste products, as are our Earth. But the first stars, it's not just that they had to be big, because only the biggest clouds could collect enough mass to overcome all the motion of the atoms from the kinetic energy, because they were so hot. So the first stars were immensely large, like 100 or some say 1,000 times the mass of our sun, which meant they burnt furiously fast and blew up after a few million years. Some of them may have left black holes at their cores, and those black holes could now bring in more material, and some of that material was laced with metals. So the next generation of stars was a little bit different. And so things started going, and again, no one knows what came first, the stars or the galaxies. So the next generation of telescopes, as I mentioned, so the Webb is going to be the main one. So the question is, can we look back far enough to see these stars? The thing is, even though they were extremely bright and radiated most of their light in the ultraviolet, that light has been stretched out by a factor of 10 or 20 to longer wavelengths into the infrared. And so that's why the James Webb Telescope has been designed to detect infrared light. It's going to go up to see if it can see traces of these first stars and galaxies in the infrared. So I mean, that'll be quite exciting. It's going to take some time for them to dig this stuff up, but by the early 2020s, they may get some direct images of the very first stars and galaxies that came about, if they're bright enough. Yeah, go ahead.
So as we look to explore our universe, one of the key things is James Webb seeing in the infrared. One of the really cool things that it's going to be able to do is it allows us to start seeing light that is from these amazingly hot blue stars in the early universe. But that light has just kept getting redshifted further and further and further from blue through all of the visible, straight out of the visible, and into the longer wavelengths of light. And it's going to start to allow us to see the Lyman alpha lines, to see, heck, the hydrogen alpha line that we're so familiar with in the sun from these heavily redshifted, moments of star formation. We don't know what we're going to find. And that's one of the awesome things about the James Webb Space Telescope, is it allows us to go where our theory and even our imagination doesn't quite take us right now.
Yeah, I mean, no doubt there's going to be surprises, as there was with Hubble. People are expecting to see certain things, and they may see completely unexpected things, which makes science so interesting, right? So, I mean, if someone is contemplating a career in astrophysics, this is a very interesting field to go into. And it's happening not just with the Webb telescope, but with other telescopes too. So ELMA, for example, can see infrared light from these first stars stretched out to millimeter waves. And the Square Kilometre Array can see radio waves from atomic hydrogen, the 21 centimeter line, stretched out to extremely long wavelengths. So these three telescopes are going to start churning out amazing results soon.
So while we wait, we're in a position where we kind of have to write our own ticket. We're in this strange space post-sequestration where a lot of NASA missions don't have the money to spend on communicating out science, on educating people with science, because there's just not enough money. And so this is where we're here today, spending our time. Neither of us are getting paid to be here. I'm begging because, well, this is what I do right now. We're trying to find ways to keep our doors open.
Wait a second. I'm not getting paid? I'm just kidding.
Sorry.
I'm just kidding.
We're trying to raise $36,000 by 10 p.m. Central tonight. That gives us 6 hours. Am I doing my math right? That gives us 6 hours and 5 minutes remaining. We are sitting right now at, refreshing the page, we are sitting at $26,536. So we're not quite on track to get to that 36,000 mark. Help us catch up. Now, Boing Boing, Cory Doctorow has done his bit. He shared this out on his newsletter. What network do you have out there listening in the audience? What network do you have that you can hit up? What do you have left to help us fund grad students, feed programmers, pay our server bills? We could run everything we do for a little bit more than the cost of 2 gold Apple Watches. And I think we do a whole lot more than that watch is capable of. At least I like to think so. So we're getting ready to sum up this hour, and I'm going to ask you once again to leave our listeners, our audience, with a final thought. But before we do, we're going to show another video from Uncle Bob, one of our awesome friends of the show, take a little bit of a break. In the next hour, we're bringing in Chuck and Susan from Telescopes from Tanzania, Kim from the International Year of Light, a cosmic light awareness cornerstone project. I'm being told to sum up before the video. I'm working on summing up. Yeah, no. We're gonna have Brian sum things up before the video.
Okay,
yes.
I'll sum up.
Sorry,
So
I'm being
as you learned yesterday, so here's my sum up. As you learned yesterday, I love hands-on stargazing, right? So I've got a project for hands-on stargazers. Now, I didn't mention that these first stars in the universe are long gone. They burnt out long ago. But the second generation of stars, the ones that were enriched from the guts of the first stars, if you will, some of these are still around. And there's one that's fairly easy to see. Sorry, let me just share my screen here. It's in the constellation Libra, which is creeping into the sky at around midnight now. And it is called the Methuselah star. Let me get this up here. Can you see it?
No.
Okay, let me get this up here. It's about 7th magnitude, so you can see it with a pair of binoculars. There it is.
I think you need to press the present to everyone button. There we go.
Sure, yeah. That's me. Now let's get the star up here. You got it? That's the best I can do for now. AirPlay.
We had it, and then I think you somehow clicked away from it. Because
Okay.
now we're seeing you, and we like seeing you, but you're not the star.
All right, well, the star itself isn't that interesting to look at. It looks like any other star, but the modeling shows that it's about 13 billion years old, so it probably comes from a second generation. And so for you hands-on stargazers, you can Google it. It's a 7th magnitude star in Libra, about 190 light years away. And it's called HD 140-283, commonly known as the Methuselah star because it's so old. So again, you can see this, if you Google it, you can find some maps to find it with a pair of binoculars. So the first stars are not among us, but there are still some very old stars floating around, and you can see them for yourself.
So I guess at the end of the day, the message is go out and look up and learn a little bit about what you're seeing.
You can see some of this stuff for yourself, yeah.
Well, it's been a real pleasure having you on again, Brian. Thank you so much for joining us in 2 different hours during this Hangout-a-thon. You and Sandy are, and Morgan, the 3 of you are 2 visitation guests, and
Okay, I didn't know that. There you go.
a lot to us.
It's my pleasure.
And I will ask you to please abuse your social network. We are so close to meeting our goal. We are sitting at $26,536 and no cents. I missed the 42 cents we had for so many hours. We are trying to get $9,464 more dollars in the next 6 hours. We can do that, can't we? But we need your help. And if you can use your awesome oneminuteastronomer.com audience to help us out, I'd really appreciate it.
Absolutely.
So we are now going to cut to a video from our good friend Uncle Bob. This video is Stellar Classics, I think. Stellar Classifications, not quite the same thing. It's Stellar Classifications. So here is Stellar Classifications with Uncle Bob.
Twinkle, twinkle, little star, how I wonder what you are. Up above the world so high, like a diamond in the sky. Twinkle, twinkle, little star, how I wonder what you are.
Okay, first of all, stars don't twinkle. The twinkling effect is caused by density variations in the air. Second of all, stars aren't little. Even the smallest is at least the size of Jupiter. Thirdly, the stars we see aren't like diamonds at all. Although, when stars like our sun die, the carbon within them can form very large diamonds indeed. And speaking of gems, This is another story about the women in astronomy, because it was a dedicated group of women in the late 19th century who laid the groundwork for understanding the final riddle of that nursery rhyme, How I Wonder What You Are. Look at this picture of Orion. It's beautiful, isn't it? You should get a pair of binoculars or a telescope and go out one winter's night and just scan around inside of Orion. There are wonders upon wonders to be found inside that constellation, especially in the Sword. But now what I want you to do is look to the upper left. See that bright red star up there in Orion's shoulder? That's Betelgeuse, a red supergiant star that's going to go supernova sometime in the next few thousand years. And now look down at the lower right. See that bright blue star down there in Orion's foot? That's Rigel, a blue supergiant star that's also going to blow itself to hell one day. Look at the difference in the colors of those two stars. One is obviously red, the other is obviously blue. Stars have different colors, and we can classify them based on those colors. If you run the light of a star through a prism or a diffraction grating, you'll get its spectrum. Now, here are the spectra of 13 different stars laid out in order of their surface temperatures. The star Rigel has a spectrum that looks like the third from the top. The star Betelgeuse has a spectrum that looks like the one second from the bottom. Now, the first thing you should notice about this lovely array of spectra is this bright swath of color that goes from the blue in the upper left to the red in the lower right. This swath of color shows us the peak wavelength emitted by each of the stars in these spectra. And if you remember our discussion on the blackbody curve, the peak wavelength tells us the temperature of the star. The second thing you should notice in these spectra are the dark absorption lines. There's two over here at the left and another fainter one over here at the right. Those are hydrogen lines. This one is hydrogen alpha, beta, and gamma. These lines are created when electrons of neutral hydrogen atoms absorb photons of very specific frequencies. Ah, the poor hydrogen atom with its one lonely electron. That electron likes to live here at energy level 1 usually. But at the surface of a star, there's enough heat to sometimes kick it up to level 2. And that's interesting to us because the 3 hydrogen lines that we've been talking about correspond to the transition of that electron from level 2 to 3 for the alpha line, 2 to 4 for the beta line, and 2 to 5 for the gamma line. In other words, our 3 hydrogen lines all begin with the electron at level 2. And that explains why the colder stars at the bottom of the chart have faded out lines, because those stars are too cold to get the electron up to level 2. It also explains why those lines disappear in the hot stars at the top of the chart, because those stars are so hot that the electron never comes down to level 2. So the width of these hydrogen lines is an indirect measure of temperature. Of course, in the last half of the 19th century, nobody knew much about this. Astronomers of the day understood that there was a correlation between temperature and color, and they knew the positions of the absorption lines, but they really didn't have any idea why some stars would have such bold absorption lines and others had none at all. The first scientist to classify stars by their spectra was Father Angelo Secchi in 1866. His classification structure was pretty simple. Bright blue and white stars went into class 1, yellow stars went into class 2, and orange and red stars went into class 3. He also noted that certain bright blue-white stars had differences in their absorption lines. So, for example, Rigel and Bellatrix in Orion. So he put them into the Orion subtype of class 1. By 1890, Williamina Fleming had classified over 10,000 stars using a modification of Secchi's system, whereby Secchi's divisions were subdivided even further and renamed A through N, where A were blue-white stars and N were red stars. She also created another classification, O, for stars that were dominated by strong emission lines. In 1897, Antonia Mori realized that Secchi's Orion subclass, which Fleming had renamed B, was actually a higher temperature than Fleming's A-class star. She thought that the classification sequence should go in temperature order, so she moved B in front of A. So then in 1901, Annie Jump Cannon took Fleming's classes and combined many of them, getting rid of some of the ones in the middle. She also took class O and moved it to the beginning, giving us the sequence we know today. Oh, be a fine girl, kiss me. Cannon and her contemporaries strongly felt that this was in order of surface temperature. And though they didn't have the theoretical basis to prove it, their instincts were good, because this is indeed in surface temperature order. These are very hot stars. These are very cool stars. There's another interesting order to these. They're in order of mass. Very massive, very light. So here's that array of spectra again, placed in the OBA fine girl kiss me order. Look at the swath of color that crosses through that spectrum again. That swath and the shape of that swath is very important. It's called the main sequence. Stars on the main sequence are fusing hydrogen in their cores. They have not yet begun to fuse helium. So here once again is Orion the Hunter. You can see the 3 stars in his belt and the sword hanging down. To the upper left is the bright star Betelgeuse. At the lower right is the bright star Rigel at his foot. Follow the belt to the left and you'll see the eye of his faithful dog Sirius, the brightest star in the sky. And go up and to the left from there and you'll see the bright star Procyon. The rightmost 2 stars in the belt, Alnilam and Mintaka, are class O stars. They are both about 700 light years away. They are so hot that most of their energy is radiated in the ultraviolet. What we see is only a small fraction of light that they emit in the visible band. If we could see into the ultraviolet, these stars would be spectacularly bright. We're lucky to have 2 O stars so close to us. Only about 1 in 3 million stars are class O. They are so massive and hot that they don't live very long. Indeed, these 2 stars are much younger than the dinosaurs, and when they die, which will be soon, they will light up the sky as supernova. Rigel on Orion's right foot and Bellatrix on his right shoulder are class B stars, also very hot, heavy, and short-lived, but cool enough to radiate much more visible light. Rigel is a B8 star, and it's 860 light years away, whereas Bellatrix is a B2 star, which is just 250 light years away. They'll also go supernova one day. Now look over to the left at Sirius. Sirius is a class A star. It's the brightest star in the sky, but that's because it's only about 8.6 light years away. It's much hotter than our sun, but it has nowhere near the luminosity of Rigel. Now look up from Sirius. See the bright star Procyon? Procyon is 11 light years away, not much further than Sirius, but quite a bit fainter. Procyon is a class F star, smaller and cooler than Sirius, but still bigger and hotter than our sun. G stars, like our sun, are pretty small and faint when you put them up against a constellation like Orion. There's really only a handful of visible G-class main sequence stars in the sky, but I can show you one that's pretty well known. Here, in the southern hemisphere, you see the Southern Cross on the right. On the left are Alpha and Beta Centauri. Alpha Centauri is a G-class star, very similar to our sun, maybe a little hotter, maybe a little brighter. It's 4.5 light years away. It's very close. In fact, it's one of the closest stars to the sun, which is why it appears so bright. Main sequence stars that are class K and M are very small and faint, and to see them, you need a good pair of binoculars or a telescope. On the other hand, stars that leave the main sequence often grow into giants or supergiants that are K or M. Betelgeuse is such a star. It's M class, and it's so large and luminous that we see it as a bright star even though it's 650 light years away. In recent years, our telescopes have gotten so good that we've been able to identify very, very faint and cool stars, and we've classified them as L, T, and Y. These stars are so small, they're maybe the size of Jupiter, and the coolest of them radiate at a temperature that we would consider room temperature. Now, you might be wondering how you add L, T, and Y to "Oh, be a fine girl, kiss me." And the answer to that is simple. Lots of tongue, yes. Yes? Could you touch your tongue? Touch your tongue, yes? Yes, that's right.
Hello and welcome back to the CosmoQuest 36-hour Hangout-a-thon. We have less than 6 hours remaining, and we are currently sitting at $26,586 in donations. We're trying to hit $36,000. We are more than 2/3 of the way there. With your help, we can make it all the way to our goal. We can't get there without you. We are also working to talk with awesome guests, and joining us in this hour is going to be Kim Arcade. And we are also working to accomplish great science. Over at cosmoquest.org, you have the ability to watch this hangout in a window side by side with where you're doing science. You're going to need a bigger screen to do this, but hey, it's for science, right? We're currently at 1,000. Wow, all of these things have gone up hugely in the past hour. We're currently sitting at 1,067 images of the moon have been processed, 1,063 images of Mercury, 1,802 of Vesta, and Mars, the project we launched yesterday. Thanks to your donations, we're sitting at 1,261 images annotated. Thank you so much for all that you've done, all that you've given, all the social media tweets and tumbles and Facebook posts and G+ mentions. Everything you do helps, and we are starting to run out of words with which to say thank you. Now, for those of you who haven't given yet, we still love you, and it's not too late. We have, in fact, a whole bunch of awesome door prizes waiting to be claimed. We have now 7 small meteors. This is the largest of them. This one is from Nantong Quangkai, People's Republic of China. We have 6 different Shikot-Allen meteorites. We have 2 indigo night prints. For those of you who aren't familiar with the indigo night prints, you give them a night that is special to you. You give them a subheading. This one was made for August 5th, 2006, the year my husband and I got married. They print out the skyline of the city of your choice. They also give you some beautiful information on the constellations that were in the sky. And you have a memory. We're giving away 2 of these. We have 2 $200 iTelescope gift certificates, donated, of course, by iTelescope. Thank you. Thank you, iTelescope. We have 5 kids' books from Sarah Willis, the book Your Place in Space. We have 5 Surly Amy pendants. And I had to start writing on new pieces of paper. We have 10 soundtracks from the Firefly video game, which is still in production. It has over 200 planets with their own musical themes. This is going to be absolutely amazing. This is put together by David Joseph Wesley. He is a composer that we are very grateful to. We also have still waiting to be claimed for every $2,000 donation, and we've already had 2. For every $2,000 donation, Jeff Notkin from Meteorite Men is going to donate a piece of palisite that is encased in a gorgeous lucite pyramid. These are beautifully polished, numbered, limited edition. $2,000 is cheap for something of this quality, and all of the money is going to helping us keep people learning and doing science at CosmoQuest. We are going to, in our final hour, have our absolutely awesome programmer, Corey Lehan, come in, and every image you annotate and every dollar you give is a entry in to get one of these awesome door prizes. So go forth, do science, learn science from our awesome guests, and help keep the science going with your donation. And if you've already given, thank you. Go find someone using Wi-Fi. Ask them if they know where that Wi-Fi came from. Remind them it is a discovery made possible thanks to radio astronomy. Ask them to donate. Ask them to give back to the science that made their Wi-Fi connection possible. Now, I hate begging for money. I hope to never do this again after this year. Right now, we're working to try and keep all of our programs going because we have this small problem called sequestration created by Congress. There hasn't been a proposal put out that we could apply to from NASA since 2011. And when we applied in 2011, we got the money. We got started. We've been doing great things since. We've been working with missions. We've been working with scientists. But since sequestration, dollar by dollar, it's all started to go away. And it's you out there who've donated last year, the year before, all the times in between that have kept us going. If you can just keep us going a little bit longer, hopefully I'll never have to ask you for money again because I just want to be a scientist and not a fundraiser. Anyways, that's where we're at. If you give, you're being entered for these awesome door prizes. If you don't give, we still love you. Go do science. If you're not going to give science or do science or give to science, well, at least learn science with the awesome guest I have joining me. Kim, we've been working together since the International Year of Astronomy back in 2009, and it's awesome to see your lovely face in one of my Hangout windows yet again. How are you doing today?
Good. How are you? It has been a while. It's so nice to see you again.
And we've brought the team back together again. It's no longer the International Year of Astronomy. It's now the International Year of Light. Tell me what's coming down as we work to celebrate science once again.
Sure. So for the International Year of Light, which is all this year, it was a declaration from the United Nations. Another great group of people has gotten together to create programs for people around the world. And one of the programs that I'm working on is called Light Beyond the Bulb. And it's essentially a way to create exhibits about light in your own community, whether it's a library or a school or an art gallery or a bus stop. And we have essentially collected a repository of images and information about those images. It's a free online repository, and anybody can sign up to download the materials to create their own exhibit and do something really cool for their community members.
And so this is one of the cases where you're working to create a great resource that you're giving away for free, which is really what a lot of this is, what we want to do. We want to help people learn. Learning should be free. Science should be free. And this is really a great project that grew out of what you started back in 2009. And I remember walking through the terminals in O'Hare and seeing the images that you and your team worked to curate. And they've really appeared all around the world. What's it like seeing your images crop up sometimes on the sides of camels?
That part is pretty exciting, actually. For the International Year of Astronomy, when we had the From Earth to the Universe program going on, and by the way, the images that were at the O'Hare Airport were just taken down, I want to say mid to late last year. So they had been up since 2009. So, I mean, they really got a run for their money on that program. And a new exhibit for the International Year of Light is replacing those images now. So that exhibit should hopefully be up at the O'Hare Airport, I guess, hopefully in the next couple of weeks. But when you see these images of space in these beautiful locations around the world, it's incredibly inspiring. I mean, we had exhibits at the Alhambra in Spain, at cafes around the world, at schools. We had people who were doing it on a budget who just printed out images on their printer and tacked them up to a fence in their community. I mean, it was such a range of exhibits, and each and every one was just really exciting to see. And there's nothing like when you see a train go by and the side of it is plastered in a huge image of the Andromeda Galaxy, to think, like, is this making a difference? Is this helping to bring science to people who might not otherwise have time, or, you know, the impetus to go online and search for it, or to try to find it in a newspaper, or to try to find it in a TV show? You know, it's a way to bring space into the everyday situation so that it becomes a little bit less of the other and a little bit more of the here and now, which I think is really rather exciting.
And one of the things that we keep discovering over and over is there's a couple of different things that pretty much every child loves. One of them is, of course, dinosaurs, and I'm so pleased to hear they may be bringing the brontosaur back. But the other one is astronomy, and while asteroids killed the dinosaurs, or a asteroid killed the dinosaurs, so we won. But people forget their passion for astronomy and somewhere get lost in the day-to-day details of life. And sometimes all it takes is stumbling across these magnificent images while shopping in the mall to be reminded to take a moment for science.
Exactly. I mean, when we were doing these exhibits, you know, for us, it's kind of about, a lot of the money that we get is just public funded projects, so that's taxpayer money, and you know, it's our job to show a return for that in a number of ways. And what better way than to take those images that were created on these publicly funded projects and put them into public spaces, so that it's not just, you know, the night sky, you can only see it at night, but you really can access the universe any time of day. It's just a way to make it a little bit more of a personal connection with this type of science. And, you know, a lot of people talk about the fact that astronomy can be a gateway science. You get interested in astronomy, what else can you find out next? Maybe you learn about chemistry more because you're interested in finding out about those elements that are in that star that exploded 10,000 light years away. You know, so there are, I think, a lot of ways to get people interested in these types of materials, and having them in places that they can see them, I think, is just a great first step. So.
And unfortunately, here we are already knocking on the door of the month of May. And I feel like not enough people know that it's the International Year of Light. It's so much harder somehow to promote light than it was to promote astronomy. But we have time to fix this. Just sort of like we have time to, well, we're currently sitting at 26,646 still. Hi, people, get the word out. But we have time left to raise $10,000 more, and we have time left to make sure everyone knows about the International Year of Light. What are some of the key programs with the International Year of Light that people should know about and be looking for and be looking to be part of?
Well, so there are a number of programs that the International Astronomical Union is working on, or supporting, I should say, as other people do them. And one is the project that I mentioned earlier called Light Beyond the Bulb, which is getting the exhibits out there. There's also a program on telescopes called Galileoscope, and I believe those are already being ordered now. There are also a couple programs for kids. One has an app, and there are also a couple programs on dark skies awareness. So it's kind of a full mixture, a full spectrum, if you will, it's no pun intended, of different kinds of topics because light touches so much. I have a few slides actually I think I could show if you want to see some images about the types of topics that are being covered for the International Year.
That would be cool. And for full disclosure, I'm working with Rosa Duran on the kits. They're virtual kits, and we will also be working to put together some physical kits of educator resources. And we're going to be hosting a series of Google Hangouts to help train teachers on how to use all of these different tools so that not only do they have e-resources that they can use wherever, but more than that, they have the training to use them most effectively with their classrooms. But not everything's virtual, and I think you have some slides for things that are a little more physical.
Exactly. So can you see my screen now? Okay, so this first image, for example, it's one of the images that for the Light Beyond the Bulb collection. And, you know, it's kind of one of the types of light that you think about, you know, the light that you see every day. In this case, so there are many other types of light, however, that we talk about in our materials. So we'll talk about different kinds of light that are used for weather forecasting, you know, trying to understand how better to predict weather, especially things like hurricanes and cyclones, as well as solar panels and recyclable energy. The sun is just a huge amount of energy for us. And how do we harness that light to make better choices for our own energy usage systems here on Earth? And then we also have, of course, going back to the theme of astronomy, we have things like images from the Hubble Space Telescope, images from the Chandrax Observatory, as well as Hubble and Spitzer. And additionally, we talk a little bit about light pollution. So this is an image, for example, taken by the International Space Station, a time-lapse image that shows some of the pockets of light from the Earth below. We also talk about things like refraction. We talk about shadows and how it's not just necessarily shadows that you're familiar here with on Earth, but also things like eclipses and transits. About reflection and microscopy and the different kinds of laser scanning microscopes and what those do for modern technology, as well as the communication system, so fiber optics, for example, and lasers. So, I mean, as you can see, this is just a really brief sampling, but it's, I think, a really good example of some of the different topics that you can cover. Everything from atomic collisions when you're talking about or, you know, electric discharge and you're talking about lightning. So
I have to say, I love my job, but your job in some ways is even cooler because you have figured out how to be part of project after project where you basically get to curate the most amazing images in the world and share them out with educational captions that captivate the imagination as well as captivating the eye. And we have a pretty science, let's face it. I'm not sure anyone else has a science quite as pretty as what we do. With all the images that you've looked at, I know no parent is supposed to have a favorite child, but do you have a favorite image?
Oh gosh. Oh, that's such a loaded question. Well, yeah, so I love my job. I really do have a cool job. And I get bored easily, which is why I'm always attaching myself to new projects. So that's just kind of a self-preservation thing. As far as my favorite image though, let me see. Yep, all right, I've got one for you. Hold on, let me just screen share again.
And while she's pulling that up, we have brought in another $100. Thank you, thank you, thank you, donors. We are now up to 26,746. Keep on bringing in the donations. Our goal, should you choose to accept it, is to take on my new arch nemesis, the potato salad of Kickstarter. Potato salad should not bring in more money than science. We're not going to surpass potato salad, I don't think. I can dream, a girl can dream. But can we at least make 36,000 and tell the potato salad that we're biting at its heels? So do you have your awesome image, Kim?
I do. So yeah, this is an X-ray image of an exploded star called Cassiopeia A. It's about 10,000 light years from Earth. And this image from the Chandrax Observatory, I look at it over and over. I have been working with this data for so many years, like 16 years, and I still get chills when I look at it. If you look at this image in optical light, it's still a really beautiful image. This is an image from the Hubble Space Telescope of approximately the same area. But as soon as you pop up that field in X-ray light, you're seeing so much detail. You know, the star that's essentially vomited itself out and all the elements in it, the silicon, the calcium, the sulfur. I mean, it's pretty incredible. And then you match the two pieces together, the Hubble and the Chandra image, and it's even more beautiful. So even though I hate to pick favorites, and my children always ask me, who's your favorite? And I refuse to answer that question. I will say this is my favorite astronomical image ever.
and it's absolutely amazing. It's the first one you showed us. It said on it, "It's alive." And I look at that photo and I see a tropical fish swimming among the stars. It just such amazing colors, and to think that that was such a deadly explosion, it's kind of amazing to think about.
It is.
So you've had the chance to travel the world, helping to get people seeing the sky in new colors of light. You've inspired people to put pictures on camels. I've never inspired anyone to do anything with a camel. How do you keep coming up with these amazing ideas? That's one of the things that's cool, is I never quite know what bit of awesome you're going to do next.
Oh, you're the sweetest. I didn't know coming on this show I'd get such an ego boost, but it's hard to. I work with a really wonderful team of people, really. I mean, I cannot take credit for any of these projects. I think the group of people that I surrounded myself with at my work, they're all just very interested. They're just really interested in science, and they're really interested in showing science off to people who may or may not already be interested in it. And there are a lot of challenges in that. And I think when you are part of a creative team, you just feed ideas off of each other. And, I just happen to luck out into a group of people that I mesh really well with, and they're all a little bit adventurous with trying new things, fortunately. So it's really, I don't know, part luck of the draw, part, I guess I got into a really good place.
That's cool. So how can people go and find these images and download them for themselves, and maybe be part of creating their own installation to celebrate the International Year of Light?
Yes, so if you go to lightexhibit.org, you'll see all the information that you need. There are a couple pieces, a couple of forms to fill out, just so we know what you're doing and when, so we can add it to essentially a Google map of events going around the world. And hold on, I could probably share that really quick.
We're pulling it up so that we can see you and have it at once.
And so, yeah, on that website, there are like over 75 images. We have captions that are translated already into Spanish, French, and Portuguese, Brazilian Portuguese. We have additional translations coming in Chinese and Afrikaans, and another language that I'm missing. So all of these images, you can pick and choose essentially what your particular interests are and what you would like to show to your visitors. And you can do it thematically, you can do it just willy-nilly. There are handouts that you can download, there are videos that you can show, there are PowerPoint loops that you can play. There's a lot of resources. We've tried to make this website as rich as we can with the time that we had. But really, these exhibits are more about the experience. And what I've been absolutely amazed by is that each volunteer that steps up to the plate to do this for their community, they bring with them such unique ideas of how to engage local artists, do scavenger hunts, have contests, have authors come for reading nights, have people do, giveaways and talks and games for kids. Like, there's just an unending list of ways to make this exhibit less about just image and reading it and more about an experience. And it's been really fun to see people do cool things like that.
And one of the awesome things that I remember happening with the from Earth to the Universe images that you did back. Did I get that name right for 2009?
From Earth to the Universe, yep.
From Earth to the Universe. One of the awesome things that happened was we saw photos getting printed by the people who had a little bit extra, who could afford the printing costs, afford the materials to create UV protected boards to be able to mount them for public display. And we'd show them for a while. And then they'd pass them on. And we saw these boards moving from place to place. And one of the good friends of the show, Bill Keel, he actually was able to take some of these panels down to Cuba where they didn't have the resources. You never know how far what you do can go. And sometimes it's spreading ideas, and sometimes it's literally your ideas get printed and carried across the planet. So share the science. And Kim, thank you so much for sharing the science. We have two more of our it feels like old school alumni day or something. We have Chuck and Sue from Telescopes for Tania joining us now. And it's like 2009 all over again, except I have a few more gray hairs now and maybe a few more wrinkles, but we're not going to discuss that, are we? So where can people learn more about all of your programs, Kim?
I'm sorry, could you repeat that last bit? Your voice cut out for a second.
Sorry, where can people learn all about what you're doing, Kim?
Pretty much on the Chandra Observatory website, chandra.si.edu. We try to link to all of our projects right from there, and a quick Google search, I guess, too, would do the trick.
So it's been absolutely awesome having you on, and thank you for doing all of the great things that you do. I just love eating it all up with my eyes. The series you did a few years ago comparing celestial objects with pictures of Earth remains my favorite of all of the things that you've done. Thank you so much, and keep doing it. It's great.
It was great to be here. Thank you so much.
So for those of you just joining us, hi Chuck, hi Sue. We have two guests from Telescopes for Tanzania. We're going to bounce to them in a second. First, I want to say we are working to raise funds. We're not doing so good this hour, folks. We're still sitting at 26,746. We have 5 hours and 22 minutes left to get to $36,000. I don't know if we can do it. It's all in your hands. Please help. Please tell other people to help. Yell at other people to help, or cajole, or just offer them candy. I'm a beggar at this point. There's few lines I will cross in terms of candy and begging. I've also been online far too many hours today. So we are at $26,746 in donations, but we have some incentives to hopefully convince you that maybe you want to give a little bit more. So for those of you who just are joining us and don't know, a good friend, Jeff Knockin, has offered for donations of $2,000 or more a piece of palisite, gorgeous, polished, beautiful, embedded in an amazing lucite pyramid. These are limited edition, but if you donate $2,000 or more, it is automatically yours. Now, we know not everyone can donate that much, and I believe in random chance. So for every image you annotate, for every dollar you give, you have a chance to get a whole bunch. I stopped being able to remember it early on today. You have a chance to get 1 of 10 soundtracks to the Firefly video game that is getting ready to come out. The composer has been kind enough to donate, so we'd like to thank David Joseph Wesley for that donation to help induce people to give. We have coming in on Twitter a new offer. There is an amazing artist, the girl who does the Chuck the Squirrel. This is Chuck. We have Chuck the Squirrel image that we often use, our Chuck facts on Twitter. She has offered to do, and I'll get a photo of this to post out. She has offered to paint a pair of canvas all-stars. Your size, you get to pick your size. She will paint them with astronomy objects so you can have your custom astronomy shoes. These are kind of all kinds of awesome. We have, and those I think we need to put a minimum donation on. I need to work with her to figure out what that is. This is coming from @ceiling_cow on Twitter. She's awesome. We have 7 meteors to give away. Little tiny ones, they're awesome. We have 2 Indigo Night prints, 2 $200 gift certificates to iTelescope, 5 kids' books from Sarah Willis by Sarah Willis, Your Place in Space, 5 Surly Amy pendants. All of this is your incentive to give, to help us strive to hit that $36,000 level that will ensure we can keep everything going until hopefully we find out that we're funded, we're working on grants, we're working to make it so I no longer have to beg for money. But at this point, it's going to be probably October before any of those grants can be awarded. So will you help us keep everything going? Now, some comparisons you might not have thought about. We're trying to raise $36,000 in 36 hours, and that sounds like a whole lot of money to people like me who work in academia. But the truth is, to a lot of people, $36,000 isn't a lot of money. $36,000 is 2 Apple Watches, the gold editions, the ones that sold out in just a couple of hours. $36,000, it's 15%-ish of a seat reserved on Virgin Galactic to spend a couple of hours strapped into a spacecraft where you probably puke. CosmoQuest does not induce vomiting. And to bring up my arch nemesis one more time, there was a Kickstarter campaign to raise money for potato salad. This potato salad, my nemesis, it raised $55,000. Now, I personally think CosmoQuest does a lot more good for this world than any one potato salad recipe. But the internet, in its great and vast intelligence, well, it spent $55,000 on potato salad. And so far, how much has it spent on CosmoQuest? So far, we have brought in $26,746 for science. Can't you help us show the internet that science matters more than potato salad? We know most of you out there watching have already given. Thank you so much. It matters so much to me. Our average donation is just $30. That tells me there's so many of you out there, so many of you giving. Thank you. But can you get help from other people? This is the whole idea of crowdfunding, is we reach out, we use our networks. Everyone who follows me on Twitter just gave $2. I'd like to think maybe my Twitter feed is worth $2. If everyone out on my Twitter feed gave $2, we'd be done raising funds and we could just talk science. We're not there yet. Help us get there. Now, I'm going to stop talking for a few minutes. I have 2 new guests who have actually survived the crowdfunding process and come out the other side and made the world a little bit better in the process. With me are Chuck and Susan Rule from Telescopes to Tanzania. Welcome.
Thank you. It's good to be here, and it's been great to catch snatches of the hangout throughout the past day and a half. Although yesterday during the day was astronomy day and at our observatory, and so we were busy with that. But last evening we did catch the bedtime stories, and good work, and Fraser Crane's internet nightmare. So
oh my gosh.
So it is good to be here. Thank you.
Now, the 2 of you, you work with Astronomers Without Borders with the Galileo Teacher Training Program. It's, like I said, it's Old Home Day. We're bringing back the alumni of the International Year of Astronomy. You did, I think it was last year, an amazing crowdfunding program to literally take telescopes to Tanzania. Can you tell us a little bit about what you accomplished?
Well, we're very excited. We have a telescope donated, and we are in the process of building an observatory in Tanzania on the side of a mountain. And we did a crowdfunding to get the land and the materials to build the observatory. And we're working on getting that telescope refurbished and sent over to Tanzania.
Yeah, actually, some folks might recognize it's a classic Cassegrain made by Tom Cave, who was a great telescope maker back in the day, and also a real Mars astronomer in terms of the research groups doing work on Mars. And so this is a scope from the late '60s. That's being refurbished and ready to go. But also, besides the observatory, we also have helped to train and create a center for science that has ambassadors, that is, teachers in the schools there who are trained in doing interactive and hands-on kinds of activities in other schools, helping other teachers learn the process, and then also working with their students. And so the Science Center ambassadors just began this past February, and they're really enjoying going out and working. And some of the crowdfunding we were able to raise is helping to support that, along with a Office for Astronomy for Development grant that is supporting that work, because the International Astronomical Union has a commitment to sub-Saharan Africa. So it is great to see that happening, because Tanzania is there in the Horn on the east coast of Africa, and it's exciting to be a part of that.
And I think it's important to make sure everyone heard that right. It's the Office of Astronomy for Development. It's not that we're going into the developing world and teaching them astronomy. It's that we're using astronomy everywhere to develop our entire culture, to create a more scientifically literate world. And yes, there are so many places that need so much help, but astronomy helps everyone. And when you help the kids in Tanzania, when you work with the Ghana Planetarium, when you work with the Galileo Teacher Training Program, you're raising up our entire planet.
One of my favorite stories, Pamela, is when we were teaching teachers in Tanzania, and this probably standard 5 teacher came up to me and said, "Sounds to me like you are saying the sun is a star." And it was such a great moment, because I said, "Yes, that's what we're saying." And then she went, "Well, that will change my teaching." And the rest of that story is I've held that because it's been an example of just a one little thing, and she's going to have 30, 40, 50 students in a classroom every year that are going to hear a different story. But when we came back here, we went to one of our local schools here in Wisconsin. And with that in my head, we were in with second graders, and I realized that one of the teachers there had not been teaching that the sun is a star, that teacher in one of our second grade classrooms didn't know that.
And so
simple little things that change everything.
It's so amazing how much we have left that we need to teach. This is one of the things, all of us, we stretch every dollar absolutely as far as we can. We had Rosa Duran on earlier, and we were reminiscing about all the places in the world where we've crammed ourselves into little tiny hotel rooms with other folks, and we were there so that we could do teacher training in places where the teachers needed the training most. And sometimes that's here in Middle America.
That's right.
I was doing a teacher training with some other professors from my university a few years ago, and we had a teacher in class who was quite certain that America had never landed on the moon, and in fact humans had never been on the moon.
Yep.
And we had to step back and say, no, here are the Lunar Reconnaissance Orbiter pictures. you can see the footsteps. Not sure we ever convinced her, but I think at least she'll be teaching it a little bit different.
Yeah.
We do
That's been
everything
one
we
of
can.
that's been one of the opportunities I've had as I'm also a solar system ambassadors. That's the JPL NASA network of folks who do local outreach in schools and communities, and now I'm also an airborne astronomy ambassador in the SOFIA program, and so also doing more outreach in local schools. And it is exciting because we're bold enough to say that astronomy is the gateway to the sciences, because you can't think about astronomy without getting connected to math or physics or chemistry or biology. It's just it's the way it happens.
So I just wanted to say thank you. We just got a new $10 donation. Every $10, every $2, every dollar matters. We're sort of saying, hey, next week sometime, instead of going out to lunch, can you eat that thing that's hiding in the back of your pantry? I'm guilty of having Asian noodles I should have eaten by now. I'm going to eat my Asian noodles. Can you donate your lunch money? Can you donate your, well, I'm drinking coffee that was sent to us by one of our good friends at facebook.com/itsmyshow. He provided amazing coffee beans. But some of you, I'm sure, have spent your $4 for Starbucks today. How about giving those $4 to science? We do amazing things. You two do amazing things. I still remember the story of sharing the goat with a small village, and how you shared your science and shared a goat, and that was an amazing lesson to learn. As you go out, you get to be there when people see Saturn for the first time.
Yep.
What's the most amazing reaction that you've seen someone have first time they look through a telescope?
Well, I think particularly for students, they're just overwhelmed, almost speechless. Sometimes it's Saturn, sometimes it's Jupiter and those 4 Galilean moons. And I've had 200 students in line to look through a little Galileo scope and to look at those moons. And while they're in line, I have them chanting out the names of those four moons, so that they're learning some of the science they'll need to have to pass their Form 4 examinations while just being taken away. Usually they just can't believe that it's there. It's just one of those things that you can't believe it's real.
It's so amazing when they look through the telescope, because there's a cultural piece of assuming that they're not on the earth but in the earth. That's been a real conversation bit. There's something about being in this kind of ball of earth that when they look in a telescope, it breaks open, and they really just
gets you out of the dome, as it were.
and it's so fun. They have lots of questions.
And we often tell our students that the sky's not a limit, or the sky is the limit is what we often say. But with astronomy, the sky isn't the limit. We can look beyond.
Absolutely.
Galileo Scope, put together by our good friends Rick Feynman and Doug Arion, they made that happen with basically everything save for their blood. I'm sure there were lots of sweat and tears involved, hopefully no bleeding. They put that together so that people everywhere in the world could afford a telescope. The original goal was $10 a kit. Manufacturing costs, it turned out were a little higher than we had hoped. But now when you buy them in bulk, you can get them for often as little as $25 each. Mm-hmm. This is an amazing optical bench that allows anyone to make out the rings of Saturn. We have with Celestron a bigger telescope that they've put together working with Astronomers Without Borders that helps raise money to celebrate the fact that we are one people celebrating one sky. Telescopes help us get so far beyond our planet.
Yeah, that 5-inch One Sky that you just mentioned, that's the name of the scope that's available from AWB, is a primary teaching tool we use in Tanzania now. we've been fortunate to be able to carry those in. We'll be going again in July, and we'll have another one or two packed into our check-in luggage, and it's a sturdy instrument. By at least 3 different times, I have packed those scopes up, wrapped them up in bubble wrap inside of a suitcase, and KLM has gotten it those 8,000 miles to Tanzania, and I take it out and put it together, and it's still holding collimation.
Go ahead.
No, it's just a great instrument.
and I have to say that the Galileo scopes kind of are your perfect kids first telescope. I am a terrible klutz at times. I tripped going down the stairs carrying a Galileo scope, and rather than me pitching face forward down the stairs, I kind of let the telescope fly and braced myself on the walls, and the telescope flew and it sprung-load itself apart, and bits and pieces of optics went everywhere. They are explosive devices at times. They're held together with elastic. But once I gathered all of those pieces together and pulled the ponytail holder out of my hair to replace the broken O-ring, it worked. It was perfect. You can't break these things.
Yeah.
It was kind of
We all just take extra O-rings.
The climate in our part of Africa tends to degrade them after about a year. So we always bring in every year a fresh supply for the over 50 scopes that the Galileo scopes we've taken in. And we've got another 20 sitting in our garage, ready to go into check luggage each time we travel over.
So I strongly recommend your standard cloth-covered hair elastic as the perfect replacement O-ring for the Galileo scope. Something like 50 for $2.
That's right.
Now, unfortunately, because we are still begging for money, actually my laptop is starting to render. There we go. We are currently sitting at, we've had no new donations come in. Sadness. I see you out there tweeting. I see you out there listening. Thank you. I do want to thank all of the volunteers who've helped us this weekend. Thank you for showing up, for being guests. I love getting to work with you guys, and I wish I didn't have to beg for money and got to listen to you just talk, because you do awesome things. But you wouldn't be here if it wasn't for, I think Susie Murph probably reached out to contact you. Susie Murph, who I actually have managed to forget to mention until now. Susie Murph has been out there, a huge help. Fraser Kane covered in the midnight hours. Mike Simmons, whose name I'm determined to mispronounce forever. He is dear to me, even if I can't get his last name straight. He gave us a 2-hour break and did an awesome 2-hour discussion earlier today. This entire hangout has been made possible thanks to an awesome green room staff. We have Richard Drum, Jim Meeker, Nancy Graziano has been making awesome comments, and awesome potato salad self-publishing menu guides to help raise money to keep CosmoQuest going into the future. So many people have done so much to help make this possible. Jeff Notkin kind of is both my hero and the source of my arch nemesis, because he's one of the people that helped the potato salad of $55,000 fame come into existence. But he's kind of making it up. If you donate $2,000 or more, he will grace you with an awesome palisite meteorite slice, polished and gorgeous inside of a lucite pyramid. We know most of you can't give that much. We've had 2 donations that size so far, and all I can say is you guys overwhelm me with your generosity. But to all of you out there who are doing science 1 image at a time and donating your lunch money $4 or $5 at a time, you matter just as much. And for every dollar you give and every image you annotate, we have a variety of door prizes that Corey Leon is working on software to help us give away in our final hour. We have, switching between pieces of paper, we have 10 Firefly soundtracks from a new video game coming out. These come to us from David Joseph Wesley. We have 5 Shirley Amy pendants, 5 books by Sarah Willis, Your Place in Space, 2 $200 gift certificates from iTelescope, 2 Indigo Night pictures showing the sky on a day of your choice in a place of your choice. We have 7 different meteors that we're giving away. So much thanks. You guys are doing so much good, and I wish I could give all of you something, but what I can do is send you an email. And on Monday, everyone who gives, everyone who participates, one by one, I'm going to work my way through, and it may take me till Tuesday. I'm going to work my way through and personally thank you from my inbox to yours. Thank you, all of you who've been part of this. Matt Woods out at Perth Observatory wrangling the Australians to help. All of you who've helped, thank you. Now, Chuck and Susan, how many times now have you been to Tanzania?
Well, this July will be my 7th trip. And typically we spend about a month. Partially it takes a bit of time to recover, making that distance trip and also the time shift. And so we move about throughout northern Tanzania, around the Mount Kilimanjaro area, and so we'll visit a variety of schools, secondary and primary schools, and take in supplies and resources, and also do sharing of teaching skills.
Pamela, we just wanted to say that it's been such an honor and a privilege to be with you today that we would like to pay for this honor and privilege. So as soon as we are off, each of us will send, or together, we will send $100. So we'll send $50 each. There'll be $100 just because you have had us on your show today.
and you may have forgotten, but that little graphic there of the telescope to Tanzania symbol is something you helped design.
So thank you.
I did do that. That was really my pleasure. We all have our ways to give back. I don't always have donations that I can give, but I'm always happy to help with website design and graphics. That's kind of my thing that I can give away. So it's been my pleasure to help you as much as I can. I couldn't give to your Kickstarter as much as or your crowdfunding as much as I wanted, but I could do a logo. And if you ever want to update your logo, I will gladly update your logo for you.
Thank you. We challenge others to join us.
Yeah, to match our 100 and make this a successful campaign.
Thank you so much. It has been so wonderful to have you on. We are now at 5 hours remaining. We are sitting at we have had, over 5,000 images annotated over at CosmoQuest today. You're doing a great job doing science, and you continue to do a great job with your donations. We have had, since I last looked, another $5, $50. I'm going to guess this one started in euros because no, it's someone getting me my 42 cents back. Thank you. We had a donation of $4.42 because 42 cents gets us 42, which is the answer to life, the universe, and everything. $30. Every little bit matters, and I thank you so much for all the bits that you're giving because they all add up. We are currently sitting at a total of, trying to figure out how to use my computer, we are currently sitting at a total of 26,865. As I've said, we'd like to get to 36,000. I don't know if we'll do it, but I'd like to try. And we can try if we do this together. We can succeed. We're going to go after I ask these two wonderful folks if they're still here. I can't see if they're still here. Okay, I'm going to ask you guys to give our audience one final message. Before I do that, I'm just going to tell everyone we're about to go to, we're about to go to our final Uncle Bob video. Maybe we may go to one more, but I think this is our last Uncle Bob video for a while. It's going to be the history of Earth. Before we cut away to that, Chuck, Susan, can you give our audience a message that you want them to walk away with today?
Science education. Science education. That's it. We need it here in this country and all over the world. We need to encourage the young girls and boys to be as excited about science as we can possibly get them to be.
That is a beautiful message. Together we can create a more educated society. And this is what we're working on together.
Yes.
It's such a pleasure to be in the same community that you're in and be working towards the same goals. Thank you so much for joining me today. It's always a pleasure to get to speak with the two of you, and I can't wait to hear your stories from your next trip to Tanzania.
Thanks. Okay, take care now.
Bye.
Thank you.
Bye.
So we're now going to cut over to The History of the Earth by Uncle Bob.
They say that grandchildren are the dessert of life, and this is one of my desserts. This is my granddaughter, Alexis. She is 11 years old. Look at those outstretched arms of hers. They measure just a little over 5 feet, 62 inches from fingertip to fingertip. Now imagine that's 5 billion years, roughly the age of the solar system. The solar system begins here, right at the tip of her middle finger. About 5 billion years ago, there was a molecular cloud about 60 light years in diameter just hanging out in space. It was 90% hydrogen, 8% helium, and 2% dust. That dust was the ash of millions of previous supernovae and was composed of every naturally occurring element, including oxygen, nitrogen, iron, silicon, gold, uranium, and all the others. Right here at inch 6, 500 million years later, a shockwave from yet another supernova slams into this cloud and causes it to fragment into thousands of little cloudlets, each a few light days in diameter. Some of these cloudlets are pushed past a critical density and begin to collapse into stars, and an open star cluster begins to form. One of the collapsing cloudlets in that cluster will become our sun. It takes 100,000 years, about the width of a hair on this scale, for the collapse to complete. During this time, the cloudlet spins faster and faster as it shrinks. The spinning flattens it. The dust particles in that disk collide and stick at first by electrostatic and chemical attraction, and later by gravity. Rocks form, then bigger rocks, then planetesimals miles in diameter. These collide with ever more force, forming the planets in our system. Meanwhile, the sun is starting to shine, not by nuclear fusion, not yet, but simply by the energy of its own gravitational collapse. But that's a lot of energy, and so the young sun is very hot and has a ferocious solar wind. That wind rapidly pushes all the dust out of the system, leaving the newly formed planets to fend for themselves. And fend they do. For 100 million years, just over an inch on this scale, the remaining planetesimals continue to bombard the newly formed planets, keeping those planets growing and molten. Halfway through this process, the nuclear furnace of the core of the sun turns on, and it graduates to a true main sequence star. Sometime during this period, a planetesimal the size of Mars smashes into the young Earth, melting it and splashing material into a ring. That ring forms into our moon. Then things settle down. The collisions end, the planets cool, and pretty much nothing else happens. But disaster is only 6 more inches away, 500 million years. You see, the giant planets, Jupiter, Saturn, Uranus, and Neptune, have been in a dance with each other. Jupiter moves inwards towards the sun, but is stopped when it reaches a 2-to-1 resonance with Saturn. That resonance drives Neptune far out into the vast reservoir of asteroids, causing them to plunge inwards, pummeling the interplanets and our moon once again. And so the Earth's Hadean eon, the first foot on this scale, the first billion years of our solar system, ends with the late heavy bombardment. But there's a silver lining. That late bombardment seems to have included a lot of ice, and so our oceans fill. As that bombardment ends at inch 15, 3.8 billion years ago, the first chemical evidence of life appears, oxygen. For we find the first deposits of banded iron on old seafloors 3.8 billion years ago. We believe this formed as photosynthetic cyanobacteria dumped oxygen into the atmosphere, causing the iron dissolved in the oceans to rust and fall to the bottom. Just past inch 18, 300 million years later, we see the first fossils of that cyanobacteria. Over the next 10 inches, or 800 million years, nothing much else happens other than the accumulation of more and more banded iron deposits on the sea floor. So long as the oxygen is getting grabbed by the iron in the oceans, it can't build up in the atmosphere. So the oceans simply continue to rust. Then, just past 28 inches, 2.7 billion years ago, all hell breaks loose in a massive global eruption. Not the first, not the last, but a big one nonetheless. Fortunately, life had a strong hold in the oceans, and not even a global volcanic catastrophe could stop it. Now, we pass the halfway point in the Earth's history and come to inch 34. It has taken over 1.5 billion years, but the oxygen produced by the cyanobacteria has finally rusted all the iron in the oceans. The level of oxygen in the atmosphere has risen to 18%. 100 million years later, at inch 36, we see the first hints of eukaryotes, cells with nuclei, and the evolution of complex life forms takes a tiny step forward. At inch 37, the first mountains begin to form. And then a huge 10-kilometer asteroid plows into the planet, leaving a 300-kilometer crater. At inch 40, another big meteor smashes into what will become Canada, leaving a 250-kilometer crater. But at inch 43, 1.5 billion years ago, modern complex eukaryotes show up. Life is on the verge of a revolution. And that revolution comes 300 million years later when sex is invented. Now we change our perspective and look at the final 12 inches, leaving the previous 50 inches and 4 billion years in the past. At inch 52, the Earth freezes solid. Ice covers the oceans to a depth of 1 mile or more. This likely happened several times, possibly due to the arrangement of the continents. But eventually this period passes and the Earth warms up again. An inch later, we see protozoans and worms. 2 inches further on, the first true arthropods, fungi, mollusks, sponges, and corals form, and creatures with bilateral symmetry begin to appear. 0.2 of an inch later, 542 million years ago, with only 6.7 inches left in our timeline, the diversity of life explodes into the oceans. Nearly all current phyla, including chordates such as squid and vertebrates such as fish, appear. Another 0.2 of an inch later, animals walk on land. Things are going to move very fast now, so we need to switch from inches to millimeters. The first breath of air is breathed 132 millimeters from the end. 6 millimeters later, insects appear. Another 27 millimeters, and reptiles are present. And then, with only 78 millimeters to go, the greatest extinction we know of took place, the Great Dying. 95% of everything dies. We speculate about volcanism and meteors, but we aren't sure of the cause. But life finds a way, because 9 millimeters later, the dinosaurs appear, and mammals show up 3 millimeters later. We are now 68 millimeters from the end. That's about the length of her middle finger, so let's zoom in again. Birds appear with only 49 millimeters to go. 8 millimeters later, the Atlantic Ocean begins to form. Bees evolve 9 millimeters after that. Antarctica splits from Australia 6 millimeters later. And the Tyrannosaurus rex appears 4 millimeters after that. We've got 21.5 millimeters left to go. A single millimeter later, 65 million years ago, all the dinosaurs are obliterated in a single stroke. A huge meteor smashes into Central America, wiping out the vast majority of life on the planet. But life is tenacious, and primates evolve within 2.5 millimeters, or 500,000 years. And now, with only 17 millimeters to go, Africa collides with Europe, and India smashes into Asia, raising the Himalayas. 5 millimeters later, cats appear. Then after 3 millimeters more, there are deer. Hominids appear 2 millimeters after that. Horses 2.5 millimeters later. And the human chimpanzee split just a single millimeter after that. There are just under 1.9 millimeters and 6 million years to go. The woolly mammoth appears within the next half millimeter. Then an early ancestor of ours, the Australopithecus, 1/10 of a millimeter later. The Isthmus of Panama closes with less than a millimeter to go, and the world enters the current ice age just 1/10 of a millimeter later. With just half a millimeter to go, Homo erectus uses fire. 3/10 of a millimeter after that, Yellowstone blows up, and Homo erectus moves to Europe. We are now 2/10 of a millimeter and 500,000 years from the present. Time to switch to microns. With 110 microns to go, Neanderthals evolve. 16 microns later, wolves appear. 30 microns later, modern men are in Africa. We've got 200,000 years to go. 50,000 years ago and 16 microns later, mitochondrial Eve, the mother of every human alive, is born in Africa. 11 microns later, the most recent glaciation of the current ice age begins. Within 8 microns, the Y chromosome Adam, the father of every man alive, is born in Africa. With only 75,000 years and 24 microns to go, the super eruption of Mount Toba darkens the skies and worsens the ice age. Humans barely survive, perhaps just a few hundred. But those who do leave Africa 5 microns later and create cave paintings in France 6 microns after that. 6 microns later, with just 30,000 years and 9 microns to go, dogs evolve and Neanderthals go extinct. A micron later, the diversity and quality of human-made tools and clothing explodes, and humans migrate into North America. A micron later, the first computer, a tally stick, is used. 4 microns before the present, the ice recedes. Jericho is founded a micron later. The next to last micron sees copper smelted, mummies in Egypt, the wheel, the extinction of the mastodon, the Sumerians, writing, and the beginning of recorded human history. A young girl, her arms outstretched as if to embrace the world. And yet everyone she ever knew, loved, or even heard about lived here, in the last 2 millionths of a meter at the tip of her left fingernail. To her, and to us, the dinosaurs lived at a time too remote to imagine, and yet in reality, they lived here, between the second and third knuckles of her finger. And so animals and plants are new things on the earth. Their time has just started, their era just begun, but not so for life in general, for life is old beyond understanding and fills almost her entire embrace.
Hello and welcome back to the CosmoQuest 36-hour Hangout-a-thon. Thank you so much to Uncle Bob for donating the use of his videos. You can learn more about what he does at cleancoders.com. It's an awesome resource for learning more about programming. They do neat training tutorials, and he has allowed us to take a few minutes off over and over and over again through the use of his videos, and we're very grateful for that. We are now to the point where we have 4 hours and 40 minutes left. We are sitting at, where are we? We crossed, while Uncle Bob was on, we crossed the 27,000 mark. We are left with $9,000 to go. We are trying to raise $36,000 in 36 hours. We are bringing you scientific guests from around the world, scientific educators doing amazing things to change this world. And we're asking you to be part of all of it. You can go over to cosmoquest.org, continue to watch this hangout side by side with Doing Science. And you guys are doing a whole lot of science. We're currently racing the world, and Vesta is pulling ahead with asteroid mappers ranking in at 1,894 images classified. Mars is slightly behind, well, more than slightly behind, 1,293 images complete. The moon is starting to pull ahead at 1,105, and Mercury is in last place at 1,083 images annotated. You can help us do science while you learn science. All we ask is that you share the love, that you tweet out what we're doing, get other people joining you doing science. Share it with your grandmother, share it with your kid. Don't share it with your cat, they don't have thumbs. But help us as we find ways to continue bringing you science for hopefully many more months and many more years to come. Now, we have joining us this hour, which is now more like this 40 minutes, we're sorry. We have joining us a digital artist, the president of the Chicago Society for Space Studies, a NASA JPL Solar System ambassador, and the vice president of National lobbying when I was a high school kid. Oh, and he's having audio problems, so I'm going to vamp for a few minutes. Joining us without them in a few moments is going to be Jim Plaxo. So while we work on fixing these problems and getting things working a little bit better, I'd like to thank all of you who helped make this possible. I've been spending all of my time lately working on applying for federal grants to help keep our projects going beyond what we're able to do with this Hangout-a-thon. And I knew that I couldn't organize this Hangout-a-thon and do right by you with my grant writing at the same time. So I reached out to some pretty awesome people. Susie Murph kind of came and became my savior, working alongside Christy McGonnell to get things going. We worked with Astronomers Without Borders, where Mike stepped in and, well, he hosted the Hangout a little bit this morning. We had Fraser Kane in the midnight hour, and helping us on the other side has been Nancy Graziano, Richard Drum, Jim Meeker, Matt Woods, and so many more. Thank you so much for everything you have done. You have made this possible. And all of you out there, Thomas Traniker marked over 3,000 craters. Thank you so much, Thomas. Everything you do makes everything we do a little bit easier. Now, Jim, you're someone that, especially with the work you did for the National Space Society, you've been very aware of just how hard it is sometimes to find a way, to find the means to keep doing science. But I know the National Space Society has been there advocating for us all along, and thank you for your term as VP.
Oh, thank you very much. It's great to be here.
So you're coming down from, I believe you're in Chicago right now?
I am. Schaumburg, which is one of the suburbs.
Very, very cool. So we are 5 hours south of you. People always assume state of Illinois, you must be near Chicago. No, there's a whole rest of the state. We're down outside of St. Louis. So you've gotten to be part of a lot of really awesome different NASA programs. NASA Solar System Ambassadors has got to be one of the most amazing things out there, working to help train educators all across the United States. Can you tell us a little bit about some of the things that you've gotten to do over the years?
Actually, one of the first most interesting experiences I had, and this predates the NASA JPL Solar System Ambassador Program by quite a few years. I got to serve as a tour guide on a pair of tractor trailers, or a couple of semis that were basically mock-ups of the International Space Station. And it spent some days here in Chicago outside of the Adler Planetarium. And my memory as a tour guide on that exhibit is always going to stick with me for one reason in particular. And that was people's response to the tour and the nature of their response. The two modules that were a part of the simulation, one was the habitation module and one was the laboratory module.
Was this back in the day when it was still the Space Station Freedom, or was this after it had all merged into the International Space Station?
Excellent question. It was Space Station Freedom at that time. And I'm trying to remember if this was before or after the major 92-93 redesign. It was, I believe, shortly after that. But families would come in and they would be very excited, asking a lot of questions in the habitation module, because people are able to relate with that. How do you cook in space? How do you eat? How do you sleep? And of course, the classic, how do you go to the bathroom in space? So this was an aspect of space exploration that people could directly relate to because it was something that they had experienced in their own lives. I lay down in bed at night to go to sleep. How does an astronaut go to sleep? However, that enthusiastic inquisitiveness largely vanished once we made our way into the laboratory module, because on the whole, people are not familiar with working as scientists, with being in a laboratory, with conducting experiments. So for me, I remember it was particularly challenging trying to maintain people's level of interest in space exploration at that level. And we see that even today with respect to media coverage of the suborbital market. It seems that every media piece that comes out that's talking about either X-Core or Virgin Galactic focuses on the space tourism aspect of their business, while ignoring the fact that these vehicles are also going to be very important platforms for carrying out a wide variety of space-based experiments, or I should say microgravity-based experiments, because right now there's a hole in the market for experimenters who need time in a microgravity or / weightless environment.
And this actually kind of makes sense. And I'd like to thank the people who we got a few more donations in. We're now at $27,075. We have 4.5 more hours to go to reach $36,000. And we can do this with your help. And unfortunately, money is what motivates this lack of discussing the science that we see coming from a lot of these commercial space agencies. They're not going to make a lot of money on science because, let's face it, us scientists don't have that much money. And we contract things out to the lowest bidder because we don't have that much money. But people who want to go to space as tourists, this is an amazing and emerging audience where if we keep saying, hey, space tourism, people with money are going to start to think, hey, maybe I should plan my next $1 million vacation, not going to a remote island off the course of Africa, but maybe going on a remote trajectory up to above 100 kilometers off the surface of our planet. If those commercial space agencies can keep selling those tickets, that's venture capital that allows them to, well, have a little bit of money that us scientists just can't give them as they're working to develop their technologies.
Yeah. Well, the companies, the private companies that are engaged in this, the important thing to remember is, okay, they get media attention via the tourism angle, but there are a lot of businesses and universities that would like to be able to conduct microgravity experiments. particularly whether it's in the pharmaceutical industry, the material science industry. But there are severe constraints, one of the big ones being, of course, the cost constraint. To the extent that the suborbital industry is able to significantly lower the cost of carrying out experiments, you could see a real boom for scientists in the area of researching in their particular field what happens when we eliminate gravity from the equation. What new insights are we going to gain into, for example, certain physical processes? And so the higher flight rate that these companies are able to maintain, that allows them to scale up, begin to get economies of scale, and lower their price further. And that creates something that's referred to as a virtuous cycle, with success feeding upon itself.
And I don't know how many of the members of our audience remember this, but back in the days prior to Challenger, this was actually one of the arguments that was used for the space shuttle. Back before that horrible day in January of 1986, they were working towards being able to have multiple space shuttle launches every month.
Well, actually, that was in order to sell the space shuttle program to Congress and to the president. NASA was marketing the program as a space truck that would be routine access to space. It would feature two components: a very high flight rate. Initially, they were talking about flights of up to 50 a year, but that once they decided on the external tank, that was a foregone conclusion. That would never happen because the Michoud facilities, they were only going to be able to turn out 24 tanks a year. So that becomes a cap. And the other thing was a dramatic lowering of the cost. So on those two key points, the shuttle program was a failure if you focus only on those 2 points. And that one reason that the cost has not come down is because the U.S. government has continued to use the experiment practices which drive up the cost. And we're seeing now the first glimmer of sunshine with the commercial crew and commercial cargo programs that are able to escape the shackles of federal acquisition regulations.
But I think it is important to remember this is a goal that we've been trying to reach for a long time. One of the major reasons that they did invest in building the space lab that fit inside the cargo hold of the space shuttle. This was the laboratory that they took up. It gave them extra space to work in. They came back down. After Challenger, they couldn't fly this anymore. They didn't allow the space shuttle to land carrying cargo after that unfortunate incident. But prior to that, I remember reading all these amazing goals of the crystals grown without having to adhere to the side of the container, which is something that unfortunately happens here on Earth with crystal growth. We were looking for newer, pure chemicals. Hopefully, in this pristine environment, we'd be able to find the cure for cancer. This was the argument that was used. This goal has been around for an awful long time. It's been around, well, since I was in elementary school. And now finally we're working towards actually achieving that goal. And the space shuttle did fail on many different points, but I mean, the poor thing was technology that was put together at the time of Gemini and never really updated as much as one would wish. My iPhone has stronger computing power than the space shuttle had, but still it flew for a lot of years.
There was significant ongoing technological upgrades that were being made to the shuttle throughout the program. But the problem is you had this huge infrastructure in place that was necessary to support what was arguably the world's most complex transportation vehicle. And on many fronts, the space shuttle was a remarkably successful vehicle. But if your primary interest is in achieving routine access to space on demand and a significantly lowering of cost, then the space shuttle program was a particularly strong hindrance in the other days when, as a part of the marketing to get the shuttle program approved, it was decreed that commercial satellites would also be launched on the space shuttle. And this just gutted the domestic launch industry, because if you're a business, you cannot compete with your national government in the provision of services. So for one of the good things that, one of the number of good things that did come out of the unfortunate Challenger accident was a redirection of, or a restatement of U.S. space policy such that commercial payloads would no longer.
I'm going to cut in. I'm sorry. One of Joe, who's sitting in the corner, just very quietly went 30,000. We have hit $30,675,000.42. That 42 cents just brings me joy. We have gotten a donation for $3,600. We have had another one of Jeff Notkin's amazingly, absolutely gorgeous Palisite slices laid claim to, and we have had more science enabled. We now have 4 hours and 23 minutes to go, and we only need to raise $5,400. We can do this. We're catching up. The end is in sight, and we can hit our goal because, well, people like you out there, you've helped, you've donated. If we hit $36,000, I will do more than my desk happy dance. I've been doing a desk happy dance pretty much the whole happy. But whenever we catch up, I end up doing a desk happy dance. We shall have a moment of excited random, I'm a scientist and a white person who really, I clearly grew up in northern latitudes, bundled in lots of clothing, incapable of free movement, because that's how I dance. A lack of ability to dance if we hit $36,000. And as I've said before, I'm personally going to write you a thank you, my inbox to yours, to every single person who gives and every single person who does science. This is absolutely amazing. Thank you. Thank you. You know who I'm saying this to, and you know all of you out there from the $4 to the $3,600. I love all of you, and you give me hope that we can make this world better. We can make this world more scientific. For those of you who are just turning in, who are just seeing all of our tweets going out on all the different who are seeing all of the Twitters, all of the Facebooking, all of the tumbles, and all of the Google Plusing. I don't know quite what the verb is for that anymore, and are just joining us. This is the CosmoQuest 36-hour hangout-a-thon, in which we are trying to raise $36,000, and we are trying to accomplish science. If you're not watching at cosmoquest.org, you are wasting a chance to do science. We have rearranged our site for this event, making it possible for you to map out other worlds while you hear this hangout-a-thon. Helping us has been a myriad of amazing, amazing volunteers. Susie Murph, when I realized I was in over my head trying to plan this, kind of stepped in and helped out. Alongside has been a weekly space hangout crew with Guido Bibra, Nancy Graziano, Jim Meeker, Matt Woods, Richard Drum, so many of you. I'm going to screw up and miss names. We had Mike on from Astronomers Without Borders, who made it possible for me to take time out to eat breakfast this morning, who covered my job for 2 hours. We had Fraser at the midnight hours, and we've had so many of you out on social media. And more than that, we've had so many people well, offer to give. We have one of my favorite authors so far, and I think we may be able to pull up. Can you pull up Ceiling Cow's awesome Canvas All-Stars, and then we'll switch over to that tweet. So Ceiling Cow, who does at ceiling_cow, who does our Chuck the Squirrel graphic that we tweet out from CosmoQuest periodically. She's a college student, and she's an amazing artist. And she will paint a pair of Converse All-Stars in your size if you give. Oh, let me see. We haven't figured out how much you have to give. How much you have to give? Huh? 300. If you donate more than 300, you will be entered in to get these Converse All-Stars between 300 and 2,000 if you haven't already gotten one of the awesome Jeff Notkin side help outs. We have 5 Surly Amy pendants. I'm wearing one of hers right now. This is I forgot the science term. It's basically fractal. It's a Mandelbrot pattern. That's what it is. Joe, can you come take Chuck up to the camera for me? This is more work by Surly Amy. I'm going to have 2 of these. And this is more representative of what you're going to get. Surly has donated. Amy Davis Roth has donated some straightforward pendants like the one not on the squirrel. We have 5 of those that we're going to be giving away. Sarah Willis has donated 5 of her kids' books. You can stop, Joe. Thank you. Sarah Willis has donated 5 of her kids'
We're switching. Okay, I got it.